Hello, dear friends, and welcome. So in this first video, I'm going to give you a rundown of what's the content of the course. This is prepared for candidates of the CompTIA Linux Plus XK0-005 certification exam. If you were looking for the 007 certification exam, that's still being prepared by Q. So what do we got going on here? Well, this exam is to certify the knowledge and skill of Linux users in configuring, managing, operating, and troubleshooting. The exam will consist of a maximum of 90 questions, multiple choice, and performance-based questions. But here's the kicker. You're going to need to complete it in a total of 90 minutes. You got to know your stuff. Now, in this exam, a candidate must achieve a score of 720 to be considered successful. Not impossible. For this exam, the subjects are going to be grouped under 4 main headings, and the percentage of each group in the exam is represented here in the table. System management, 32%. Security, 21%. Scripting, containers, and automation, 19%. Troubleshooting, 28%. So let's break all that down. What does it really mean for you? Well, the first main heading here is system management. So under this heading, we're going to talk about Linux fundamentals, files and directories managing, configure and managing storage units, configuring and using processes and services, network tools, and installing software and software configuration. Next up, the second main heading is called security. So it's under this heading we're going to explain the purpose and the use of security in a Linux environment, implement identity management, implement and configure firewalls, and apply access controls. Up next will be scripting, containers, and automation. So all under this heading, we're going to talk about creating simple shell scripts to automate common tasks, perform basic container operations, perform basic version control using Git, common infrastructure as code technologies, container, cloud, and orchestration concepts. After all of that, you should be ready for the fourth and final topic, troubleshooting. So it's under this heading we're going to explain, analyze, and troubleshoot storage issues, network resource issues, CPU and memory issues, user access, and file permissions. Also, we're going to talk about using systemd to diagnose and resolve common problems with a Linux system. So, Kali Linux is a Debian-based Linux distribution aimed at advanced penetration testing and security auditing. Kali contains several hundred tools which are geared towards various information security tasks, such as penetration testing, security research, computer forensics, and reverse engineering. Kali Linux is developed, funded, and maintained by Offensive Security, a leading information security training company. Now, we're going to use Kali as the attacker system. However, if you don't want to use Kali for whatever reason, you can download the tools that we use and install them to your host machine. So let's download it and install it as a virtual machine on our host system. So I'm going to prepare the Kali VM directly from the VirtualBox image first. The first step is to download the VM files. Open the browser and simply Google the words Kali and download. The first website is the official site of Kali, so click on it. This is the download page of Kali. These are the ISO files. You can use them to install Kali as the main host or as a virtual machine in any virtualization platform. Now, these are the images that you can use to install. With the latest release, Kali Linux announced that the images have been restructured and simplified. So from now on, Kali Linux has new image styles: installer image, a live image, and a network installer image. Installer image is recommended for users who want to use Kali Linux on their system. No network connection is required. You can choose desktop environments such as XFCE, KDE, GNOME, and any other tools that you want to install during your installation. Now, the second one is a live image. So it's used to run Kali without installing it. And the last one is a network install image. The smallest image, of course, to download, containing only enough to install the base system that requires a network connection to install selected applications. At the bottom of the Kali image files table, there are ready-to-use, well, almost ready-to-use Kali virtual machines. So if you're going to use Kali as a virtual machine, you can use them instead of installing ISO files from scratch. Click this link under the Kali Linux VirtualBox tab to download the OVA file. So the second step is to install Kali. Well, since we'll use the OVA file, it'd be better to say import for this step. And the download's finished. It's under the download folder. Now I'll open a VirtualBox interface, choose import, and choose the OVA file under the download folder and click continue. So as you can see, there are the suggested settings of VirtualBox for the imported virtual machine. RAM is 2 gigs by default. Now just click import and agree to the license agreement in order to continue. And it starts to import. It may take a couple of minutes. So I want to look at the size of the empty space on my host. df command simply displays the free disk space, and -h parameter makes the result human readable. Now I have 140 gigabytes of free space, and that should be plenty for this installation. Installation's finished, and this is the summary of the VM. RAM is 2 gigabytes by default, and if you have enough RAM on your host system, I suggest you increase it. Networking is NAT, just as I want. Now just click on the Start button. Okay, the virtual machine could not be started. So I wonder about the details of this error, don't you? Okay then, so to fix this problem, we'll need to install the Oracle VM VirtualBox extension pack. So I'll copy this part, and I'll just search on the web. So now let's look at the official site of VirtualBox. We can download it under the title of Oracle VM VirtualBox extension pack. So we'll just click on this link and save the file. And it quickly downloads. So let's open the file and click install. And again, I'll accept the virtual license agreement. And finally, enter the password to complete the installation. And now it's been installed successfully. So now I'd like to go to the Preferences and double-check the extension packages. And everything is okay. Good. So now we can start again. Okay, so our Kali is booting for the first time. Click Switch for the full screen mode. And here we are at the login screen. Now, in addition to the changes that I mentioned in the previous lecture, there is another important change in this Kali 2020.2 release. The default user account is now a standard unprivileged user. Kali is no longer using the super user account root by default, right? So the new default credentials are Kali and Kali. And welcome to Kali 2020.2. Now, normally the screen resolution automatically fits your particular screen, but if you have any resolution problems like I appear to be having, you can change the scale for your screen. So first, I'll just open up the display settings, and I can choose the resolution value to be 1920 by 1200 and click the Apply button. Now go to Preferences, and under the Display tab, you can change the scale factor. So I'll set this value to be 190% of my screen, and you can change it to whatever you want and just try different values for your screen. All right, so I'll click OK. Now let's look at the changes. Yeah, that's pretty good. So let's open a terminal screen and check the network connection. When I run the ifconfig command with standard user privileges, I will get an error because the ifconfig command is under the sbin folder and requires root privileges. So why don't we have a look inside that sbin folder? As you can see, I can run the cd, pwd, and ls commands without sudo. These commands do not require root privileges. However, the commands that are under the sbin folder must be run with sudo. Ifconfig is here, and let's run this command with sudo. And it's okay now. Of course, there is a more practical solution. We can always switch the user to root so that we don't have to write sudo for every command that requires root privileges. So let's run sudo su. Okay, so I'm root now, and I'll double check that with the whoami command. Well, now I can run any command which requires super user privileges without sudo. And this is my IP address. If ifconfig didn't obtain an IP address, that means that you have a problem with your network configuration. It's not a problem. Problems do occur, and I certainly will give you some solutions to fix any possible network problems in the next lecture. So now we're on the last step. Fix the problems and run Kali. Now in this lecture, I will assume that you do have trouble with network connections, and I'm going to give you some solutions so that you can fix the problem. Now, hopefully you're not facing such a problem, so if you don't have a network situation, please, you don't have to apply any of these solutions in this lesson, but it's good to have you on the ride, and you can always sharpen your troubleshooting skills. So first off, let's reboot the machine to understand whether the problem is an exception for the initial run or not. So I shut down the virtual machine because I want to look at the settings of it. Now select Kali and click the Settings button and click the System tab. I want to make the RAM 3 gigabytes. So now I can click the Start button to boot it again. Username and password are both Kali. Okay, we are in again. So let's check the network connection by clicking the network icon at the upper right-hand corner. So I think there's a problem on the DHCP of the VM. Well, anyway, we can live without DHCP as well. So I'm looking at the wired network. Don't be confused, even though you share the wireless connection of your host machine, it's simulated as a wired network in the VM. So let's open a terminal screen and look at the networking service if it's running. Write Service Networking and press Tab twice to see the available commands of the service. Networking service does not have status command, so I'll assume that it's not started and try to start it. And if you are still not connected at this point, let's go to Network Settings. You can go to Network Settings via Advanced Network Settings under the menu. Or you can right-click on the network icon in the upper right corner and select Edit Connections. Now click the wheel icon under the Wire tab. Okay, I go to the IPv4 tab to set the IP manually. Click the Manual option. I'll choose an IP for the new Kali. Now the IP block of my virtual network is 10.0.2.0 through 24, so I'll choose an IP from this block. Netmask is 255.255.255.0 for a 24 IP block. The gateway is 10.0.2.2. So I can use Google DNS as my DNS server and route. Now you can click the Save button. Okay, I'll reboot the machine to be sure that the changes are applied. Boot completed. So open the terminal screen and first type sudo su to switch the user to root so that you don't have to write sudo for every command that requires root privileges, and then run the ifconfig command to see the IP address of Kali. And it's 200. So let's ping a remote system, for example, Google DNS 8.8.8.8. Yes, we received the response packages. The network's okay now. So to double check, open a browser and visit any website. So the Linux operating system comprises several different pieces. Bootloader, the software that manages the boot process of your computer. For most users, this will simply be a splash screen that pops up and eventually goes away to boot into the operating system. Kernel, this is the one piece of the whole that is actually called Linux. The kernel is the core of the system, and it manages the CPU, memory, and peripheral devices. The kernel is the lowest level of the OS. Init system. So this is a subsystem that bootstraps the user space and is charged with controlling daemons. One of the most widely used init systems is systemd, which also happens to be one of the most controversial. It is the init system that manages the boot process once the initial booting is handed over from the bootloader. That is grub or grand or unified bootloader. Daemons. So these are background services, printing, sound, scheduling, etc., that either start up during boot or after you log into your desktop. Graphical server. So this is a subsystem that displays the graphics on your monitor. It's commonly referred to as the X server or just X. Desk environment. This is the piece that the users actually interact with. There are many desktop environments to choose from: GNOME, Cinnamon, Mate, Pantheon, Enlightenment, KDE, XFace, etc. Each desktop environment includes built-in applications, such as file managers, configuration tools, web browsers, and games. Applications. So desktop environments do not offer the full array of apps, right? Just like Windows, Mac OS, Linux offers thousands upon thousands of high-quality software titles that can easily be found and installed. Most modern Linux distributions, we'll talk about this more below, will include an App Store-like tool that will centralize and, simplify application installation. For example, Ubuntu Linux has the Ubuntu Software Center, which is a rebrand of GNOME software. But anyway, it'll allow you to quickly search among the thousands of apps and install them from one centralized location. Who doesn't like that? Now, a shell is a user interface for access to an operating system's services. So in other words, if the user wants the operating system to do something, they will then use a shell for this purpose. It's a command language interpreter that executes commands read from input devices such as keyboards or even from files. So in general, operating system shells use either a command line interface, CLI, or graphical user interface, GUI. Command line shells called terminal in Linux and Mac OS, or command prompt in Windows. Graphical shells provide means for manipulating programs based on graphical user interface, or GUI, by allowing for operations such as opening and closing, moving, resizing windows, as well as switching focus between windows. Now, it's named a shell because it's the outermost layer around the operating system kernel. A kernel is a computer program that is the core of a computer's operating system, with complete control over everything in the system. So it'll manage the following resources of the Linux system: file management, process management, input-output management, memory management, device management, etc., etc. Now, there are several shells for Linux, such as TCSH, KSH, and ZSH. But one of the more common ones is Bash, where the name is an actual acronym for Born Again Shell. So each shell does the same job, but it understands different commands and provides different built-in functions. So the screen shows a $sign or hash on the left of a blinking cursor while you're in a command line environment. The $sign and hash symbols indicate the user account type that you're logged into. The $sign means you are a normal user. Hash means that you are the system administrator or root. Now, in the C shell, the prompt ends with a percentage sign. The tilde means home directory. That is the default directory when first logging in. Now, there are differences on prompts in different Unix or GNU Linux distributions because of their default settings. But in general, the prompt usually shows the login username, machine host name, and current working directory, and ending with a $sign, percentage, or hash sign. So desktop environment is the first thing you're going to see when your computer is ready for you to use. Windows and Mac users will usually find the concept confusing because both of these operating systems come pre-installed with their desktop environments, right? But with Linux, you can actually select and install any desktop environment that you want to place on your system. I'll show you some of the best desktop environments. GNOME is easy to use, a clean and modern desktop environment that's a bit minimalistic, I would say, compared to other available Linux desktop environments. GNOME is well known, and it's one of the most useful and best Linux desktop environments for Linux users. XFace, or XFCE, is one of the most lightweight desktop environments out there. So if you have an old computer and you need to have more free memory for other applications, XFace is very suitable for this. KDE is one of the most popular desktop environments. Now, you may also refer to it as the Plasma desktop. Plasma offers all the tools required for modern desktop computing experience, so you can be productive right from the start. Now, Unity, I would say, is probably one of the best-known versions of the Linux desktop. It was a former default interface for Ubuntu. From Ubuntu 17.10 to the GNOME desktop environment has become the default interface instead of Unity. So it looks modern and offers good filtering features. So in the previous lecture, we saw the most popular Linux desktop environments. Throughout the course, I'll be using Kali, which is a Debian-based Linux distro. With the latest release of Kali, you can choose desktop environments such as XFace, KDE, GNOME, and the tools that you want to install during installation. So I selected the XFace desktop environment, and in this lecture, I want you to look around and see what you think of the graphical interface of Kali. So we'll start with the menu of Kali. So it's on the top left corner. You can see your favorite applications or folders from right here in the Favorites folder. You can reach the recently used applications. And from settings, you can change default settings for different processes and services which are running on Kali. As you can see, there are lots of different categories. Kali distribution is created for advanced penetration testing and security auditing. So it contains several hundred tools which are geared toward various information security tasks such as pen testing and security research. You can find all the necessary tools associated with these categories. All right, so let's continue with the next one from the panel. So this is the home folder of the current logged-in user. This folder is also located on the desktop. So let's have a look inside the folder. There are documents, downloads, music, pictures, public, templates, and videos folders in the home directory. The file system contains all the folders on the Linux system. And then over here on the left-hand side, you can change the directory to the most commonly used directories. But for now, we'll close this folder and continue. This is the terminal screen, also known as the shell or command line. So on the File tab, you can change the terminal settings such as appearance, behavior, shortcuts. This is the record screen tool named Kazam. You can take screenshots or even record the entire screen. On the top right of the menu, you can see here the date and the time, the network connection, configurations, and power management. From the lock icon, you can lock the session. And then finally, you can log out of Kali from here. You could also restart, shut down, suspend, and you see what else. All right, so just a quick look at the user interface of Linux. Of course, you will observe it in greater detail as you continue to use it. All right, so the Linux file hierarchy structure defines the directory structure and directory contents in Unix-like operating systems. It is maintained by the Linux Foundation. / represents a root folder. All files and directories appear under the root directory, even if they are stored on different physical or even virtual devices. Only the root user has the right to write under this directory. So /bin, essential command binaries that need to be available in user mode. For example, cat, ls, cp, etc. /home, the user's home directories containing saved files, personal settings, and all that kind of stuff. /sbin, Linux commands located under this directory are used typically by system administrators for system maintenance purposes like rebooting, ifconfig, that kind of thing. /boot contains bootloader files. For example, grub files are located under /boot. /etc, and you may have heard /etc. This will contain configuration files required by all programs. For example, resolve.config. /lib, these are libraries essential for the binaries in /bin and /sbin. /dev, essential device files, including terminal devices, USBs, or any device attached to the system. For example, /dev/null. /opt, this will contain optional application software packages. /proc contains information about system process and kernel. /mnt, temporary mount directory, where sysadmins can mount file systems. /var, it contains variable data like system logging files and temporary files. /media, mounts points for removable media such as CD-ROMs and the like. /tmp contains temporary files created by system as well as users. /srv contains site-specific data served by this particular system, such as data and scripts for web servers. /user contains binaries, libraries, documentation, and source code for second-level programs. The second topic that we'll pick up in Linux fundamentals is basic boot process. All right, should be enough for now, so let's get started. So you probably know by now an operating system can be defined as low-level software that manages resources, controls peripherals, and provides basic services for other software. You will see the Linux login prompt shortly after pressing the power button on your system. So this time may vary, especially depending on your particular hardware system. But what's going on behind the scenes from the moment you press the power button until the Linux login prompt appears? The answer to this question can be explained in 6 different stages. All right, so we'll start with the first stage, and this is called Basic Input-Output System, usually referred to as BIOS. Now, when you turn on your computer, it's the BIOS that does the power-on self-test. So this process is the same with other operating system types as well. It just aims to check that the existing hardware is still working properly. Now, if the post fails, the boot will not continue. If the post is successful, it loads the first boot sector it finds containing a valid master boot record, MBR, into RAM, and then control is transferred from the boot sector to the loaded code. The boot sector is really the first stage of the boot loader. There are 3 bootloaders used by most Linux distributions. We've got Grub, Grub2, and Lilo. So Grub2 is the newest of them. Also, it's used much more frequently these days than the other older options. But anyway, to put that briefly, the BIOS loads and executes the master boot record, MBR bootloader. All right, then we get to the second stage called UEFI. So most of the modern motherboard manufacturers have come up with a system where they can communicate with the user way more easily instead of the classic BIOS. The system, which is abbreviated as UEFI, is the abbreviation for Unified Extensible Firmware Interface. That's why we say UEFI. This can be thought of as an embedded operating system running on the motherboard. See, with UEFI, we can access all parameters that we can reach via BIOS. A user-friendly interface will help us achieve all of this. So let's examine some of the terms that we're using now. The first term will be MBR. So MBR, it's the abbreviation of Master Boot Record. MBR is located in the first sector of the bootable disk. It's responsible for loading and executing the Grub bootloader. Now, on the other hand, MBR contains information too about Grub or Lilo in older systems. Okay, so now it's time for a term mentioned in our previous statements. It's called Grub. So this is used as an abbreviation for Grand Unified Bootloader. Now, this Grand Unified Bootloader is the typical bootloader for most modern Linux systems. Grub's splash screen is usually the first thing you see when you start a computer. It has a simple menu where you can choose some options. Now, if you have more than one kernel image installed, you can select which one that you want to use with the help of the keyboard and let the boot start. All right, so which installed kernel image will appear by default? Well, sure enough, as you may have guessed, the last loaded one will be selected by default. So the Grub's going to wait a few seconds for you to select an option. And if you don't, it's going to load that default kernel image. So in many systems, you can find the Grub configuration file at boot/grub/grub.conf or /etc/grub.conf. All right, so there's your briefing about Grub. I want to talk more about what's even more widely used, Grub2. So Grub2 is today the primary bootloader of choice for most current Linux distributions. Grub2 is the program that finds the operating system kernel and then loads the necessary data into memory. Grub2 provides the same boot functionality as Grub1, but Grub2 works like a mainframe command-based pre-OS environment. This provides more flexibility in the pre-boot phase. Grub2 is configured with /boot/grub2/grub.cfg. Then we get to the third stage, which is all about the commands. We'll begin with mkintrd. So this command actually creates an initial image used by the kernel for preloading the block device modules, such as IDE, SCSI, or RAID. So these modules are going to be needed to access the root file system. The other command is grub-install. So grub install command is the one that installs grub onto a device. This includes copying grub images into the target directory, which is generally /boot/grub. Now, on some platforms, it may also include installing grub onto a boot sector. For example, you can use grub-install-dev-sda as a command to install the bootloader in the MBR of the SATA hard disk. Well, let's have a look at some of the options of the grub2 install command. -v, or the version parameter, prints the version information and exits. --root-directory equals directory parameter. This installs grub images under the directory dir instead of the root directory. --grub-shell equal file. This is the parameter that uses file as the grub shell. The --force-lba parameter forces grub to use LBA mode even for buggy BIOS. And a --recheck parameter probes a device map even if it already exists. So this option is kind of unreliable, actually, and its use is strongly discouraged. Now, another great command that we're going to be using with grub2 is grub-mkconfig. So this command creates a new configuration based on the currently running system. So it gathers information from the boot partition or directory, the etc default grub file, and the customizable scripts in /etc/grub.d/. All right, let's have a little chat about some of these options of the grub2 makeconfig command. -o, -output equals file. This is the parameter that outputs the generated config to file. Default equals stdout. -v, this is the -version parameter, prints the version information and exits. Now, when you install a Linux distribution, it's going to ask you to install a grub bootloader. So why don't we just take a moment now and have a look at how to do this installation. Now, part of grub will be installed on the MBR ESP partition. The rest of the group is located in the /boot/grub directory of Linux distributions. Yeah, it's also going to look at all of the partitions to detect whether or not there are other operating systems installed. And if it finds other operating systems as a result of this process, it adds them to the group menu. All right, so let's talk about a few of the scenarios and when to use the update grub2 command. So the first of the scenarios could be to change the default boot order. The second scenario would be to change the grub config file /etc/default/grub in order to reduce default boot time. But I'll tell you this, grub2 needs to be updated in order to realize all of these requests. But there is another scenario here. It's the installation of more than one Linux distributions on the same machine. Now, we can perform our operations without installing grub2 for each Linux distribution. However, we can't forget that different distributions use different versions of grub2. So, in order to solve such a situation, what we'll need to do is just update the incompatible distribution. The command structure you can use in the update process should be in the form of sudo update-grub. All right, so let's have a look at a tool called Drcut. Now, according to Wikipedia, Drcut is a set of tools that provides enhanced functionality for automating the Linux boot process. It's used to create a Linux boot image, init ramfs, by copying tools and files from an installed system and combining it with a Drcut framework, which is usually found in the /user/lib/drcut/modules.d. Now, so far we've only talked about grub and grub2. However, some Linux distributions use a boot item called lilo apart from these two boot items. There's a small file system that's loaded by lilo and it's mounted by the kernel rather than the actual file system. It's called initrd.img. So the kernel mounts this file system as a RAM disk, runs /linuxrc, and then mounts to the used file system. Very cool. So our next topic is boot sources. So all operating systems require a resource during their initial installation. The first of these is known as a pre-boot execution environment, or PXE. and it's pronounced Pixie often. So it creates the environment for a computer to install an operating system over a network connection. So Pixie can be used quite quickly to install an operating system. It's convenient to use for both servers and clients. Now, the second of these is called booting from Universal Serial Bus. So this is the process of using a USB storage device to boot or boot a computer's operating system. It enables the computer hardware to use a USB storage stick to retrieve all basic system boot information and files. So all operating systems support the creation of a bootable USB drive that can be inserted into a USB slot to start a computer, server, or laptop. You'll just need to specify the boot order or specify your boot order preference with the keyboard keys. Now, the third of these is called booting from ISO. So this feature of Linux Grub 2 bootloader, you can boot Linux ISO files directly from your hard drive. All right, so this third topic that we're going to cover in Linux fundamentals is kernel panic. But don't panic. According to a recent Wikipedia article, a kernel panic, sometimes abbreviated as KP, is a safety measure taken by an operating system's kernel upon detecting an internal fatal error in which either it's unable to safely recover or continue to run the system would have been a higher risk of major data loss. So the term is largely specific, though, to Unix and Unix-like systems. And then the fourth topic that we talk about in Linux fundamentals is device types. So the first of device types that we're going to cover will be a character device. So these devices used for data transfer can only transfer one character per unit time. Now you may see many pseudo devices, -dev-null, as character devices. But these are not really physically attached to the machine, but allow the operating system to gain more functionality. The second of these device types is block device. So they transfer large data in fixed-size blocks. Examples of block devices are units that use data as blocks, such as hard drives and file systems. The third of these device types is special character devices. These devices are -dev-null, -dev-0, and -dev-urandom. Now, once more, going back to Wikipedia, you can see that in some operating systems, the null device is a device file that discards all data written to it, but reports that the right operation succeeded. So this device is called -dev-null on Unix and Unix-like systems. You can see also that -dev-0 is a special file in Unix-like operating systems that provides as many null characters as are read from it. One of the typical use cases is to provide a character stream for initializing data storage. Read operations from -dev-0 return as many null characters as requested in the read operation. Now, unlike -dev-null, -dev-0 may be used as a source, not only as a sink for data. All write operations to -dev-0 succeed with no other effects. However, -dev-null is more commonly used for this purpose. Now, in Unix-like operating systems, -dev-random, -dev-urandom, and -dev-arandom. These are all special files that serve as pseudo-random number generators. They allow access to environmental noise collected from device drivers and other sources. -dev-random is typically blocked if there was less entropy available than requested. More recently, and you can have a look below in the different OSs because they do differ, but it usually blocks its startup until sufficient entropy has been gathered, then unblocks permanently. -dev-urandom is a device that typically was never a blocking device, even if the pseudo-random number generator seed was not fully initialized with entropy since boot. All right, so we've got a new topic here. It's basic package compilation from source. So Linux, like many other operating systems, has package managers to make software installation that much easier for its users. But sometimes you will have to build a package from source. So when you want to fix a bug in software packages or change a package to meet your needs, Linux also offers solutions to these problems. The vast majority of Linux packages are free and open source. It's possible to customize or modify a piece of software to your liking. Also, since they are open source code, good architectural processes and practices and coding patterns can also be looked at in other software projects. So let's have a look at how you compile and install a package using source on Linux. So I'm going to just take you through step by step the entire install process. So we'll go to the first step. This is called installing the required tools. So for installing, a source code has to go through 3 stages. These are compile, build, and install the software. Linux provides all the necessary tools for these operations. But I'll tell you, most of the Linux software is written in C or C++ programming languages. And because of this, you'll need a C or C++ compiler. On the other hand, we must use a compiler like GCC, a builder like CMake, extra packages like curl and getx. Of course, it's possible to get rid of all of this confusion. Depending on the Linux distribution that you're using, a single command may also be used to perform the function of these tools, like we're going to get to in the next step. All right, so here we are. Next step is called downloading the package source code. So we use git package for installing, and we'll be installing the git package from the source. Git is preferred because it's widely used among software engineers and developers. You can find many packages that you want to compile on the official website of the respective package. You can download the source code files using the curl command line tool or something similar. Now here is the next step. It's called compiling the source code. So in this step, we'll need a source code management system that we call a Git. If it is not in our system, let's go ahead and download it and extract it to a folder. So in this case, its name will be git-2.34.1. Now, of course, the folder name will probably be different for you if you've downloaded a different version of Git. But it is oftentimes very useful to read the information files included in the installation package before software installation. So here the readme.md or install files are going to show themselves. So these useful files are located in the root directory of the source code. But if you want my opinion, the configure script is a way more important file than the others. So it's going to check the software dependencies for the package that you want to compile. And if the script encounters missing dependencies, guess what? It warns you with error messages. So you go ahead and run the script to configure and prepare your source code. The command will also generate the make files and configurations for the software that you are about to compile and install. All right, let's go ahead to the next step called building the software package. So the source code is structured and compiled. That means the next step is going to be to create the software by following these steps. So any necessary instruction on how to create the software package are actually contained in the make file. Use the make command, and after a short time, the compilation process will end. All right, so we'll move on to the next step called installing software package. Of course, if you've come this far, it means that you have successfully compiled and created the Linux software from the source code. So here's the last step. We can go ahead and install the Git software package that you just created from the source code. And this command installs the package by copying the compiler files to the correct locations on your PC. All right, so we've got another topic here. It's called storage concepts. And you may know storage is a process in which digital data is saved in a data storage device through information processing technology. So this storage is actually a mechanism that allows a computer to keep data temporarily or permanently. So I want to cover the concepts used to identify and manage storage devices in this section. We'll start with the concept of file storage. So it's actually a hierarchical storage methodology, which is used to organize and store data on computer hard drives or on network-attached storage devices, often known as NAS. In file storage, the directories and subdirectories form the hierarchy. The data are kept in files, And the files are also organized by folders. So when the operating system or a user needs to access a file, really the only thing that you or your computer system will need is that file path. All right, so let's move along and go to concepts of block storage. So this concept of storage is a technology that used to store data files on storage area networks, SANs, or cloud-based storage environments. Sometimes it's called block-level storage. But in cases where data transfer rate, efficiency, and safety are important, companies prefer block storage space. So in block storage, the data is divided into blocks. These blocks are also stored as separate parts by switching with a unique switch. Blocks can be stored in different systems, or data from different systems can be accessed due to the separation system. All right, so we can move along to object storage. This storage concept has a storage architecture to process large amounts of unconstructed data. You may often hear something called object-based storage. That's what we're talking about. This data does not conform to or cannot be organized easily into a traditional relational database with rows and columns. Moving swiftly along to partition types, we're going to examine partition tables under two main headings. One will be that MBR, or Master Boot Record. The other one is the GUID partition table, or GPT. But don't worry, I will explain where these two partition tables are used and how you can choose between the two. Now, once again, according to Wikipedia, the MBR, Master Boot Record, is the very first 512 bytes of a storage device. It contains an operating system bootloader and the storage device's partition table. It plays an important role in the boot process under BIOS systems. But also, the MBR is not located in a partition. It's located in the first sector of the device, physical offset 0, preceding the first partition. Now, the boot sector present on a partitionless device or within an individual partition is called a volume boot record, VBR, instead. In the MBR partition table, there are three types of partitions. First one of them is primary. Second one is extended. Third one is logical. So primary partitions can be bootable and are limited to 4 partitions per disk or RAID volume. Extended partitions can be thought of as containers for logical partitions. So a hard disk can contain no more than one extended partition. The extended partition is also counted as a primary partition, so if the disk has an extended partition, only 3 additional primary partitions are possible. In common usage, the numbering scheme is to create primary partitions, SDA1 to SDA3, followed by an extended partition, SDA4. Logical partitions on SDA4 are SDA5 and SDA6, etc. You can see those numbers. All right, so also according to Wikipedia, the GUID partition table, GPT, is indeed a partitioning scheme that is part of the Unified Extensible Firmware Interface Specification. So it uses globally unique identifiers, or GUIDs, or UUIDs in the Linux world. And these define partitions and partition types. So it's actually designed to succeed the Master Boot Record partitioning scheme method. And at the very start of a GUID partition table disk, there is a protective Master Boot Record, PMBR, to protect against GPT unaware software. So this protective MBR, just like an ordinary MBR, has a bootstrap code area which can be used for BIOS GPT booting with bootloaders that will support it. All right, so if we do need to compare GPT and MBR partition tables, we're going to see many advantages of GPT. I mean, MBR is an old partition style. It's been used since MS-DOS, but doesn't mean it doesn't work. But the GUID partition table, or GPT, excels in reliability and performance, using the latest advances in formatting tools. All right, so now it's time to talk to you about Fuse. File system in user space. So this is a software interface for Unix and Unix-like computer operating systems, which lets non-privileged users create their own file systems without editing any kernel code. The Fuse module provides a user-friendly interface environment for accessing real kernel interfaces. So now I want to cover RAID. RAID is an acronym for Redundant Array of Independent or Inexpensive Disks. So we could define RAID as combining multiple separate and mostly small-sized disks in a row, and these sequential disks form an array, and each one is called a member of the array. There are different ways it can be used to align the disks to form an array, and these different paths are called RAID levels. So RAID levels are chosen based on their characteristics. For example, some are chosen for fault tolerance, which is the ability to recover from one or more disk failures, some for performance, showing the change in read and write speed of the entire array, and some for capacity of the array, which is determined by the amount of user data that can be written to the array. The array capacity may not always equal the total capacity of all the disks, and it should be noted in that array. So there are three main methods of storing data in the array. First of them is striping. This method is designed to split the data stream into blocks of a certain size, and then write those blocks, one by one, to RAID. This method affects data storage performance. The second method is mirroring. This method is a storage technique in which identical copies of data are stored simultaneously in RAID members. This type of data placement affects fault tolerance as well as performance. And the last method would be parity. This method is a storage technique using striping and checksum methods. It's based on accompaniment. So certain parity functions calculated for the data blocks. When a drive fails or is out of use, the missing block or blocks are recalculated with the checksum method, and RAID fault tolerance is provided. All current RAID types are based on striping, mirroring, parity, or a combination of these storage techniques. All right, so you ready to find out how a Linux user can access hardware information? Linux administrators in particular need to know the right information about the hardware platform that they're using. Well, this information will be crucial in correctly installing compatible software as well as the hardware components that are used. So to provide system and hardware details, Linux has both built-in and easily installable commands that its users can readily keep on hand. Now, I want to show you some of the commands that are used in Linux to let you know everything about your system. Yeah, so you're going to use the command line terminal, and you'll be able to get all of your hardware information that way. So the first command is uname. Now, this command is actually short for the Unix name. And this command is used to print operating system and hardware information via the command line. Another great command is lshw. So this command is short for list hardware, lshw. Okay, so it's a command line utility used to print information about your system's hardware component. So it's going to fetch information like CPU type, speed, disks, memory, bus speed, firmware, cache, all kinds of things from /proc files. And we've got another one. It is lscpu. So this command fetches detailed CPU information from the /proc/CPU info and sysfs files. Next command is lspci. So this command is utility on Linux systems used to find out information about the PCI buses and devices connected to the PCI subsystem. Now, one of them is lsusb. This command is short for list USB, and this command is used to list all the USB devices that are attached to your Linux system. Another useful command is dm IDE code. So we can use this command when we want to extract all of the hardware-related information of your system. This command will change your processor, RAM, BIOS, etc., and it contains information about. When it comes to CPU ID, this instruction deserves a separate value from the others. So here we are with our next title, System Management, and our second subtitle, which is Manage Files and Directories. So the first topic that we're going to cover in Manage Files and Directories is file editing. While file editing, we're going to be using some of these commands. Here's some new ones for you. So one of them is the sed command. The sed command in Unix stands for Stream Editor and can perform many functions on the file, such as searching, finding and replacing, adding, deleting. Although the most common use of the sed command in Unix is for substitution or find and replace. See, using sed, you can edit files without even opening them. So it's a much faster way to find and replace something in a file than to first open that file in a visual editor and then replace it. So here's the syntax of sed. Sed options, triple dot, open square bracket, script, close square bracket, open square bracket, input file, triple dot, close square bracket. Another useful command is awk. So this is a script language for manipulating data and generating reports. The awk command programming language requires no compilation and allows a user to use variables, numeric functions, string functions, and logical operators. So awk is a utility that allows a programmer to write small but effective programs in the form of expressions that describe patterns of text. Each line of a document can be searched for and actions to be taken when a match is found on a line that can be defined. awk is mostly used for pattern scanning and processing. It searches one or more files to see if they contain lines that match the specified patterns and then performs the associated actions. All right. So let's have a look at what else can we do with awk. So with the awk command, you can actually scan a file line by line, split each input line into fields, compare the input lines with the pattern, and perform operations on matching lines. But also, awk is a useful command for transform data files, produce formatted reports. And also, the awk command is suitable for programming constructs. Formatted lines are also suitable for use in arithmetic and string operations, as well as loops and conditions. So here's the syntax of awk. Awk options single tick selection underscore criteria. Then you put your action between curly braces, single tick, input dash file, right angle bracket, output dash file. And then we've got another command here, printf. So it's this command which is used to print data to the screen in a formatted way. It's also used in programming languages such as C and C++. So we've got it here in Linux to display the string, the number, or any other format identifier given with the terminal window. So I'll show you the syntax of printf. Printf square bracket dash v var, close square bracket, format, open square bracket, arguments, close square bracket. Now, have you heard of Nano? Well, Nano is a simple and user-friendly text editor. Unlike other command line editors, for example, Vim, it doesn't have any mode. It has an easy-to-use GUI, or graphical user interface. It allows users to interact directly with text, although it switches between modes, just like the Vim editor. So Nano is usually included by default in many Linux distributions. But if it's not installed, you can easily install it yourself just by using these commands. Just like we can install with sudo apt update, which is a command group, we can use the command group sudo apt install nano for Debian and Ubuntu and yum install nano for CentOS and Fedora. So our other command line operator is VI. So the VI editor is an interactive text editor. You can use it to create and modify text files. It is also the only text editor you can use to edit certain system files without changing the permissions of the files. Now, the Vim editor is an enhanced version of the VI editor. And we're going to use the VI command when we click to use the VI editor to create, edit, or view files. Syntax of the VI command goes like this, VI, so this command runs the editor. or VI file name. If the file named file name exists, the first page of the file will be displayed. Now, if the file does not exist, an empty file and screen will be created in which you can enter text. Because right now we're going to talk about file compression, archiving, and backup. As with all other operating systems, file compression, archiving, and backup are features that are used in Linux distribution for, guess what? File compression, archiving, and backup. The first of these is gzip. So this command compresses each file into a separate file, and the compressed file consists of a zip header and deflated data. If a given file has an argument, gzip compresses the file, adds a .gz for the suffix, and then deletes the original file. With no arguments, gzip compresses the standard input and writes the compressed file to the standard output. So here's the syntax of the gzip command. Gzip, open square bracket, options, close square bracket, and between two square brackets, file names. Now, let's talk about another well-known compression utility, zip. See, zip is a compression file packaging tool for Unix. Each file is stored in a single .zip file name, of course, with the .zip extension. So zip is widely used to compress files to reduce file size, and it's also used as a file package utility. Zip Unix, Linux, Windows, etc. are available on many operating systems. Now, the zip program itself puts one or more compressed files together with information about the files into a single zip archive. An entire directory structure can be packaged into a zip archive with just a single command. Now, especially for text files, it can compress up to 75%, as well as protect files without compression. The program allows large files to be distributed and packaged as a series of files and transferred securely. So it also helps you save disks by archiving unused files or directories. And we've got some syntax for the zip command. Zip, and in square brackets your options, zip file, files _ list. So what about the differences between gzip and zip, and when to use which? So gzip is much better than zip in terms of compression, especially when compressing large numbers of files. But remember, when working with gzip, it's necessary to archive all files in a single tarball before compressing. Now, when you're doing zip, individual files are compressed and then added to the archive. So when you want to extract a single file from a zip file, the file is simply extracted and then compressed. To make this work with gzip, the entire file must first be compressed. And as you can see from this usage, it's pretty clear that when extracting a 1 megabyte file from a 10 gigabyte archive, it's going to take a lot longer in gzip than in zip. Now, the downside of gzip could actually be an explanation of gzip's advantages, because the compression algorithm in gzip compresses one large file instead of multiple small files. So it can take advantage of the redundancy in the files to further reduce the file size. So I'm going to just show you a brief comparison, and maybe you can extract the difference yourself. So let's archive and compress 10 identical files with zip and gzip. So you're going to see that the resulting zip file is actually 10 times larger than the gzip file. Now I'll show you another command. It's bzip2. So it's another command that's used to compress and decompress files in Linux. It helps to link into a single file that takes less storage space than an original file, right? So it has a slower decompression time and higher memory usage. And each file is actually replaced with a compressed version of the file, with the original name followed by the bz2 extension. So here's the syntax of bzip2. bzip2, and in square brackets, options, file names, _. So why don't we just take a look at some of the options of this command. So the first option is -z. And this option is used for further compression of the file. So an example here would be the command group bzip2-z filename.txt. Another option here is -k, and you can use this one when you don't want to delete the original file. An example of that command group would be bzip2-k filename.txt. There's another option, -t. So you use this when you want to check the integrity of the file and confirm whether the file is corrupt or not. Now, the purpose is not to actually open the file. And an example of that would be command group bzip2-t filename.txt.bz2. And we've got another option. It is -v. You might be familiar with the verbose mode. This shows the compression ratio for each process file. So it also increases the level of detail. It sheds a lot of information of interest, primarily for diagnostic purposes. An example of that would be the command group bzip2-v filename.txt. But I mentioned earlier another archiving method. Let's dive into that one. It's called tar. So this command is used to create, archive, and extract the archive files. So this tar command in Linux is actually one of the most important commands because it's going to provide you archiving functionality. So we can use a Linux tar command to create compressed or uncompressed archive files, also maintain and modify them. And the syntax of the tar command goes like this: tar, with your options, archive-file, file, or directory to be archived. And again, there's a few options for this command. First of which would be -c, and this means create an archive. Another one of them is -x. So this means extract the archive. The next one is -f. This means create archive with the given file name. And the last one I want to cover is -t, which means display or list files in the archived file. So I also want to show you a new compression command. This command, like I said before, though, compresses and decompresses a file specified with the command xz. If no file name is specified in the xz command, the command reads data from standard input and writes the data to standard output after processing the data. So xz can compress or decompress one or more files at the same time, and it normally removes the original file after compression and removes the compressed file after decompression. And you can keep both compressed and uncompressed files just by using some of the options. The syntax of the xz command goes like this: xz filename.sh. Now the command compressed and created the compressed file named filename.sh.xz. But after compression, xz is the command that also deletes the original file. So we could also use this command if we need multiple file compression for this. It would just be enough to give us space between the two files. Okay, so what can you do if you want to decompress a file? Well, when you decompress any file with the xz command, as you do with compression, it's going to delete the compressed file after decompressing. And we'll need to use the -d for a parameter to decompress a file. So we can open our file using the command group xz-d filename.sh.xz. However, the filename.sh.xz will be deleted at the end of the process. Now, another command which is used for archiving is cpio. So cpio just simply means copy in, copy out. It's used for processing archive files such as tar. So this command can copy files to archives in or out of archives, right? Copy in, copy out. So the syntax of cpio goes like this: cpio-o, left angle bracket, name -list, right angle bracket, archive, and in parentheses for copy out, close parentheses. cpio-i, left angle bracket, archive, and in parentheses for copy in. cpio-p, destination-directory, left angle bracket, name list, and in parentheses for copy destination directory. All right, so now we can talk about the last command of this stage. It is dd, or double D. The primary purpose here is to convert and copy files. This command can also read or write to volumes, such as special device files and device drivers in Linux. So in other words, D can be used for tasks such as backing up the boot sector of a hard drive and obtaining a fixed amount of random data. All right, my friends, so now it's time to discuss file metadata. So in terms of Unix or Linux file systems, metadata is information about a file. So this information includes file owner ID, permissions, file type, and disk blocks used by the file. And all of these are kept in a disk structure called an inode. So in order to obtain file information, we'll examine a couple of different commands. The first is stat. So we're going to start with the tostat command. So this command shows you way more detail than ls on Linux. We'll have a look at what we can do with this configurable utility. If you're wondering what information you can learn about a file, well, this data will include the name of the file, the size, number of file system blocks it needs for storage, the size of a file system block, file type, device number, hard drive ID, inode number, file permissions, user ID, and owner's account name, group ID, and owner account name, access timestamp, modification timestamp, and the original creation date of the file. The second command of this stage is file. Let's have a look. So this command is used to determine the type of a file. So you can use this command to test each argument in order to categorize it. You can do 3 different tests with this command. First test is file system test. And the program will verify if the file is empty or if it is some kind of special file. This test actually causes the file type to be printed. Second test is magic test. And this gets used to check files containing data in certain and fixed formats. The last test would be language test, and this looks for specific strings that can appear anywhere in the first few blocks of a file. Oh yeah, by the way, here's the syntax of the file command. File, square brackets option, square brackets, file name. All right, so it's time to introduce you to soft and hard links. As you may know, links in Linux are like pointers in programming languages. So they point to a file or directory. So it's kind of a shortcut to create a link or access a file. So the first one up is hard links. Each hard linked file is assigned the same inode value as the original. Therefore, they refer to the same physical file location. If they happen to be deleted, they will continue to work. See, these links are more flexible. The original or linked files remain mounted even if moved across the file system. But hard links cannot traverse different file systems. Hard links have actual file content, you see. Removing any link only reduces the number of links, but it does not affect other links. Hard links also work fine even if we change the file name of the original file. The size of any hard link file is the same as the original file, and if we change the content in any hard link, the size of all hard link files gets updated. Now, the disadvantage of hard links is they cannot be created for files in different file systems and cannot be created for specific files or directories. So when we want to create a hard link, we will use the command set like this. IN, in square brackets, original file name, in square brackets, link name. I mentioned to you another kind of link, soft links. So you can think of the soft link as a shortcut in the Windows operating system. So unlike a hard link, each temporary linked file contains a separate inode value pointing to the original file. Now, similar to hard links, any changes made to the data in any file will be reflected in the other, but soft links can be linked between different file systems. But if the original file is deleted or moved, the soft link file will not work properly. You see, a soft link specifies a path to the original file instead of the content. So removing a soft link, well, it's not going to affect anything other than removing the original file. See, the link becomes a dangling link pointing to a file that doesn't exist. Now, unlike a hard link, A soft link can link to a directory. The size of the soft link is not dependent on the size of the file or directory its path points to. It's equal to the name of the file to which the soft link was created. So when you want to create a soft link, just use the command set like this. in-s in square brackets original file name, square brackets link name. All right, my friends, looks like it's time to have a look at copying files between systems. So why don't we just get started with the copy commands? So the first of these is going to be rsync. This command is short for remote synchronization, and it's a software utility for Linux that efficiently syncs files and directories between two hosts or machines. And here's the syntax of rsync. rsync in square brackets options, source in square brackets destination. So here's another command for the copy operation, scp. So this is the abbreviation for secure copy. All right, so in the Linux system, the secure copy command is used to securely copy between servers. Secure copy uses the same authentication and security used in secure shell protocols, SSH. Now, the most important features of the scp command are simplicity, being preloaded, as well as security. So here's the syntax of the scp command. It goes like this. scp in square brackets, option parameter, open square bracket, this is a double, user at, close square bracket, host1 colon, close square bracket, file1, triple dot, double square bracket, user at, close square bracket, host2 colon, close square bracket, file2. And as perhaps you can see from the syntax here, the scp command has some optional parameters. So let's have a chat about these parameters. First parameter is -p, or port. This is used to specify the port address to connect to the remote host. The second of the parameters is -p. That's a little p, and this gets used to preserve modification times, access times, and mods in the original file. Another parameter is -r. This is used to recursively copy all directories. The next parameter is -v, and this again means verbose mode. Prints any error messages encountered during the progress of scp and ssh. So these messages will make it easier to troubleshoot connections, authentications, and any configuration issues. So now it's time to learn a new command. This is nc. Yeah, the nc command represents the netcat tool. The netcat tool is, well, one of the well-known networking security and network monitoring tools. So this tool is often used for many reasons: port scanning, port listening, port redirection, network debugging, network daemon testing, TCP and UDP operations, open remote connections, reading, writing data on the network, as well as simple TCP proxies and others. This tool can be used directly or as a flexible back-end tool that can be driven by any other program. All right, so in this lecture, we're going to look at the components of Linux commands. So these are the examples of Linux commands. ls and ifconfig are command names. We're going to practice them with the next lecture, and you'll see how they work. But for now, let's examine the structure of the command components. /bin is an argument of the ls command. An argument, also called command line argument, can be defined as an input given to a command line to process that input with the help of a given command. So arguments are entered in the terminal or console after entering the command. They can be set as a path, so we could also write more than one argument together, and they will be processed in the order that they are written. Now, a parameter is an argument that provides information to either the command or one of its options. They are optional, and you're also free to use whatever parameter suits your particular needs. single character parameters are used with a single dash. More than one parameter can be used behind a dash, so ls-al can be used instead of ls-a-l. Now with double dash parameters, more than one character can be used, such as here, ls double dash help. So in this case, a new double dash must be used for each parameter. Make sense? So as a result, the first command lists the files and directories under the /bin folder with long format by showing permissions. All right. The second command displays the detailed information about the ifconfig command. The ls command is used to list files or directories in Linux and other Unix-based operating systems. Just like you navigate in your File Explorer or Finder with a GUI, the ls command allows you to list all the files or directories in the current directory by default and further interact with them via the command line. -a or ~all parameters lists files or directories, including hidden files or directories. So in Linux, anything that begins with a dot, that is considered a hidden file. -l lists the contents of the directory in a table format with content permissions, size of the content in bytes, and last modified date and time of the content. -h or ~human readable display size information with human readable format. -s or ~size, where s is lowercase, lists files or directories with their sizes. -uppercase s lists files or directories and sorts by date or time in descending order, or from biggest to smallest. Finally, -t is the parameter that lists files or directories and sorts by last modified date and time in descending order, from biggest to smallest. So let's go ahead and practice. So go to Kali, log in with the default credentials Kali and Kali. Open up the command line. Now you can change the font size from the preferences under the File tab. Click on Change. I'm going to set the size to be 14. Okay, so that's better for me. Now let's run the ls command with a help parameter and we'll be able to see some detailed information. So you can see the arguments, options, and parameters here, and you can use them when needed. They're all right here. So I'll show you some of the most common options. Now, and by the way, you can clear the screen with Control-L. So let's list all the files under the /user/bin folder with -al parameter. And as you can see, we find all the files, including the hidden files, with the long listing format. And these are the permissions and last modified date of the file. So let's look at the file sizes with the human readable format. And as you can see, the file sizes are more readable now. Now the next parameter is lowercase s, and it'll show you the total size and sizes of each file. And then finally, we'll use the t parameter, and it sorts the files and directories by the last modified date and time from biggest to smallest. All right, so in this lecture, we will see the pwd command. PWD stands for Print Working Directory. And as the name suggests, it prints the current directory. So let's go to Kali. Run pwd. Now, as you may remember, the tilde sign means the home directory, and you see that we are in the home directory of the Kali user. So why don't we change the directory to /user/share/nmap/scripts and list files. So now let's run the pwd command again. And as you can see, we now see the full path of the current directory. The man command. Man is the abbreviation of manual, so it gives detailed information about the named command, including name, synopsis, configuration, description, options, exit status, return value, as well as errors. Now, the manual is divided into multiple sections, so we can pass a section number as an argument to get a specific section of the manual for a given command. And this table shows the available sections. Section 1 is default. It opens the user command descriptions if no section is given. Now, if you run man password, it shows the manual of the password command. And if you specify the section number, for example, 5, it'll show the format of the file. All right, so let's go to Kali. Run man pwd to see the manual page of the pwd command. And there it opens section 1 by default. So just press Q to quit. So what if we run the man command? And of course it shows us the manual page of the man command. Say that 3 times fast. That's all right. You don't have to. Great. So obviously there's lots of detailed information about the man command, right? You can read through this at another time, but know that it's here. So this time we'll specify a section number. 1 is the default section, and it shows the user commands. So let's try to see section 5 of the password command. And as you can see, it shows the file formats and conversions of the password command. Now the cd command, or change directory command, this is used to change the current working directory in Linux and other Unix-like operating systems. It's one of the most basic and frequently used commands when you're working on the Linux terminal. You can specify the path of the directory, and in addition to that, you can change the directory with some special symbols. A double dot is a symbol for the upper folder. A single dot is the symbol for the current folder. So if you run cd double dot, it moves you to the previous folder. If you run the cd command without any parameter, it'll give you the home folder of the current user. cd tilde user moves to the home directory of the named user. And finally, cd single dash moves to the previous position. All right, so let's go ahead and practice it. So go to Kali, change directory to /user/share/nmap/scripts. And now let's check the current folder with the pwd command. Okay. So now let's move to the previous folder with a double dot. Cool, now check the current folder again. And as you can see, we have now moved to the upper folder. So let's go ahead and run the cd command without parameters and check the current folder. And you can see that we are in the home folder of the Kali user. Now, if we run the cd command with dash, we'll move to the previous position. And yeah, so let's see how we just moved back to the nmap folder. So let's go to the home folder again. This time use the tilde sign. Okay, great. Well, now we're back at the home folder again. The cat command is one of the most frequently used commands in Linux, Unix-like operating systems. The cat command allows us to create single or multiple files, view the contents of a file, concatenate files, as well as redirect output in terminal or files. That's where the cat command comes from, right? Concatenate. I didn't just trip over that word. Anyway, generally it's used to see the content of a text file. I'll just show you how it works, all right? So follow along. First, list files, and there are two different text files here. So let's check out the content of the my text file with the cat command. And these lines are written inside the text file. So if we want to add a new word or statement to this file, we can use a double greater than symbol. I'll just write the new line and quit with Control and C. So let's see the content of the file again. And as you can see, we've added one more line to the text file. So what if we only use one greater than symbol? So let's add in a new line again, run the cat command. Single greater than symbol overwrites the entire content with a new line we just added. That's powerful stuff. So let's see the content of the my text file 2 this time. So if we run the cat command with both my text file and my text file 2, we'll see the contents of both. Now, the echo command is one of the most basic, as well as frequently used commands in Linux. So it displays a line of text, and the arguments passed to echo are printed to the standard output. So let's practice it. Go to Kali, run echo path, and it displays a line of text on standard output. Now, if you want to display the variables, you'll need to add a $sign to the variable. So let's run echo $path. This time it shows the path environment variable that keeps track of certain directories in Linux. So hopefully you remember cat shows the content of the file, and there is a single line in the my text file. We can also add a new line to this file with the echo command. So run echo a new line double greater than my text file. Let's see the content. And there it is. It's been added. All right, so we showed in the cat command the single greater than symbol overwrites the entire content with a new line. Just remember that. And here we have the more command. That's used to view the text files in the command prompt, displaying one screen at a time in case the file is large, for example, log files. So if you press enter or space, it'll move to the next page. The line number specifies a line where you want to start displaying the text content, and you can press Q to quit. Let's go to Kali. All right, so we can open the syslog file because it's large enough to open with the more command. And it's under the /var/log folder. Oh, and we get permission denied. Okay, so it's an error. But as you remember, some commands, operations, or files require root privileges. And as a standard user, we won't be able to access these files, or we won't be able to, perform any of these important actions. So to change the user to root, just run sudo more/var/log/syslog, enter the password. Okay, so let's press enter or space to go to the next page. We can also see how much of a percent of the file that we've already read. And press Q to exit. So let's add a line number. If we add a number with a dash It'll display the 12 lines in a page. So it's add a number with a plus sign, and it specifies a line where you want to start displaying the text content. So it started displaying from line 123. So the head command is a command line utility for outputting the first part of the files given to it via standard input. Right? So it writes the results to standard input, but by default, head returns the first 10 lines of each file that it is given. You can add a number with the -n parameter to see the first specified lines if you want. You want to see how that works? I want to show it to you. So change directory to the /user/share/nmap/scripts. List files. And as you can see, there are lots of nmap script files. So let's run one of them with the head command. And it displays 10 lines by default. So let's specify a number with the -n parameter. Okay, so this time we see the first 20 lines of this file. Now, the less command is a command line utility that displays the contents of a file or command output, one page at a time. So you see how it's similar to more, but it actually has more advanced features. So you can search for a word in a file, move to a specific line, and it allows you to go both backward and forward within the line. So let's play around with that. Run sudo less /var/log/syslog. You can now press the arrow keys to go back and forward. So let's search for a database, for instance, right? /database. And yeah, there you go. It finds it easily. So now let's go to a specific line. I'll move to the 86th line, for instance. Okay, well, we cannot see the line number, but I believe that we are in the 86th line. All right, so just quit out of that. Here's the tail command, and it complements the head command, as you might imagine. So it'll display data from the end of the file. It'll write results to standard output, and by default, tail returns the last 10 lines of each file that it is given. It may also be used to follow a file in real time and watch as new lines are written to it. So to watch a file for changes with the tail command, just pass the -F option. This will show the last 10 lines of a file and will update when new lines are added. Hey, what about going to Cali? All right, so here we are under the /user/share/nmap/scripts folder. And let's just run any file with a tail command to see the end of the file. Okay, so if we specify the number, for example, 40, we see the last 40 lines of the file. Now let's follow a file in real time with -F parameter and see how it repeats every 2 seconds. It's very handy to watch log files that change regularly. And let's quit out of that by pressing Control and C. Now grep, this is a command, well, I'll tell you that grep stands for globally search for a regular expression and then print it out. So that's why we say grep. But the grep command basically searches a file for a particular pattern of characters, and then it'll display all the lines that contain that pattern. The text search pattern is called a regular expression. So when it finds a match, it prints the line with the result. The grep command is handy when searching through very large log files, for instance. The -i parameter is used to perform case-insensitive searches. You can use regular expressions with -e parameters. -r parameters can be used to read all files under each directory recursively. And then finally, the -v parameter. We use that when we want to select non-matching lines. All right, so let's give it a shot. Let's go to Kali. Let's read the content of the /etc password file. So this is a plaintext file that contains a list of the system's accounts, giving for each account some useful information like user ID, group ID, home directory, shell, and so much more. Of course, we could search for a particular pattern in this file. So let's run grep Kali /etc/passwd. And here, as you can see, it filtered the result containing Kali. So why don't we use a regular expression with the -e parameter? So Linux regular expressions are special characters which help search data and matching complex patterns. So if we add the caret symbol to the beginning of a word, it'll display the patterns that start with Kali. Now, to do a case-insensitive search, we can always add the -i parameter, and we'll capitalize the first letter of Kali so that we can see the result. Now, as you can see, the result did not change. It shows the patterns that start with Kali regardless of upper or lower case. All right, so now let's perform a recursive search. So we can search for OpenVPN under the /user folder recursively. We can also see the full path of the matched pattern. Now, if you want to select non-matching lines, you can just use the -v parameter. And it shows the patterns that do not start with Kali. So the command uname displays the information about the system. -a is the option that prints out all the system information. So I'm going to give it a shot, see what it looks like. Run uname, and it displays the operating system name. Let's add the -a parameter to print all available information. And of course, respectfully, as well as respectively, the output includes the kernel name, host name, kernel release date, kernel version, machine hardware name, and operating system name. Pretty cool, huh? Puts you in the driver's seat. So redirection is a feature in Linux so that when executing a command, you can change the standard input-output devices. The standard input device, of course, is a keyboard, and the standard output device is the screen. But check this out. A single greater than symbol is used to overwrite the output file with the result set. The double greater than symbol is used to append the result set to the target file. The single less than symbol is used to add the results as an input for another command. As you may remember, we practiced output redirection while running the cat and echo commands. I wonder if you noticed. Well, let's try it here and see if you recognize it. So first run echo hello world single greater than my text file. Now look at the content of the file. We overwrite the file. So this time let's use a double greater than symbol. And this time we add a new line to the text file. So let's use input redirection. So in the previous lectures, we looked at the etc/password file. and that contains a list of the system's accounts. There were some values on a line separated by a colon. Run cut-d:-f1 less than etc/password. So in the first command, we got the first values of each row with the -f1 parameter. We needed a delimiter to separate them, and we used the colon for this with the -d parameter. So we gave the etc/password file as the input to the first command by using input redirection. So, do you remember what this file looked like before? And as you can see, we extracted the first column of each line. So a pipe is a form of redirection, and it sends the output of one command to another command for further processing. So pipe is used to combine two or more commands. And in this, the output of one command acts as the input of another command. And this command's output may act as an input to the next command. It can continue, believe me. Now, pipes, it's important to note, are unidirectional, right? In other words, data flows from left to right through the pipeline. All right, so now you know all that. Let's try it out. Now, in Kali, there is an important file that stores the actual password in encrypted format for the user's account, with additional properties related to the user password. The name of this file is Shadow. It's under the /etc folder. So why don't we dig in and have a look at the content of this file? Oh, and of course it requires root privileges, so just add sudo to the beginning of the command. Okay, so these are the encrypted form of the user's passwords. Let's read the first 3 lines of this file with the head command. So we'll combine the 2 commands with the pipe redirection. So the output of the one command acts as an input to another command. Yeah. Okay, so now change the directory to the /user/bin folder. Run ls-l pipe grep my, and the grep command takes the output of $ls-l as its input. The net effect of this command is that the output of the ls-l is displayed one screen at a time. So the pipe acts as a container which takes the output of ls-l and gives it to the grep as input. So the mkdir, the mkdir, is a command in Linux that allows users to create or make new directories. Mkdir stands for make directory. So with mkdir, you can also set permissions. You can also create multiple directories or folders at once, and really so much more. You can also build a structure with multiple subdirectories using mkdir with the -p option. So why don't we just get into it and get practicing? Yeah. So go to Kali, and if you want to list files in a directory that doesn't exist, you're going to get this error message. So why don't we create the directory with mkdir? Change the directory to the temp folder. Now, if you want to create multiple subdirectories, you can always use the -p option. And we'll check the subdirectories using the cd command. All right, no problem. They were loaded under the temp folder. The touch command is a standard program for Unix and Linux operating systems that's used to update the access and modification times of the files to the current time. So a file argument that does not exist is created empty. All right, so why don't we try it out? Go to Kali, list all the files that start with my, and there are 2 text files, and these are their modification times. So let's change the modification time of my text file 2. We need to create a new file with the same name as this file with the touch command. And let's check the time again. And sure enough, its modification time was updated. So now let's create a new document. And you see how an empty text file was generated under the current directory. RM. It stands for remove. So the RM command is used to remove objects such as files, directories, symbolic links, and so on and so forth from the file system of Linux. The -R parameter is used to remove directories and their contents recursively. -D parameter is used to remove empty directories. -F parameter is used to ignore non-existent files and arguments. This command normally works silently, and you should be very careful, actually, when you're running RM commands, because once you delete the files, then you are not able to recover the contents of these files and directories. All right. But with that being said, let's see how it works. So list all the files that start with temp. As you can see, I've got 2 directories. The second one, temp1, is the folder that's empty. So first I'm going to try to remove the temp folder. Now when I try to remove non-empty directories without parameters, I'll get an error. That's a good thing. So if I use -D parameter for a non-empty folder, I'll get an error again. So I need to remove this non-empty folder with the -RF parameter that forces and removes directories, like I said, recursively. So let's list directories. Okay, that temp folder is no longer available. So we'll use the -D parameter to remove an empty folder named temp1. And we'll list the directories again. What? There's no directory that starts with temp? Good job. All right. The CP command. This is going to copy files and directories or copy multiple sources to a destination directory. The -R parameter is used to copy directories recursively. The MV command will move or rename files or directories, or it can move multiple sources and their files and directories to a destination directory. The -F parameter is used to not prompt before overwriting. So why don't we go to Kali and you'll see what I mean. We're going to practice. We'll first list the files. So we'll copy the mytext file to the temp folder. And as you remember, dot represents the current directory. Temp folder is under the current directory. And list files in the temp folder. All right, so here it is. So now go to the temp folder. We can rename this file with the MV command. List files again. And as you can see, we changed the name of the file. So we can move this file to another folder with the MV command as well. Let's move it to the home folder of the Kali user. Run the CD command without any parameter, and that'll take us to the home folder. List the files again. Okay, so these are the copied and moved files. They were actually the same files from the very beginning. So what do we have here? Let me look for, oh, right, it's the find command. Ha. Anyway, the find command is one of the most important and certainly frequently used command line utilities in Unix-like operating systems. It's used to search and find a list of files and directories according to the conditions that you specify for files matching arguments. It has a wide range of uses. For example, you can always search by names, permissions, search depth, logical comparisons, and the list goes on. But instead of listing, let's try it out. So after typing the find command and the location that you want to search in, you need to add -iname So this is a parameter to find files using their name and ignoring the case. So I'll search for all files that end with NSE under the root folder. Okay, so here we go. This is a great example because, as you can see, I get some errors because of permissions. Now, to find all files, I'll need to run this command with sudo. Okay, so now it's found all the files that end with NSE. This time I'll use a somewhat complicated command, or it's more complex anyway. Let's search some files under the root folder and use the max depth parameter. So the max depth parameter is used to specify levels of directories below the starting points. For instance, number 1 means that you're going to find a file under the root folder and one level down. So the command I wrote in parentheses finds folders that do not have 700 permissions. Make sense? Then finally, the remainder of the command lists these folders. Okay, enter. Of course, you need to run this command with sudo because you are searching under the root folder. And as a result of the search, this file with the permission of 600 was found under the root folder. Of course, there are many utilities available in Linux and Unix systems that allow you to process and filter text files. Cut is a command line utility that allows you to cut parts of lines from specified files or piped data and print the result to standard output. So it can be used to cut parts of a line by delimiter, byte position, and character. -F is the parameter used to select only specified fields. With a -D parameter, a delimiter is used to cut data. So, let's see how it works. Go to Kali, and the most common file to understand the usage of the cut command, I think, is /etc/password. So let's view the contents of this file again. As you can see, each data is separated by a colon. So that means that we can use the colon as a delimiter. Let's get the first fields of each line with the -F1 parameter. Okay, so this error is caused by the slash because password is a file, not a directory. So don't use the slash at the end of the file. Now let's delete it and run the command again. Okay, see how that works. We get the first fields of each row. So let's change the field numbers. You can select multiple fields just using a comma. And sure enough, we'll get the third and fourth fields of each row in the file. The first numbers are user IDs. The second numbers are the group IDs of the users. The chown command, or you may have heard chown. Either way you choose to say it, they're probably both acceptable. But anyway, the chown command changes user ownership of a file, right? Change ownership of a file, directory, or link in Linux. So every file is associated with an owning user or group. It's critical to configure file and folder permissions properly. Now, to change both the owner and the group of a file, use the chown command, followed by the new owner and group separated by a colon with no intervening spaces and the target file. So let's just practice it. First, list files with the -L parameters, see the permissions. And here you can see the owner and group of the mytext file are Kali. So let's change it. Run chown nobody:games my text file. Right. See, this operation needs root privileges. Of course, I knew that. I'm just showing you. Yeah. Then let's run this command with sudo. List the files again. And sure enough, I set the owner as nobody and the group as games. Now, you know, our first title here is System Management. Our third subtitle, Configure and Manage Storage. So the first topic that we're going to cover in Configure and Manage Storage is disk partitioning. Disk partitioning is the process of dividing a disk into one or more logical areas, commonly known as partitions, where a user can work with individuals according to their needs. So it's one of the parts of disk formatting, right? So when a partition is created, the disk will store information about the location and size of the partitions in the partition table. So each partition appears to the operating system as a logical disk, and users can read and write data on these disks. Control of these partitions is provided by the partition table. The most important advantage of disk partitioning is that each partition can be managed separately. So wait a minute, why do you need disk partitioning? Well, a simple answer would be in order to add a new hard disk to the system. You can also run more than one operating system on the same system. You can use the hard drive disk efficiently. Also to use different filing systems within the same system. Also to provide backup and security. Now, while partitioning a disk, we could use a command or instead a tool. So the most well-known of these commands is fdisk. It's also known as format disk. So it performs operations by establishing a dialog with the user during its execution. It's used to view, create, delete, modify, resize, copy, as well as move partitions on a hard drive using the dialog-oriented interface. This command allows a user to create space for new partitions, to issue new drivers, rearrange old drivers. It also allows you to copy or move data to new disks. And I'll show you the syntax of fdisk. It goes like this: fdisk, in square brackets, options, device, or fdisk-I, and in square brackets, device, triple dot, close square bracket. So let's check out some fdisk examples. So if you want to do something with your disks and partitions, you got to first view all available disks and their information. So for this process, you can use the sudo fdisk-I command set. So if you want to see a particular partition on a specific disk, you can use the sudo fdisk-I and in square brackets specific partition command. So in fact, let's go over to Kali and write sudo fdisk-I-dev-sda in the command line. And you see here the example we have implemented lists all partitions on -dev-sda. If you do want to see all of the fdisk commands, you can use sudo fdisk-dev-sda command set. Then after that, you're going to see a prompt. And if you press M, you can see all the parameters. Let's say that you want to create a hard disk partition. You can use sudo fdisk in square brackets partition for the command set. So why don't we go to Kali and write sudo fdisk-dev-sda in the command line. And after that, just type in N, and you'll create a new partition. Then type P for primary, type E for extended or logical partition, etc. And if you want to see the size of your partition, you can use the sudo fdisk-s in square brackets partition. Let's go back to Kali and write sudo fdisk-s-dev-sda in the command line. Now, as in other operating systems, formatting disks is actually very easy in Linux as well. However, formatting is a process that should always be done with the utmost care. A small mistake may cause major data loss or corruption in data. Now, you can format your drives according to your needs very easily just by making use of certain commands, basic formatting commands in Linux. In fact, there are graphical interface tools that you can use instead of commands. However, sometimes due to some problems with these tools, you may receive repetitive error messages, and you might not be able to format your drive. So this is where knowing a few of the commands come into play. So with a simple command, you can do all of this in the terminal, and I think it's a lot easier, safer, and quicker. So let's start with the lsblk command. So this command is going to tell you all about the devices connected to your machine. So if we go to terminal and run this command, as you can see, we've got information listed in columns. First column is name. So this column shows the name of the device. The other column is MAJ:MIN:. It shows major and minor device number. For example, SDA shows hard disk drive, specifies partitions on SDA1 and SDA2 devices. SDB stands for USB drive. So we said earlier that there are a number of tools for partitioning drives in Linux. Now let's get to know one of them and examine how the formatting process works using it step by step. So we're going to use the parted command in these operations because, hey, it's easy to use. We'll use the MBR partitioning, and parted also supports GPT partitioning, by the way. So we can use a USB stick for this example. So step 1 is opening the terminal and run the command set below. Sudo parted-dev-sdb. Step 2 will create the MBR and partition table to be used by MS-DOS. You may see some messages to check if you're operating on the correct drive for the partition. Enter ignore/y to bypass any of those warnings. mklabel MS-DOS. And step 3, the syntax for the partition command is mkpart, square bracket partition type, close square bracket, open square bracket file system, close square bracket, start, end. Now, if you want to use all this space and create one partition, just use mkpart primary ext4 1 big M I big B 100%. And then capital G capital B. Make sure you pay attention to the uppercase and the lowercase letters. Now, to create another partition, use mkpart primary ext4 2GB and 3GB. So here, 2GB is a starting point for this partition because it was an endpoint in the last one. And 3GB is the endpoint of this partition. You follow? And the endpoint can be changed according to what size partition you want. So here it's going to create the second partition of size 1 GB. For the fourth step, if you want to see the result of the partition, you can use the print command. So I'll display all the partitions that we've created. Number step 5, if you have checked the partition operation result and reach your goal, you can use the exit command. Okay. ISBLK is the command to show all the partitions. You can see the different types. NTFS, VFAT, BTRFS. All right, so when there is a change in the operating system partition table, for example, after parted, the operating system's partition table must reread, and the partition table changes must be reported to the operating system kernel. You can run part probe afterwards to make the kernel aware of the new partition configuration. See, part probe is a program that informs the operating system kernel of any partition table changes. The syntax of part probe command goes like this: part probe, and in square brackets, -D, again in square brackets, -S, and then in square brackets again, devices. So let's learn some more of the options of part probe. -D just means don't update the kernel. -S means show a summary of devices and their partitions. -H means show a summary of options. -V, show the version of the program. And now this next topic that we're going to cover in Configure and Manage Storage is mounting local and remote devices. So that means we've got to talk about systemd.mount. Now, if you've ever gone to ubuntu.com, You can read all about it. There's a configuration file with the extension .mount. So this unit actually encodes information about a file system mount point controlled and supervised by systemd. The typical configuration items are configured in the generic and install sections. The mount-specific configuration options are configured in the mount section. So these mount points, these are created at runtime independently of the unit files or /etc/fs tab. And these will be monitored by systemd and appear like any other mount unit in systemd. You can see the description in /proc/self/mount-info. Now, some file systems have special semantics like API file systems for kernel to user space and user space to user space interfaces. Some of them may not be changed via mount units and cannot be disabled. So let's talk about this mount. So files on a Linux file system are organized into a large tree with the root or slash. These files can span various devices depending on your partition table. And initially, your home directory is linked to this tree with a slash. Now, to mount it manually, you can use the GUI interface or the mount command if available. The mount command is used to mount the file system on a device with a Linux file system located at the root slash. If you want to unmount these devices from the tree, well, you can use another unmount command. And the syntax of the mount command goes like this: mount-t type device dir. So if you want to see the different uses of this command, I'll just show you quickly. Mount open square bracket -I pipe -h pipe -v capital close square bracket mount -a open square brackets -f close square brackets open square brackets -t close square brackets open square brackets -capital O close square brackets mount open square brackets -f close square brackets open square brackets -o close square brackets device pipe dir mount open square brackets -f close square brackets open square brackets -t close square brackets open square brackets -o close square brackets device dir. So the commands that you see in the examples tell the kernel to index the file system currently on the device. Anyway, one thing to note about this command is that if you don't use the dir part in the syntax, it looks to itself for a mount point in /etc/fstab. So you can use /source or /target to avoid those errors. So you would make the syntax like this: mount /target/mount point. Now /etc/fstab usually contains information about which device should be mounted where. Most of the devices are indicated by files like -dev-sda4. So now there's a few important options of this mount command to have a look at. -L means listing all the file systems that are mounted. -H will display options for the command. -V means displaying the version information. -a means to mount all devices described at /etc/fstab. -T means type of file system the device uses. -T means describe an alternative fstab file. -R means read-only mode mounted. All right, so why don't we go to Kali and do some examples. So first up, how can you display information about the mounted file system? Well, just use the command sudo mount -i -t ext4 or sudo mount -i -t fuse blk. So let's say you want to see how the file systems are mounted. You can check our next example. You can use sudo mount /dev/sd4 /media/media 2022. Sudo mount /dev/sd5 /media/media 2022. Sudo mount /dev/sd6 /media/media 2022 and then sudo mount-i-t ex4. And then sudo mount-i-t fuse blk. So let's say you want to unmount file systems. You can check out this example. Use sudo umount/dev/sd6, sudo umount/dev/sd5, sudo unmount/dev/sd4, and then sudo mount-i-t ex4. And then sudo mount-i-t fuse blk. Well, I wonder if you've ever heard of Linux Unified Key Setup. The abbreviation is LUKS, or LUX. So going back to the almighty Wikipedia, LUX is used to encrypt a block device. And the contents of the encrypted device are arbitrary, and therefore any file system can be encrypted, including swap partitions. Now there's an unencrypted header at the beginning of an encrypted volume, which allows up to 8 or 32 encryption keys to be stored, along with encryption parameters such as cipher type and key size. So the presence of this header is a major difference between LUX and plain dmcrypt, since the header allows multiple different passphrases to be used, with the ability to change and remove them with ease. However, if the header is lost or corrupted, the device will no longer be decryptable. Now, there are two versions of LUX, with LUX 2 having features such as resilience to header corruption and using the Argon 2 encryption algorithm by default, whereas LUX 1 uses PBKDF2. So when you use LUX, you have to use a reference implementation of the LUX. It's called crypt setup. For example, to encrypt a device with the path /dev/sda1, you can use crypt setup LUKS format -dev-sda1 for your command set. If you want to unlock an encrypted device where the name is the mapped device name, you can use crypt setup LUKS open /dev/sda1 name. Now, a port is basically a physical docking point, which is basically used to connect the external devices to the computer. Or we could say that a port acts as an interface between the computer and the external devices. For example, we could connect hard drives, printers to the computer with the help of ports. Now, like other operating systems, the Linux operating system also allows access to external drives, things like USB memory, external hard disks. But unlike Windows and Mac, external drives do not start automatically in a Linux environment. So first of all external drives have an identification tag on Linux. So before you can access a hard drive, you must find the device label. Although this process is very easy, it's a very important step. Now, if you want to find the label of an external hard drive, you've got to open up the terminal and execute the lsblk command. As you know, lsblk will list all connected drives. So if a hard drive is in use, you will see it in the terminal screen. And this is because the command always shows which directories the hard drive partitions are using. So the Linux operating system is usually installed in /dev/sda, mounted with /, and sometimes it can be installed on /boot and /home partitions. But you really should make note that all hard drives displayed in the terminal are labeled /dev/sdb. This label always belongs to the second driver. And then after that, each hard drive connected will be another letter in the alphabet. I also want you to notice that /dev/sdb1, /dev/sdb2, /dev/sdb3, and /dev/sdb4 in the screenshot. See, these let the user know that there are 4 partitions on the SDB hard drive. And the sizes of each partition are also listed in the list. All right, so we've arrived at the third topic that we're going to cover in our configure and manage storage. It's file system management. So it's within this topic that we're going to talk about XFS tools, EX4 tools, and BTRFS tools. You ready? We're going to start with XFS. Now, going back to Wikipedia, XFS is a high-performance 64-bit file saving system. And XFS was actually ported to the Linux kernel in 2001. It's supported by many Linux distributions as of June 2014. So in particular, Red Hat Enterprise Linux uses it as its default file system. XFS excels at executing parallel I/O operations due to its design based on allocation groups. XFS provides extreme scalability of I/O threads, file system bandwidth, and files, as well as the file system itself, while spanning multiple physical storage devices. Now, in terms of capacity, XFS is a 64-bit file system, and it supports a maximum file system size of 8 exabytes minus 1 byte, but limitations imposed by the host operating system may reduce this limit. 32-bit Linux systems limit both the file and file system size to 16 terabytes. Now, in terms of logging, in modern computing, logging is a capability that ensures the consistency of data in the file system despite any power outages or system crashes that may occur. XFS provides logging for file system metadata, where file system updates are written to a series of logs before the actual disk blocks are updated. Now, a log is a circular buffer of disk blocks that are not read in normal file system operation. The XFS log can be stored in the data partition of the file system or on a separate device to minimize disk contention. Now, in terms of allocation groups, XFS file systems are internally divided into allocation groups, which are linear regions of equal size within the file system. Files and directories can span allocation groups, and each allocation group manages its own nodes and free space separately, providing scalability and parallelism, allowing multiple threads and processes to perform I/O on the same file system simultaneously. If an XFS file system is to be created on a striped RAID array, a stripe unit can be specified when the file system is created. So this maximizes throughput by ensuring that data allocations, inode allocations, and the internal log, the journal, are aligned with the stripe unit. Blocks used in files stored on XFS file systems are managed with variable length extent, where one extent describes one or more contiguous blocks. So this can shorten the list of blocks considerably, compared to file systems that list all blocks used by the file individually. Block-oriented file systems manage space allocation with one or more block-oriented bitmaps. In XFS, these structures are replaced with an extent-oriented structure consisting of a pair of B+ trees for each file system allocation group. One of the B+ trees is indexed by the length of the free extents, while the other is indexed by the starting block of the free extents. So this dual indexing scheme allows for the highly efficient location of free extents for file system operations. Now, once again, according to Wikipedia, the file system block size represents the minimum allocation unit. So XFS allows file systems to be created with blocks ranging between 512 bytes and 64 kilobytes, allowing the file system to be tuned for the expected degree of usage. When many small files are expected, a small block size would typically maximize efficiency and capacity. But for a system dealing mainly with large files, a larger block size can provide a performance efficiency advantage. Now, XFS makes use of lazy evaluation techniques for file allocation. So in other words, when a file is written to the buffer cache, rather than allocating events for the data, XFS simply reserves the appropriate number of file system blocks for the data held in memory. The actual block allocation occurs only when the data is finally flushed to disk. So you can see that this improves the chance that the file will be written in a contiguous group of blocks, reducing fragmentation problems and increasing performance. XFS also provides a 64-bit sparse address space for each file, which allows for both very large file sizes and for holes within files in which no disk space is allocated. As the file system uses an extent map for each file, the file allocation map size is kept small. Where the size of the allocation map is too large for it to be stored within the in node, the map is moved to a B+ tree, which allows for rapid access to data anywhere in the 64-bit address space provided for the file. So this XFS also provides multiple data streams for files. This is made possible by its implementation of extended attributes. These allow the storage of a number of name/value pairs attached to a file. In fact, names are null-terminated printable character strings, which are up to 256 bytes in length, while their associated values can contain up to 64 kilobytes of binary data. They are further subdivided into two namespaces, root and user. Extended attributes stored in the root namespace can be modified only by the superuser, while attributes in the user namespace can be modified by any user with permission to write to the file. Extended attributes can be attached to any kind of XFS inode, including symbolic links, device nodes, directories, etc. In fact, the attribute utility can be used to manipulate extended attributes from the command line, and the XFS dump and XFS restore utilities are aware of extended attributes and will back up and restore their contents. Most other backup systems do not support working with extended attributes. Now, for applications requiring high throughput to disk, XFS provides a direct I/O implementation that allows non-cached I/O operations to be applied directly to the user space. And data is transferred between the buffer of the application and the disk using DMA, which allows access to the full I/O bandwidth of the underlying disk devices. The XFS Guaranteed Rate I/O system provides an API that allows applications to reserve bandwidth to the file system. XFS dynamically calculates the performance available from the underlying storage devices and will reserve bandwidth sufficient to meet the requested performance for a specified time. Now, this is a feature unique to the XFS file system. Guaranteed rates can be hard or soft, representing a trade-off between the reliability and performance. However, XFS will only allow hard guarantees if the underlying storage subsystem supports it. Now, this facility is mostly used for real-time applications such as video streaming, and you can see how that would be highly desirable. XFS implemented the DMAP I interface to support hierarchical storage management in iRIX. Now, as of October 2010, the Linux implementation of XFS supported the required on-disk metadata for DMAP I implementation. But the kernel support was reportedly not usable. For some time, SGI hosted a kernel tree which included the DMAP I hooks, but the support has not been adequately maintained, although kernel developers have stated an intention to bring this support up to date. So XFS does not yet provide direct support for snapshots, as it currently expects the snapshot process to be implemented by the volume manager. Taking a snapshot of an XFS file system involves temporarily halting I/O to the file system using the XFS freeze utility, having the volume manager perform the actual snapshot, and then resuming I/O to continue with normal operations. The snapshot can then be mounted read-only for backup purposes. Releases of XFS and iRIX incorporated an integrated volume manager called XLV. So this volume manager has not actually been ported to Linux, and XFS works with standard LVM in Linux systems instead. And check this out. Even though we've got the extent-based nature of XFS and the delayed allocation strategy, it significantly improves the file system's resistance fragmentation problems. But XFS also provides a file system defragmentation utility, XFS FSR, which is short for XFS File System Reorganizer, that can defragment the files on a mounted and active XFS file system. XFS provides the XFS GrowFS utility to perform online expansion of XFS file systems. XFS file systems can be grown so long as there is remaining unallocated space on the device holding the file system. This feature is typically used in conjunction with volume management, as otherwise the partition holding the file system will need enlarging separately. Now, one of the disadvantages of XFS file systems is they cannot be shrunk in place, although there are several possible workarounds. Another disadvantage is metadata operations in XFS were slower compared to journaling file systems, implemented later and designed to work with much larger logs, resulting in, for example, slower performance with operations such as deletions of large number of files. Another disadvantage is journaling cannot be disabled, so this may actually result in the shortened lifespan of SSDs. And that actually brings us to another great point. Another journaling file system of Linux, it's known as XK0-005, or Fourth Extended File System. So XK0-005 is a default file system for many Linux distributions like Ubuntu. Now, let's have a look at some of the features of XK0-005. It supports large file systems. So to illustrate that, the XK0-005 file system can support volumes up to 1 exabyte. That's EIB. And single files up to 16 terabytes, abbreviated TIB, with a standard block size of 4 KIB. Extensions replace the traditional block mapping scheme used in earlier formats, and we can define the scope as a series of contiguous physical blocks that improve large file performance and reduce fragmentation. A single extension on an XK0-005 can map up to 128 megabytes contiguous space with a block size of 4 KB. Now, there can be 4 extensions stored directly in the inode. When a file has more than 4 extensions, the rest of the extensions are indexed in a tree. Now, another feature is backward compatibility. XK0-005 is backward compatible with other successive versions. This feature makes it possible to mount X3 and X2 as well as XK0-005. So this will slightly increase the performance because certain new features of the XK0-005 application, such as the new block allocation algorithm, can be used with X3 and X2 without affecting the format on the disk. Another feature this leads us to is that it can make permanent pre-allocation. So XK0-005 can actually pre-allocate disk space for a file. The allocated space will be guaranteed and will most likely be adjacent. Now, this has applications for streaming media and databases as well. Another great feature is delayed allocation. So XK0-005 uses a performance technique called allocation on offload, also known as delayed allocation. So this delayed allocation improves performance and reduces fragmentation by effectively allocating a large amount of data at a time. There's yet another great feature, and that is an unlimited number of subdirectories can be created. XK0-005 does not limit the number of subdirectories in a single directory, except for the directory's specific size limit. So let's have a look at BTRFS. So this is another form of storage, a form of computer storage that actually combines copy-on-write, or COW, file system with a co-developed logical volume manager. BTRFS aims to address a lack of pooling, snapshots, checksums, and integrated multi-device coverage in Linux file systems. Now, of course, we got some features of BTRFS. And one of them is cloning. So BTRFS provides a clone operation that atomically creates a copy-on-write snapshot of a file. Such cloned files are sometimes referred to as reflinks in light of the proposed associated Linux kernel system call. Another feature of the BTRFS is subvolumes and snapshots. A BTRFS subvolume can be thought of as a separate file namespace. It can be mounted separately by passing the subvol or subvol ID options to the mount utility. It can also be accessed by mounting the top-level subunit. Now, in this case, the subvolumes are visible and accessible as their subdirectories. A BTRFS snapshot is a subvolume that shares its data with another subvolume using its copy-on-write capabilities. And changes made to a snapshot are not visible in the original subvolume. So when a writable snapshot is created, it can be treated as an alternate version of the original file system. For example, to revert to a snapshot, a modified original subvolume must be disconnected and the snapshot mounted in its place. So at this point, the original subvolume can also be deleted. Another feature of BTRFS is send-receive. Given any subvolume or snapshot pair, BTRFS can create a binary diff between them using the BTRFS send command. This can be replayed after using the BTRFS fetch, possibly on a different BTRFS file system. So the send-receive feature effectively creates and applies a set of data changes required to convert one subvolume to another. It's loaded because we got another feature of BTRFS. It's quota groups. So a quota group, or Q group, sets an upper limit on the space a subvolume or snapshot can consume. A new snapshot does not initially consume quota as its data is shared with the parent, but is then charged for new files and copy-on-write operations on existing files. When quotas are in effect, a quota group is automatically created with each new subvolume or snapshot. These initial quota groups are the building blocks that can be grouped into hierarchies to implement quota pools. These operations are performed with the BTRFS QGroup command. And if that's not enough, another feature of BTRFS is in-place conversion from X to 2, 3, and 4, as well as RiserFS. Now, as a result of having very little metadata fixed to fixed locations, BTRFS can be warped to fit the unusual spatial layouts of back-end storage devices. The BTRFS Convert tool will take advantage of this ability to perform an in-place conversion of an X2, 3, or 4, or RiserFS file system by placing the equivalent BTRFS metadata in its own unallocated space, while preserving an unmodified copy of the original file system. And that brings us to another feature of BTRFS. It's union mounting seed devices. So in creating a new BTRFS, an existing BTRFS can be used as a read-only seed file system. The new file system will then act as an overlay that copies right on seed as a form of Unity mount. Another feature of BTRFS is encryption. Now, while we can't talk about full encryption system yet, a workaround for combining encryption with BTRFS is to use a full disk encryption mechanism like dmcrypt, LUKS, on the underlying devices, and then create the BTRFS file system above this layer. The last feature of BTRFS that I want to talk about with you is checking and recovery. See, Linux distributions traditionally rely on FSCK, or File System Check program. This functionality is implemented through the BTRFS control program. And then there's another tool called BTRFS Restore, and that's used to perform the restoration process. So this tool can be used to recover files from an unmounted file system without replacing the corrupted file system. Well, my friends, that leads us to the fourth topic that I want to cover here in Configure and Manage Storage. So this is monitoring storage space and disk usage. Monitoring the disk usage or storage space on your system is obviously important. It's important to know how to maintain the efficiency of your Linux system. There's the total available size, total used space, file system information, as well as the partition information, all this kind of stuff. So it's the information about the system that's important for system efficiency, and it's important for you to know it. So let's get started with learning about the tools and command line utilities available in Linux to monitor this information, which is your disk usage. So first off, we've got the df command. This is a command line utility which you will use to monitor your Linux disk usage. So let's have a look at this df syntax. So it goes like this: df, square brackets, option, triple dot, square brackets, file, triple dot. Now, if there is no file name that's written as an argument with the df command, it shows the available space on all currently mounted file systems. Now, we've got a few options for this df command. -A or --all means display disk usage of the whole system. You can also see dummy files. -H or --human-readable just means displaying sizes in human readable format. -T or ~print equals type is displaying the file system type in the output. -K means to display disk usage of the file system in block size. -I or inodes means display inodes information of the file system. ~total, display grand total space usage of all file systems. -L or ~local means to display only local file system space usage info. -T or ~type equals type, all caps, means display the disk space information of a particular file system type. -X or ~exclude -type equals type, all caps, means exclude all the file systems having type from the output. Now, there's another great monitoring storage and disk usage command, -du. So this is the short form of disk usage. So we use it to estimate the file space usage. The du command can be used to monitor files and directories that are consuming large amounts of space on the hard disk drive. So let's have a look at the du syntax. It goes like this: du in square brackets option, triple dot, in square brackets file, or du in square brackets option, triple dot, ~file 0 from equals capital letter F. Let's have a look at some of the options here. -H or ~human-readable means the same thing, displaying sizes with human readable format. -A or ~all means display the count of all the files, not only the directories. -C or ~total means display the grand total. Well, my friends, we've gotten to the fifth topic that we're going to cover with configure and manage storage, and that's creating and modifying volumes using Logical Volume Manager, LVM. Mentioned LVM earlier, but we didn't get into it. When installing the Linux operating system, it's very important to determine the size of the area where the system will be installed, just like in other operating systems. See, an incorrect calculation at this point can create some big problems for the user in the case of, running out of space. So as you can imagine, enlarging or shrinking a section can be cumbersome and a bit risky if you try and do it later on. Logical Volume Management, or LVM, which has become the default for installation of most Linux distributions, has a number of advantages over traditional partition management. Perhaps the most distinguishing feature of LVM is that it allows logical partitions to be resized on demand without much hassle. So, never mind what we used to do. All right, so let's have a look at the structure of LVM here. PV is the physical volume, and these are formed by the configuration of one or more hard disks or partitions. A VG, a volume group, is created using one or more PVs. So you can think of a VG as a single storage unit. Logical volume, on the other hand, can be created from a VG. You can create PVs directly on the device or partition it first. All right, so now we're up to creating PV, VG, and LV. So we're going to use /dev/sdb/dev/sdc And we're going to be using these in the PV creation example. So you can create PVs directly on the device or partition it first. So let's start to create our physical volumes on top of /dev/sdb/dev/sdc. So here's the syntax of creating a PV. PV create /dev/sdb. PV create /dev/sdc. Not so bad so far. Then if you want to view the newly created PV, you can use the pvs command. Also, if you want to view the detailed information of the PV, you can always use the pv display-dev-sdx command set. So in this example, X could be SDB, SDC, and B, C, or D belonging to SDD, where X is B, C, or D. Well, you probably guessed that. Now, if you want to get information about all PVs, just write PV display. Now let's move along, creating a VG named VG1 using /dev/sdb. All right, so where's /dev/sdc? Why didn't we use it here? We reserved dev/dev/sdc to show the possibility of adding other devices to expand storage capacity as needed. So taking a look at the syntax to create VG goes like this. VG create VG1 /dev/sdb. And just like with PVs, you can use the VG display VG1 command group to display information about your VGs. Now, I wonder, you may remember we created a VG named VG1. The order of operations came to create logical volumes. While performing this process, the area distribution we'll make should be aimed at meeting both current and future needs. I think it'd be probably a more accurate method to name all the logical units we defined for their intended use. So for example, let's create two LVs named vol documents and vol backups with the remaining space that we can use for our purpose to store our documents and their backups respectively. Now, while you're creating an LV, you may use LV create, and this command has a few options. So the first of the options is -n, and this is used for indicating a name of an LV. Another option would be -L. This sets a fixed size. Another option would be -lowercase-l. This is used to indicate a percentage of the remaining space in the container VG. So let's have a look at the creation syntax. Vol underscore documents goes like this. LV create -n vol underscore documents capital letter L 12G VG1. And what about the syntax to create the vol backups? Goes like this. LV create -n vol underscore backups L 100% free VG1. So if you want to display LVs and some basic information, you can use the LVS command. Also, you can see some detailed information with the LV display command. And on the other hand, if you only want to see one LV, just use the LV display VG1 /vol underscore documents command set. And don't forget that before each logical volume can be used, you must create a file system on it. So we're going to use X4 as an example here, since it allows us to both increase and reduce the size of each LV. Remember, as opposed to XFS, that only allows an increase in the size. So if you look at the syntax to create the file system, it goes like this: mkfs.ext4/dev/vg1/vol_documents. And mkfs.ext4/dev/vg1/vol_backups. Great, so now our next step is going to be how to resize logical volumes and add extra physical storage as needed. Well, let's assume that the space we set for the vol backups is insufficient. So we'll alternate between the capacities used by the two divisions. Let's aim to increase the insufficient vol backup space by 2 gigabytes. Now, of course, we will allocate this field from the vol documents field. So we'll go to the terminal and use the command set lv reduce -L-2.0g -r/dev/vg1/vol_documents to decrease. And now use the command set lv extend -L plus 100% free -r/dev/vg1/vol_backups. I do want to express an important point here that I think has not actually escaped your attention. It's really important to include the minus or plus signs when resizing logical volume, okay? I think I said dash, but it's a minus. Otherwise, you set a fixed size for the LV instead of resizing it. Follow? So anyway, if you remember, we originally reserved the physical partition /dev/SDC. So imagine when you get to a point where resizing logical volumes can no longer solve your storage needs and you have to buy an extra storage device. Well, simply put, you just need to get another disk. So to solve this problem, we will add our reserved PV /dev/SDC. And if we're going to add /dev/SDC to VG1, we can use the following command set: VG extend VG1 /dev/SDC. And you can detect the increase by running the VG display VG1 command set before and after the operation. So this sixth topic that we're going to cover in Configure and Manage Storage is inspecting RAID implementations. All right, so it's time for our command that will help us to RAID. Its name is MD-ADM. Although dealing with RAID arrays may seem like a complex process, Linux actually takes this issue out of the way with MD-ADM, Manage Command Set. So you can see what tasks MD-ADM --manage will allow you to perform when you execute the command. And the tasks are re-adding a device to the array, marking a device as faulty, removing a faulty device from the array, replacing the faulty device with a spare one, starting an array that's partially built, stopping an array, marking an array as RO, or read-only, or RW, which is read-write. So the --manage option is not necessarily required to manage RAID devices with the mdatom tool, but only the mdatom command can also execute the management mode. So let's check out the syntax for mdatom. And it goes like this: mdatom --manage RAID and square brackets options, square brackets devices. Okay, so now we can move on to the /proc/mdstat command. So proc/mdstat is a special file that shows you the state of the Linux kernel's multiple device driver. It's the software RAID implementation that allows you to create any number of RAID devices based on the disk devices, physical or virtual, available to your Linux system. So if you want to use this command, the syntax will look like this: cat/proc/mdstat. And that leads us to the 7th topic that we're covering here in Configure and Manage Storage. It's Storage Area Network, SAN, or Network Attached Storage, NAS. So a SAN, a Storage Area Network, is used to transfer data between servers and the storage device's fiber channel and switches. As storage area network components, we can mention node ports, cables, interconnect devices, storage arrays, and SAN management software. In Network Attached Storage, or NAS, the data is identified by file name as well as byte offset. In Network Attached Storage file system, it's managed by a master unit like CPU and memory. It uses files for backup and recovery instead of block-by-block copying techniques. Network Attached Storage components include the main unit, the CPU, the memory, network interface card, NIC, optimized operating system, protocols, and storage protocols, ATA, SCSI. So what about the difference between storage area network, SANs, and network attached storage, or NAS? For example, in SAN, data is identified by disk block, while in NAS, data is identified by file names as well as byte offset. In a SAN, the file system is managed by the servers, whereas in NAS, the file system is managed by the main unit. SAN is definitely costlier than NAS. SAN is more complex than NAS. While protocols such as SCSI and SAT are used in SAN systems, file server and CIFS protocols are used in NAS systems. So now we've got to talk about multipath D. So the multipath daemon checks for failed paths and reconfigures the multipath map. The daemon runs the multipath utility when events occur that require device map reconfiguration. So just by using the -D option, you can run the daemon that displays all messages in the foreground. The syntax goes like this: multipath D -D. And after listing, you can stop. You can also set the verbosity level using -V and a square brackets level. It has an interactive mode enabled with the -K option, and you can use some of the other commands with that interactive mode as well. Syntax goes like this: multipath D -K. All right, so all operating systems use a kind of file system. So we're going to start with Network File Systems, or NFS. As you may know, a file system defines how data in file form is stored and retrieved from storage devices such as hard disk drives, solid-state drives, tape drives. It's a network protocol for distributed file sharing. See, NFS is a network file sharing protocol that defines how files are stored and retrieved from storage devices over networks. It allows system administrators to share all or part of a file system on a network server to make it accessible to remote computer users. Clients with access to the shared file system can mount NFS shares, also known as shared file systems, NFS uses remote procedure calls, RPCs, to route requests between clients and servers. In many modern operating systems, it's one of the most widely used protocols for file servers. Moreover, cloud vendors implement the NFS protocol for cloud storage. So anyway, let's just talk about some of the benefits of using NFS. NFS is a mature protocol, so it's been around for a while. Its application features, security level, and potential weaknesses are well understood by its users. NFS is also an open protocol, so in this way it's open to continuous development, and it's generally accepted as a free and open network protocol. NFS is an easy-to-install, low-cost solution for network file sharing because it uses existing network infrastructure. Centralized management of NFS reduces the need for additional software and disk space on individual user systems. The protocol is easy to use and allows users to access remote files on remote hosts pretty much the same way they access local files. NFS can be used as a distributed file system, reducing the need for removable media storage devices. Now, on the other hand, there are some disadvantages with NFS. One of them is the dependency on RPCs. This makes NFS inherently insecure and should only be used on a trusted network behind a firewall. It's also known to have limited bandwidth and scalability, and NFS slows down during heavy network traffic. So we'll continue with the server message block. It's abbreviated as SMB, which you might be familiar with, and the Common Internet File System, abbreviated as CIFS. Server message block is a communication protocol Microsoft created to provide shared access to files and printers between nodes in a network. But it also provides an authenticated inter-process communication, or IPC mechanism. Microsoft first implemented SMB in its LAN Manager operating system. Meanwhile, SMB used the NetBIOS protocol as the basic transport. So way back in 1996, Microsoft released a version of SMB with minor modifications under the alias of Common Internet File System, or CIFS. CIFS remains compatible even with the earliest incarnation of SMB, including LAN managers. It supports symbolic links, hard links, and larger file sizes, but none of the features in SMB 2.0 and later. However, Microsoft's proposal remained an internet draft and never reached standard status. And now Microsoft has since abandoned CIFS, but has made SMB features publicly available. And doesn't that bring us to our 8th topic that we're covering here with Configure and Manage Storage? It's the storage hardware. So our first command is LSSCSI. So if you want to list all of your SCSI devices on your system, you're going to use this command. Command syntax goes like this: LSSCSI in square brackets option. So we can just run this utility and see what kind of screen we're going to see. So the first column that you'll see on the screen defines the address of the device in the system. And then the second column gives some information about the type of device. The last column specifies where to find the device file. Our second command is lsblk. lsblk is used to list details about blocked devices. So these blocked devices are basically files that represent devices connected to the computer. Now, most Linux distributions do not have the lsblk command pre-installed. Although it differs according to Linux distributions, a general command set for installing goes like this: sudo apt-get in parentheses yum install util-linux. So let's go on with a few examples. If you want to display block devices on your system, you can use lsblock. Or you may want to display the empty block devices. With others, you can use lsblk-a. Or if you want to display devices with size information, you can use lsblk-b. Or if you want to display information about the device owner, group, and mode of block devices, you could use lsblk-m. I want to tell you about another command which we're going to talk about here. It's blkid. So using the block ID command, you can view attributes of block devices that are on your system. So it's a quick way to find the type of block devices. If you want to display all the block devices that are on your system, you can use the blkid command. Or let's say you want to display all the blocks with an I/O limits. You can use the blkid-I command set. Or let's say you want to display additional information, you could use the blkid-P command set. Or if you want to search for parameters, just use the blkid-L-T command set. So the -T option should also specify with -L. For example, blkid-L-T label equals /home. This is the command set for searching for the label parameter that has the value /home. Or if you want to format the blkid output, you could use the blkid-O command set. Now, by default, the -O uses the full format. Because of this, blkid and blkid-O full have similar outputs. For example, blkid-O list. This is the command set that will also display the mount point column. That's very helpful. Now, another command which we're going to talk about is fcstat. It displays the statistics gathered by the specified fiber channel device driver. So you specify the device-specific statistics. These statistics display in addition to the device generic statistics. So here's the syntax of the command: fcstat, in square brackets option, device_name. And then if you specify no options, the fcstat command displays only the device generic statistics. So for an example, if the fcstat command is not connected to a specified device name, it does not connect to a network, and the -D option will open the device in the diagnostic mode to report statistics. Right, so let's have a look at some of those options of fcstat. And the first of them is -C, so it removes the delay in generating the output. The other is -D, it displays the statistics by opening the adapter in diagnostic mode. Then we've got another one, it's -E, so it's going to display all the statistics, which includes the device-specific statistics. And the last one would be -Z, so this is going to reset some of the statistics back to their initial values. So if you remember the syntax of fcstat, you will remember device name. Okay, so it's the name of the fiber channel device, for example, FCS0. If you want to display the statistics for a fiber channel device driver FCS0, you can use the command set fcstat FCS0. All right, so here we are. This is section 5, and it's affectionately titled System Management, and our fourth subtitle is Configure and Use Processes and Services. Great, so in this topic, our first subtitle is System Services. So let's get to know some of the terms so that we could better understand the processes of Linux. So the first term that we're going to talk about will be the program. So in a Linux file system, we can define it as a structured command set stored in an executable file. The program is created to perform a specific operation. So our second term is process. Now we could just define the process as a working program in memory and CPU. So this next term is the user process. And we could define that as a process initiated by the user. Next is the daemon process. We use this to describe a process that is operated independently of the terminal. So during the boot process of a Linux system, init daemon starts several daemons, including a daemon for the user entry. And once the user is logged in, the user can start a terminal window or a virtual terminal, and this will allow the user to start manually. So don't worry, we're going to continue to explain terms, especially before we get to the next stage. But I do want to introduce you to the process ID, or commonly abbreviated PID. And this is just a unique description that's appointed at the very beginning. Another term that's useful is the child process. So these are the processes initiated by another process. So that needs to be matched with the parent process, and this is the process that initiates operations such as child processes. But the last thing that I want to mention to you here is the parent process ID, or PPID. So it is the PID of the upper process that constitutes the existing process. All right. So the first thing I want to cover here in Configure and Use Processes and Services is System Services. So what we're going to do is just go over a simple command line utility called System Control. Now, this is a Linux command line auxiliary program, and it's used to control and manage systemd and other services. So it's going to allow you to communicate and perform operations with systemd by considering systemctl as a control interface for systemd in its service. So to show you in the systemd language, a service or a unit is a resource, an object systemd is aware of and knows how to address. The classification of a unit as a service is technically correct. However, in systemd, units tend to be more abstract. So units usually consist of welding pools, file system connections, network protocols, devices, as well as local Linux services. So what do you suppose you need to know about systemd unit types? Well, I'm glad you're here because I'm going to explain a few. First of all, the basic. We should know that the unit files are labeled with a suffix in the unit file, which explains the purpose-based. The first part of the suffix is called service.service. Okay. It defines how systemd manages a service. They usually end with the extension of the .service. But did you see the difference? Big S, little s. Okay. So this suffix basically explains how to start, stop, reload, and restart. The next suffix you ought to get to know is .target, and these units provide synchronization points to other services during startup. Next up, we have the suffix called .slice. So a slice unit file encodes information about systemd slice units. Slice units are a part of the Linux control group tree, which provides resource allocation and restrictions on a slice-related operation. Next suffix called .device. These unit configurations define a device unit as exposed in the sysfs/udev device tree. Now here's the suffix called .timer, and these units define a timer managed and controlled by systemd for scheduled activation. Next suffix we have .snapshot. So these unit files allow rollback of the current state of the system after making changes. So we create them using the systemd snapshot command. And that brings us to the next suffix called swap. All right, so this .swap will encode information about swap space, such as the device name or path of the swap space. All right, here's an important suffix .mount. So these unit files encode information about mount points in the system managed by systemd. And that brings us to .automount. So these are the unit files that define the mount points that are automatically mounted. All right, so let's say you want to display the unit files available in the system. Well, you can list the files in the /lib/systemd/system or /etc/systemd/system. And then for this process, systemd has a command. So let's go to the terminal and execute it. All right, so here's the syntax of the command. It goes like this: sudo systemctl list-units. Now, once this command is executed, you will see the units available in the system. The output from the systemctl list-units command uses a column-based organizational method. So doesn't that beg the question about these different columns of the systemd screen? So let's have a look at the first one. It's called unit, and this is showing the name of the unit file. Next column over is load. So this shows whether the unit definition loaded correctly or not. Next column would be called active. So it shows the high-level activation state. Okay, next column, sub, it shows the low-level activation state. Next column is description, and it explains the unit file. So you know what? You can actually sort the units according to their status if you want to. And the command set that you would use for that would go like this: sudo systemctl list-units -- state equals inactive. Now, most of the inactive columns you can see in the list will consist of network activation service, recovery mode, manual DB, and the like, which started before the user session. You follow? Cool. Okay, so now let's say that you need to show all the unit files in the system. You simply add the -- all parameter to the end of the command. So in that case, the command set would look like this: sudo systemctl list-units -- all. Now, apart from those, if we do need to list the operations we can do with this command, you could always do this to view the volume file count, edit unit files unless it's necessary to avoid editing critical unit files, manage services, starting and ending services, reinstalling the services, restarting the service, enable services at boot, checking the status of a service. And that brings us to our next topic and our second subtitle, which is scheduling services. All right, very good. So when using a Unix-based operating system, certain tasks must be performed over and over again. So running repetitive tasks manually every time, well, who wants to do that? It's also time-consuming, and it's way inefficient. So to solve that problem, Unix comes up with a built-in task scheduler. So these task schedulers are activated when needed by the system or at specified rerun times. So Linux actually comes with two essential and very powerful tools. The first of these tools is the cron daemon, default task scheduler, and the other is AT. It's more suitable for one-time task scheduling. So we're going to get started with the cron daemon. All right, so this program is responsible for running many jobs at certain times. So these tasks are usually run in the background at scheduled times, but it offers great flexibility regardless of the task, regardless of the interval, the clock, the calendar functions, etc. So cron keeps track of its actions using the crontab file. The crontab file is a script that contains all the necessary information to run all cron jobs. So if you want to list all scheduled cron jobs for the current user, the set of commands that you would run would go like this: crontab-l. All right, so this set of commands will actually print all the contents of the crontab file. Now, if you want to see the cron job list for a different user, the set of commands to run would go like this: sudo crontab-u-l. Then if you want to edit the crontab script, the command set to run would go like this: sudo crontab-e, and run the command. Now, don't forget to run the command with sudo privilege to edit the crontab file for the root. All right, so let's move along with AT. And while cron is the primary way of scheduling tasks, AT offers the ability to run a command script at a specific time or a fixed interval. But I want you to note that it will run the targeted job only once, while cron will rerun the job at intervals. And of course, that tool might just be a little less popular compared to cron, but it's relatively more easy to use, I suppose. So the tool does not actually come pre-installed on most Linux distributions. So if you do want to install it, you'll need to run the appropriate command according to your distribution. We'll go over a couple. For Debian, Ubuntu, and those derivatives, the command set goes like sudo apt install-yat. For CentOS or RHEL and those derivatives, the command set would go like yum install at. For Arch Linux and those derivatives, the command set is more like sudo pacman-S at. And for Fedora and those derivatives, the command set would go like sudo dnf install at. And then once the installation is complete, enable the AT daemon. And for that, you can use sudo systemctl enable --now atd.service for that process. Now, the way it works actually seem a little different to you. You must define the interval to run the desired task. For example, you can use the right now plus 2 hours command set to run a specific command 2 hours from, well, now. Okay, so here's our next topic. It's the third subtitle. It's process management. In Unix-based operating systems, a running command instance is known as a process. So you can actually identify each transaction with a unique transaction ID. Linux provides command line tools to list, manage, and monitor these processes quite efficiently. You can use these tools from Linux to prioritize processes or change their order to manage system resources more efficiently. The first of these commands is the PS command. Now, the PS command is commonly used. It's a command line utility for listing running processes. There's another way to list and manage processes, and that's the top command. Although the top command is interactive and screen-oriented, the PS command also displays additional information, such as the resources consumed by each process. And since Linux is a multi-user structure, each process is associated with a separate user and group account. Therefore, account information, along with the transaction details, helps you access system resources that a transaction can use. Now, if you want to display all the processes of the current user, you can use a command like this, ps ux pipe less. And then let's say you want to display all the processes for all users, you could use this command, ps aux pipe less. All right, so that brings us to another method of managing processes, and that's using System Monitor. System Monitor provides a graphical way to view and manage processes. If you want to start System Monitor, just use Applications, right angle bracket, System Monitor. If you want to just view all running processes, you can switch to the Processes tab. So the actions for the current user will be displayed in alphabetical order. You could reorder the transaction list by clicking any column header. You can also click the percentage CPU and memory headers to view the processes that consume more processing power and memory. So yeah, System Monitor allows you to manage processes in a variety of ways, actually. It means you can stop, terminate, resume, terminate, and change the process priority just by right-clicking on a process name. So System Monitor is actually the best tool for novice Linux users who don't quite know how to work with command line utilities yet. In fact, why don't we just have a look at how to work with background and foreground processes. Now, you may need to access a Linux system over a network using only the command line. So this process limits the effective management of multiple active programs. But a shell lets you manage programs by switching them in the background and foreground. Okay, so how about starting a background process? While running in the shell, run the command that will start the program, then stop it and put it in the background just using Control+Z. And if you want to run a program directly in the background, you must add the ampersand to the end of the program. So your command set would look like this. Find /usr right angle bracket /tmp all user files ampersand. Now note that you cannot run commands that require terminal input in the background. And if you want to view all the programs running in the background or that are stopped by you, you can use the jobs command. And also, if you want to continue a job that you are doing in the background, you can use the FG command and it will bring the command to the foreground. Syntax goes like this. FG %, left angle bracket, job _number, right angle bracket. And then likewise, you can restart a command that you've stopped running in the background by using the BG command. And the command set that you will use for this process should look like this: BG, %, left angle bracket, job underscore number, right angle bracket. Just make sure that you sing falsetto. Oh, come on, everybody loves the BGs. So let's have a look at how to use kill processes in Linux. You can kill, stop, and resume a process with a graphical application program such as System Monitor. But conveniently, you can also use command line tools like kill and kill all to do the same. Now, you can use either names or numbers to use a signal, so the syntax will go like this: kill dash signal number, left angle bracket, process dash ID, right angle bracket, and kill dash signal name, left angle bracket, process dash ID, right angle bracket. So for example, the following commands send the sig kill signal to a process with a PID 2022. Kill dash 9 2022. Or kill dash sig kill, all caps, 2022. All right, let's list the most commonly used process signals then. The first is sig kill, and the signal ID is -9. So this option kills a process immediately. Next term is sig term, and, well, the signal ID is -15, so this operation terminates a process. Next up is sig stop, and the signal IDs are -19, so this will stop the process. Next up is sig cont, and the signal IDs are -19, so this continues a process after it stops. All right, so there's something else I need to share here with you. It's about listing processes in open files. Now, on Linux and Unix-like systems, everything is like a file. So it means resources in Unix systems, storage devices, network sockets, processes, everything. It means that a file descriptor has been assigned. So a file descriptor is a unique number that identifies a file and other input-output devices. It describes resources and how the kernel accesses them. So think of it as a gateway to kernel abstraction hardware resources. This means that Unix and Unix-like systems like Linux make heavy use of these files. Okay, so what about LSOF utility? Well, this utility is the abbreviation of list open files. It's just a command line utility that allows us to view the open files and the processes or users who open them. The LSOF utility is available in major Linux distributions, and if you want to manually install this utility, you can use a different command set for the different distribution of Linux. So that means for Debian, you can use sudo apt-get update and sudo apt-get install lsof-y. For REHL and CentOS, you can use the sudo dnf update and sudo dnf install lsof command. For Arch, you can use sudo pacman-sy and sudo pacman-S lsof. And for Fedora, just use the sudo yum install lsof. All right, so let's show the process of an opened file. Now, if we want to filter to show only processes that open a particular file with the lsof command, you can use the command set that goes like this: sudo, in square brackets, path to file. For example, you can use the sudo lsof/bin/bash and have a look at the file that opens /bin/bash. So why don't we have a look at how to show files opened by a specific user. Now, you can also filter the output to show the files opened by a specific user. So you may do this just by using the -u flag followed by the username. It goes like this: sudo lsof-u. All right, let's have a look at how to show files opened by a specific process. So let's say you want to display all the files opened by a specific process. You can use the PID of the process to filter the output. And then the command set that you would use would go something like this: sudo lsof-p and in square brackets, PID. All right, so what about showing what is opened in a directory? So another command that's useful to display the Linux process is top. I mentioned it at the beginning. Let's break it down. It provides a dynamic real-time view of the running system. Okay, so usually this command will show a summary of information in the system and list of the processes or threads currently managed by the Linux kernel. So as soon as you run this command, an interactive command mode will open at the top of the window where it will contain statistics of processes as well as resource usage. And then if you notice in the lower part of the window, a list of currently running processes will be displayed. And then when you want to exit the command mode, just press the Q key. Now we need to talk briefly about the meanings of the titles displayed on the screen when you run this top command. So from these headers, the PID shows a unique process ID of the task. PR stands for the priority of the process. So the lower the number, the higher the priority. VIRT, well, this shows the total amount of virtual memory used by the task. User specifies the username of the task owner. %CPU represents CPU usage. Time plus CPU time. This is the same as the time, but reflects a bit more granularity for 1/100th of a second. SHR represents a shared memory size in kilobits used by a task. NI stands for the nice value of the task. So a negative nice value actually means higher priority, and a positive nice value means lower priority. %mem, this is the memory used by the task, and it shows the rate. Res, and this refers to how much physical RAM the process uses. And command is the name of the command that started the process. So now let's have a look at some top command examples. For the first example, normally the top output keeps refreshing until you press Q. So if you want to automatically exit after 5 repetitions, the command set would then go top-N5. Now for a second example, let's say that you want to display specific user processes. The command set would look like this, top-U. So for a third example, if you press the Z option when you run the top command, this is going to display the running processes in color, which may actually help you identify running processes a little easier. Example 4, if you press the C option when you're running the top command, it's going to display the absolute path of running pro. And when you press the K option in running the top command, you actually can kill a process after finding PID of the process. All right, so another great command that you can use to display the Linux process is htop. Now, htop is a command line utility that is frequently used in Linux. htop actually allows the user to interactively monitor the system's vital resources or server processes in real time. htop is a newer program compared to, well, the top command, and brings many improvements over the top command as well. So htop supports mouse operation, uses color in its output, and also gives some visual indicators of processor memory and swap usage. htop also prints full command lines for processes and allows both vertical and horizontal scrolling for processes and command lines, respectively. And what about the syntax of htop? Looks like this, htop, and in square brackets, your options. So what about those options? Well, the first one that you'd be interested in is -D or ~delay. This option is used to display the delay between updates in tenths of seconds. Next option would be -C or ~no-color. So this option will start htop in monochrome mode. Next up is -H or ~help. So this option is used to display the help messages and exit. Another one is -U or ~user equals username. And this option is used to show only the processes of a given user. Another one is -P or ~PID equals PID. and this option is used to show only the given PIDs. Next one up is -S or double-dash short-dash key column, and this option sorts by this particular column. And if that wasn't enough options for you, HTOP also offers some interactive commands for ease of use. Some of these commands are used to move through the process list, just like these: arrows, page up, page down, home, and end. Additionally, some special tasks are assigned to the function keys. So you can use F1 for help, F2 for setup, F3 for search, F4 for filtering, F5 for tree view, F6 for sequence, F7 for increase the priority of the selected process, F8 for deprioritize a selected process, F9 for end process, F10 for exit. All right, so that brings us to yet another subtopic of ours, and that will be set priorities. I mentioned the Linux nice command earlier. This helps execute a program or process with a changed timing priority. It starts a process with a user-defined scheduling priority. So in this, if we give a process a higher priority, the kernel will allocate more CPU time to that process. Now, there is something called the renice command, on the other hand, which allows you to change and edit the scheduling priority of an already running process. The task of scheduling the process and allocating CPU time for each process according to the plan rests with the Linux kernel. So why don't we take a moment here to have a look at the operations that we could do with nice and renice for commands. So let's say that you want to check the nice value of a process. You can use the ps-el pipe grep terminal command set. And if you want to set the priority of a process, you can use the nice-10 in square brackets process_name command set. If you want to set a negative priority for a process, you can use the nice-10 in square brackets process_name. And if you want to change the priority of a running process, for example, PID equals value, you can use the sudo renice-n15-p in square brackets value. Now, I want to bring up an important issue at this stage. It's the process states. So in Linux, a process is a command or a step of executing a program. In Linux, processes will be in one of 5 possible states. So the states are described: running or runnable, R; uninterruptible sleep, or D; interruptible sleep, S; stopped, T; or zombie, Z. So why don't we just start with an explanation of running or runnable state, abbreviated R. Now, like we said before, that when a new process is started, it is rendered running or executable. In the running state, the process receives one CPU core to execute its code and logic. However, the thread scheduling algorithm can force a running process to give up its right to execute. This is to ensure that each process has a fairer share of CPU resources. So in that case, the process will be placed in a run queue, and its state is now an executable waiting to be executed. Now, although running and executable states are referred to as different, in both cases they're actually grouped into a single state, denoted by the character R. Now, what about an explanation of sleeping state? Now, remember, these are interruptible, abbreviated S, and uninterruptible, abbreviated D. Now, while the process is executing, the code may need and even request an external resource. Requests for external resources are I/O-based requests, such as reading a file from a disk or making a network request. So the process cannot progress and stalls because there are no resources. So in these such events, they have to leave their CPU cycles to other tasks ready to run, and therefore they go to sleep. Now, like we mentioned before, there are two different sleep states. These are uninterrupted sleep, D, and interrupted sleep, S. The uninterrupted sleep state only waits for resources to be available and does not react to any signals before switching to the runnable state. Interruptible sleep state. Well, these, on the other hand, will respond to signals and the availability of resources. All right, so what about stopped state? Well, from a running or runnable state, a process can be put into a stopped state, or T, using the SIG-stop or SIG-stop signals. The difference between both signals is that we send SIG-stop programmatically, like running kill-stop PID in square brackets, and the process cannot ignore this signal, and it goes into a stop state. But on the other hand, if we send a SIGT STP using Control-Z combination from the keyboard, well, the main difference between this from SIG-stop is that the process can optionally ignore it. So that means that it can continue to work even after receiving the SIGT STP signal. So in this state, you can actually make the process running or runnable state by sending the SIG-cont signal. Now, let's go ahead and explain the zombie state. Everybody wants to know. So when a process in other states completes its execution or is terminated, it sends the SIG-child, SIG-CHLD signal to the parent process and goes into a zombie state. The zombie process, also known as the defunct process, will remain in this state until the parent process clears it from the process table. Now, to clear the terminated child processes from the process table, the parent process must read the exit value of the child process using the wait, open and close parenthesis, or wait PID, open and close parenthesis, system calls. All right, so we've been talking a lot about process states, but in what ways are we going to use and view these statuses? So there are obviously, or not obviously, multiple ways, though, to check the status of a process in Linux. So you can use command line tools like ps and top to check the status of processes. But alternatively, you see, we can refer to the sudo state file for a particular PID. So then how do you view the process state using the ps command? Well, let's go to the terminal and then run the ps command. And the syntax looks like this, ps a. Now you must add a, and this is a column that tells you the status of the process. The first letter of the value under the stat column indicates the state that the process is in. So what about viewing the process state using the top command? Well, in Linux, the top command line tool displays process details in real time. It shows different aspects of the system, such as memory and CPU usage of individual processes. So in fact, why don't we run top in the terminal to see the process status? All right, so another way to find out about process states is to use the /proc sudo file system. So the /proc sudo file system contains all the information about processes on our system. So you can actually directly read the status of a process through this sudo file system. Now, the approach does have a downside. You do need to know the PID of the process before you can read its status. So to get the status of a process, you can get the value in the sudo status file under /proc/ in square brackets PID/status. And the instruction set would go like this: cat /proc/2519/status pipe grep capital letter S state. All right, so that brings us to a new subtopic, and that would be job control. So yeah, a job is a shell-managed process. So each job is assigned a sequential job ID. Because a job is a process, each job has an associated PID. So there are three types of job status. The first job status is foreground, So when you enter a command in a terminal window, it will occupy that terminal window until the command completes. That's a foreground job. Now the second one is background. So when you enter an ampersand symbol at the end of the command line, the command runs without copying the terminal window. The shell prompt is displayed immediately after pressing the return key. All right, so that's an example of a background job. The third status of a job is stopped. So if you press a Control+Z for a foreground job or enter the stop command for a background job, the job stops. And then that job is called a discontinued job. So apart from these, command pairs Control+C and Control+D are also used. Control+C is the command that kills a process. It terminates the program. Control+D is the command that closes the terminal window or ends the terminal line. Now, we might as well talk about the pgrep command. So after running the grep command, well, this will also look for the pattern and prints a matching text to the output. However, if you need to apply the commit type for fetch, select information about the current running process. In fact, why don't we go ahead and use the pgrep command to get more information. So we'll start by checking all the options available in pgrep. And you can do this easily using the pgrep-h or --help command set. If you want to know the PID of the running process, you can use the pgrep in square brackets name command set. For example, pgrep Firefox. All right, so another command line utility is pkill. So this utility kills program processes based on the parameters that you specify. The user running the process, its partial or full name, or several other attributes determine their process. The pkill command comes pre-installed on most Linux distributions. So it's by using the pkill command, Linux systems can kill their running processes. One of its unique features that it does is it does not require the PID number of the process to be entered, such as the kill command. You can terminate this process by entering the name of the process as input. And in most cases, we know which processes we need to stop, and we know its name. So it proves to be an easy command line method for us to finish the complex process. The standard syntax for this command line goes like this: pkill in square brackets, option, left angle bracket, pattern, right angle bracket. When called without an option, pkill initiates the termination of all running programs by sending a 15 term signal. For example, if you want to stop all Firefox processes smoothly, you can use the pkill-15 Firefox command set. All right, so we're going to talk about PIDOF. It's another command that's used to find out process IDs of a specific running program. So it's basically an identification number that is automatically assigned to each process when it's created. So the syntax of the command is like this: PIDOF, square brackets, options, program 1, program 2, program N. So if you want to find the PID of any process, the command line goes like this: PIDOF, and in square brackets, process_name. The PIDOF displays all PIDs of the named command or program. That's why the program just needs to use the -S option with it to display a process ID. The command line for that operation would go like this: PIDOF-S, and in square brackets, program_name. And that brings us to section 6. Congratulations for making it this far. I know you're having as much fun as I am. So the first title here is System Management. It's our 5th subtitle. This is Use Networking Tools or Configuration Files. All right, so here we are at the first subtitle, Interface Management. So let's get started with IP Route 2. So this is a great tool package, IP Route 2. Contains utilities to control and monitor the network, IP address, routing. It's a more modern alternative to regular net tools. IP Route 2 is an open source project. It focuses mainly on the networking components of the Linux kernel. Commonly used utilities in IP Route 2 are IP, SS, and Bridge. Now, a significant portion of Linux users still use netstat, ifconfig, route, and others, and that's fine. But tools such as IP Route 2 package tools are quite fast compared to those old ones. So you're probably wanting some more information about it, right? So let's have a look at the IP Route 2 and the nettools commands that do the same task and compare and contrast. So if you use IP link show for your command set in IP Route 2 and ifconfig-a in nettools, well, you can view all interfaces. You can use this command set in IP Route 2, IP link set /up F0, and compare that with the command ifconfig F0 up/down. That'll obviously enable or disable network interface. You can use the command set in IP Route 2, IP ADDR, add 192.168.0.10/24dev F0 in IP Route 2. You can use the ifconfig F0 192.168.0.10/24 command set in nettools, and you'll be assigning an IPv4 address to the network interface. In IP Route 2, use the IP Route show command set, and the command set in nettools to show the IP routing table is route-n. Use the big S little s command set in IP Route 2 or the netstat command set in nettools to display socket listening TCP UDP. In IP Route 2, use ARP-AN, and in nettools to display the ARP table, just use IPNA. So we'll go ahead with Network Manager. To control Network Manager, a command line tool gets used. Often it is called nmcli. So the Network Manager CLI command is also used to view network device status, create, edit, enable, or disable, as well as delete network connections. So here's the syntax of nmcli. It goes like this: nmcli, options, object, curly braces command, close curly braces. So if you want to check the device status using the nmcli command, you can use nmcli dev status. That's a command set. And you can see the output shows various columns. That includes the device name, its type, connection status. And if you want to check the active connection on the device, you can use nmcli connection command set. And here you can see that there is only one connection that's active. The number of connections, it's UUID, Universal Unique Identifier, and type. Well, it's going to vary from machine to machine, right? Now, if you want to list all available devices, you can use nmcli device list command set. Also, some options that you can use with nmcli command go like this. For example, nmcli-t device list. So this is the command set that's intended to give you the terse output. You can use -t or --terse as well. So for an example, an MCLI-P device list is the command set that will give you easily readable and organized format for users. You can use -P or --pretty. Oh yeah. All right, so why don't we start with the /etc/host files. So this is the file that associates host names with IP addresses. You can resolve or search for an IP address if you know the host name. Larger networks use domain name service or DNS to accomplish this solution. If you want to open and examine this file, just go ahead to the terminal and execute cat/etc/hosts for your command set. So continuing with the /etc/resolve.conf file, this is the resolver configuration file that provides access to DNS. So this file usually has at least two lines, one line specifying the IP address of a DNS server or name server, and the other specifying the search domain. So if you want to open and examine this file, you just go to the terminal, execute cat/etc/resolv.conf. And now let's continue with /etc/sysconfig/network file. Now this file is used to specify general network settings. For example, if you want to specify the default gateway, you can use the cat/etc/sysconfig/network command set. So now here we are at name resolution. And we'll start with the /etc/nsswitch.conf file. So it's a file used to configure system databases and name service key. It'll provide resources for common configuration databases and name resolution mechanisms. So this file is used to configure which services are used to determine information, such as host names, password files, and group files. And that brings us to the /etc/resolve.conf file. The etc/resolve.conf file is the resolver configuration file for Linux and Unix-like operating systems, and it's used to configure DNS name servers. The /etc/resolve.conf file contains information read by resolver routines the first time they are called by a process. You can actually make this file using the cat command with cat/etc/resolv.conf. All right, so let's move on to a command that was mentioned before. So the name of this API, which is used to control the host name in Linux systems and change its related settings, is hostname CTL. So the command also helps to change a host name on a particular system without actually finding and having to edit the /etc/hostname file. So when you want to run this command, the syntax of the command looks like this: hostname CTL with your options in square brackets, command, triple dot. The parameter written as command here can be one of four different options, and these are status, and this will mean to check the current hostname settings. Set-hostname name means to set the system hostname. Set-icon-name name means to set the icon name for the host. Set.chassis name means set the chassis type for the host. Now, of course, there are three different types of host names in Linux, and these are static, and this is assigned by the system administrator, used to initialize the kernel hostname at boot. We also have the type known as dynamic or transient, and it's assigned by the MDNS server or DHCP server during runtime. It's a top-level hostname known as pretty, and it's assigned by the system administrator or end user. What do you say we see some examples? So here in example 1, if you want to check the current host names, you can either execute hostname CTL or hostname CTL status for the command set. So another example, if you want to change the static hostname to new hostname, you can use hostname CTL set-hostname in square brackets new underscore hostname --static. Now we can move on to the resolve CTL command. So resolve CTL is used to resolve domain names, IPv4 and IPv6 addresses, DNS resource records, and services with the system d-resolve.service resolver service. Now by default, the specified list of parameters will be resolved as host names, retrieving their IPv4 and IPv6 addresses. If the parameters specified are formatted as IP either version 4 or 6, well, the reverse operation is done, and the hostname is retrieved for the specified addresses. Now, when you want to use this command, you can use resolve CTL in square brackets option triple dot, in curly braces command, and in square brackets name triple dot. Now, by the way, I will need to talk to you about the phrase A record. So if this expression is A, well, it means an IP address for IPv4. If it is AAA, it means an IP address for IPv6. All right, so let's go on to the dig command. It stands for Domain Information Groper. Now, this command is used to get information about DNS, and it's a command that's mostly used by network admins. It's used to verify, troubleshoot DNS problems, and perform DNS lookups. The dig command has replaced tools like NSLookup and host. And when you want to install this utility, you can use the sudo apt-get install DNS utils command set for Debian and Ubuntu. And sudo yum install bind-utils is a command set for CentOS and Red Hat. And here's the syntax of this command. It goes like this. Dig, server, name, type. So another command mentioned earlier is NSLookup. Now this command has similar functions to the dig command. It's abbreviation of name server search. So this command is a useful command to get information from the DNS server. It's a network management tool to query the domain name system, or DNS, to get domain name or IP address mapping or any other specific DNS record. It'll provide a very useful way to troubleshoot DNS-related issues. And the syntax of this command goes like this, NSLookup with an option. So for example, if you go to terminal and run nslookup google.com, well, you can display the A record of a domain name. So the host command. This is also a command used in Linux distributions for DNS lookups such as dig and NSLookup. The host command comes in handy, especially if it's used to find the IP address of a specific domain name, or if you want to know the domain name of a specific IP address. You can also find more specific details of a domain name by selecting the corresponding option along with the domain name. I'll show you the syntax. It's host, options, host name with the server. So if you run the host command without any options, you will list the general syntax of the command, the various options available with the host command, and a brief description of each option. If you were to execute host domain underscore name as your command set, you can display the IP address of the specified domain. Also, if you execute host IP underscore address command set, you'll be able to display the domain details of the specified IP address. Now here's another important command. It's whois. So whois lookup will give you a lot of information about who owns a particular internet domain name. Now, in Linux, you can actually run it from the command line by typing whois. We mentioned earlier that the whois system is a registry that contains both the ownership of domain names and details about the owners. The Internet Corporation for Assigned Names and Numbers, ICANN, regulates domain name registration ownership. However, the registry is maintained by different companies known as registries. There are some terms that you're going to need to know in order to understand that better, and these include, well, registry. Let's begin with that one. So this refers to a company that manages many domain names. Now, there are many companies that work on such domain name lists. And you'll come across the term registrant. This term will refer to the legal owner of the domain name. And finally, we'll talk about registrar. And this word just refers to an agent used by the legal owner of the domain name for the registration process. Now, when you open the whois record, it contains all the contact information associated with a person, company, or other organization that registered the domain name. Some include more information than others, and some records return different amounts of information. So when you open a whois record, you will be able to see the following information: registrant's name and contact information, registrar's name and contact information, date of registration, when the information was last updated, and the expiration date. For using whois in Linux, you can make a whois request on the web, just like in other operating systems. You can also search directly from the command line. Now, this is very useful if you need to call from a computer without any graphical user interface, or if you just want to do it from a shell script. Now, many Linux distributions come with a whois command installed. And if the need for loading arises for Ubuntu, you can use sudo apt-get install whois. And with Fedora, you can use sudo dnf install whois. So let's have a look at how to use the whois command with the domain name. You can use a whois command with domain names or IP addresses. A slightly different set of information is returned for each of these. So in our first example, let's use a domain name. So go to your CLI and run whois nytimes.com. So obviously it's pretty self-explanatory: contact information, registration dates, etc. And we see some various details about the registrar, the registration, including, well, there's several entries in the list that you may not recognize. The domain state lines show the state the domain is in and can be more than one at a time. So states are defined in the extensible provisioning protocol. And some of these are rare, while others are limited to specific situations, such as legal disputes. Now, of course, another way to use the whois command is to use it with an IP address. So you can go to the terminal and type in whois 151.101.113.164. Run it. And here you see the first section contains the information regarding the information that owns the IP address that we searched for. Second section contains the address and the name of the registrant. And the other sections contain contact information that allows you to report issues regarding abuse, network operation, traffic routing, and so on and so forth. And now we come up to network monitoring. All right, so especially when you're a system administrator, you would be expected to monitor the network system under your responsibility, as well as produce quick solutions to any problems that may arise. There are some commands and tools that are commonly used in Linux distributions for this purpose. Why don't we start with a TCP dump tool? So it's a packet sniffing and packet analysis tool, and it's used to troubleshoot connectivity issues in Linux. It's used to capture, filter, and analyze network traffic, such as TCP/IP packets passing through your system. And it's also sometimes used as a security tool. It saves the captured information as a PCAP file. You can open these PCAP files via Wireshark or a script tool itself. Now, many operating systems have this TCP dump command pre-installed. Otherwise, you can use the commands here to install it. For Red Hat, you can install it with yum install TCP dump, and for Ubuntu Debian, you can install it with apt install TCP dump. Let's start working with this TCP dump command. Now, if you want to capture the packets of the current network interface, use the sudo TCP dump command set. This will capture packets from the current interface of the network where the system is connected to the internet. If you want to capture packets from a particular network interface, you can use the sudo TCP dump -I, network interface name, and this command will capture packets over the specified network interface. Let's say you want to capture a certain number of packets. Well, just use the sudo TCP dump -C8-I, network interface name. And then this command will capture only 8 packets from the network interface. Well, let's say that you want to print the captured packets in ASCII format. You can use the sudo TCP dump -A-I, network interface name. And then this command will print the ASCII value of the packets captured from the network interface. If you want to display all available interfaces, just use sudo TCP dump -D. And this command will display all the interfaces that are available in the system. If you want to save captured packets into a file, you can use sudo TCP dump -W and square brackets file underscore name.pcap -I, network interface name. And now this command will output all the captured packets in a file named file underscore name.pcap. So we'll continue with another network analyzer tool called Wireshark. It's a free and open source packet analyzer. So it can be used for network troubleshooting, analysis, software and communication protocol development, and also for training. You see, Wireshark is very similar to TCP dump that we've described previously, but it has a graphical front end and integrated sorting and filtering options. Wireshark's local network trace file format is the libpcap format, supported by libpcap and winpcap. Therefore, it can replace captured network traces with other applications that use the same format, including TCP dump and CA netmaster. It can also read images from other network analyzers, such as Snoop, Network General's Sniffer, and Microsoft Network Monitor. But also, Wireshark is a data capture program that understands the structure, encapsulation of different network protocols. So it can parse and display fields with their meaning specified by different network protocols. Wireshark uses PCAP to capture packets, so it can only capture packets in network types that PCAP supports. So how about having a look at some of the advantages of Wireshark? In fact, Wikipedia's got a pretty easy list of them. Data display can be refined using a display filter. Plugins can be created for dissecting new protocols. VoIP calls in the captured traffic can be detected. If encoded in a compatible encoding, the media flow can even be played. Raw USB traffic can be captured. Wireless connections can also be filtered as long as they traverse the monitored Ethernet. There are various settings, timers, and filters to be set to provide the facility of filtering the output of the captured traffic. So what I want to talk about now is actually a terminal application. In other words, you can call it the terminal version of Wireshark. So this command line will prove very useful when a graphical user interface is unavailable. So while a GUI is theoretically easier to use, command line applications are much more useful for all environments, especially server environments with command-only options. So as a network administrator, you will need to use a command line interface at some point. So it's important to note that T-Shark is sometimes used in place of TCP dump. While both tools are almost equivalent in traffic capture functionality, T-Shark is actually much more powerful. All right, so let's start learning about T-Shark, how it works, what its features are, and how you can use it to the best of its capabilities. So let's have a look at the syntax of T-Shark. It's T-Shark with an option. Okay, so what about the options of this command? Well, you can always access its options just by typing T-Shark:\help. And let's have a look at some of them. -I, or interface, means the name or IDX of the interface, defined as the first non-loopback. -F, the capture filter, means packet filter in libpcap filter syntax. -S, or snaplen, this means the packet snapshot length, which defines the appropriate maximum. -P means don't capture in promiscuous mode. -L means capture in monitor mode if available. -B is the buffer size, and that means size of the kernel buffer, defined as 2 megabytes. -Y, link type, means link layer type, defined as the first appropriate. ~timestamp type means timestamp method for the interface. -D means print list of interface and exit. -L means print the list of link layer types of iFace and exit. ~list timestamp types means print the list of timestamp types for iFace and exit. Now, of course, before we can start to control the network traffic, we will need to know the network interfaces in the current system and choose one of them. And of course, you can use the T-Shark-D command set to list all the available interfaces. I do want you to note, though, that not all interfaces are operational. So type ifconfig to find the interfaces running on your system. So if you want to start the live capture process, you will need to use T-Shark command with the -I option. So the command set goes like this: T-Shark-I network interface. If you want to stop the live capture, you can use Control-C. And now we'll continue with yet another network analyzer command called netstat. The command can be used for network connections, routing tables, interface statistics, masquerade connections, multitask subscriptions, all kinds of things. If you want to, we can examine the netstat command along with its options. Before we dive into that, for TCP option T, for UDP option U, for Unix option X, these are the characters that we will use. If you want to display both listening and not listening sockets, you can use netstat-A pipe more. So to list all TCP ports, you can use netstat-AT. To list all UDP ports, just use netstat-AU. If you want to list only the listening ports, netstat-L. And if you want to display statistics for all the ports, use netstat-S. To get kernel routing information, just use netstat-R. And to get a list of network interfaces, netstat-I. All right, so there is another network analyzer command. It's called traceroute. So a packet on the network will follow a route to each destination. The traceroute command is very useful when there's a need for information about the route and hops that the packet follows. So to make this command clearer, we can go to the command line, type and run the traceroute google.com command set. So after running the command, you can see the route of the request packet from the local machine to reach Google host, as well as detailed information about all the different hops it visited in between. The first column in the list corresponds to the number of jumps. Second column represents the address of that hop. And after that, you'll see 3 times in milliseconds separated by spaces. So these 3 packets are the packets sent by the traceroute command. And then the times indicate the time of the packets reaching the hop. The syntax of this command is traceroute, options, host_address with a path length. Also, this command has a few options, so we can talk about these. If you want to use IPv4, you can use traceroute-4 google.com. If you want to use IPv6, go ahead and use traceroute-6 google.com. If you do not want a fragmented packet, you can use traceroute-f google.com. If you want to route the packet through the gate, you can use traceroute-g in square brackets hop-ip google.com. And there's another network analyzer command. It's called ping. Now, the term ping is actually short for packet internet groper. So its main purpose is to control the network connection between the host and the server host. This command takes the IP address or URL as input and sends a data packet with a ping message to the specified address. It receives a response from the server host in response to the packet it sent. And this response is called latency. So a fast ping means lower latency, faster connection. But it also comes with ping installed on every modern operating system. The response to the command is measured in milliseconds. So if you want to see the installed ping command version, you can use sudo ping-v. And if you want to ping www.google.com, you can always use ping www.google.com. Oh, and by the way, of course, I would like to remind you that you should use Control-C as your key combination to stop the ping. Otherwise, it's going to just continue to send packets. Okay, so now let's have a look at some of the features of the ping command. One of them is that you can actually specify the number of packets to be sent to the server. So if you want to specify the number of packets, you can use the command structure p-c, packets_number, IP address, /hostname. If you just want a summary, you can use the command structure p-sing, packets_number-q, IP address or hostname. And let's say you want to stop a ping after a certain amount of time, you can use the command structure ping-w up_time, IP_address or hostname. For example, ping-w5 www.google.com is going to stop pinging after 5 seconds of running the command set. So it's also possible to test network performance with the ping command. If we use the -f option, we can test this process with the ping-f www.google.com command set. So yeah, there's a variety of tools at your fingertips. So let's have a look at another network analyzer tool called MTR. It's It's actually a very powerful cross-platform network diagnostic tool that combines ping and traceroute functions. So MTR is an advanced variant of traceroute that displays in-depth information by determining the packet path to the target host. The report on the path includes a response percentage, as well as the response time of all the hops between the source and the target machine. Let's have a look at how MTR works. Network diagnostics probes the connection between the two devices with ICMP packets to troubleshoot network connectivity issues. So ping, traceroute, and MTR have the same working principle. But really, is there any difference? Well, the ping utility uses ICMP echo request and echo replies, whereas traceroute and MTR use ICMP packets with a time to live, or TTL. Now, as for MTR installation, it actually comes pre-installed on most Linux distros. If it's not installed, for Ubuntu, you can use the command set sudo apt-get-y install MTR. For RHEL, you can use the command set sudo yum-y install MTR. For Arch, just use the command set sudo pacman-y install MTR. So let's have a look at what kind of screen you're going to encounter when you run the MTR command, along with the options. So we'll run sudo mtr-r-c5 google.com. And with the -c option, the loop will run for that specified number of times and then exit after printing the stats. So pay close attention to the screenshot. The columns that you see here convey statistical data, so we'll start with the first column heading. Percent loss is the packet loss percentage at each machine. SNT means number of sent packets. The last is the round-trip time for the last traceroute packet. The average round trip for all probes. And the best means shortest round-trip time of a packet to a particular host. WRST. This is the longest round-trip time of a packet to a host. STDEV is the standard deviation of latencies. Now, the SNT2 WRST columns measure latencies in milliseconds, but only the average column matters the most. So why don't we talk about some of the options of MTR? So the MTR command uses IPv6 by default. If you actually want to use and view IPv4 addresses, that means you've got to use sudo mtr-4 google.com. But if you want to display both domain names and IPv4 addresses at the same time, well, you got to use the -b option. So your script will be more like sudo mtr-b google.com. Now, we mentioned before, it's up to you to limit the number of pings sent to each machine. You can use sudo mtr-c7 google.com for that process. So MTR, ping, traceroute. We'll get a report on all of these commands, so what's going to be our focus when analyzing the reports? Well, packet loss and network latency are very important in all of these reports, and making an evaluation according to loss and delay values is going to be helpful for whatever your solution. Now, as you know, our first heading is System Administration. Our fifth subheading is Use Network Tools or Configuration Files. Another subheading of this topic is Remote Networking Tool. Now, when it comes to remote access and management in Linux systems, SSH is the first thing that comes to mind. So SSH is a client-server service that provides secure encrypted connections over a network connection. SSH servers allow remote connections from SSH clients. Now, technically, anyone can connect to your system if there's no security configured on the SSH server. It may try to log in, and even if they fail to authenticate, the amount of bogus traffic coming into your system wastes bandwidth and system resources. Now, to clarify, SSH stands for Secure Shell. So it's a protocol used to securely connect to a remote server system. The reason SSH protocol is secure is that it transfers data between the host and the client in encrypted form. SSH runs on TCP/IP port 22. SSH servers come with lots of configurable security settings, and as a result of this configuration, you can control or increase your security level. All right, so for the syntax of this command, you're looking at it, SSH, in square brackets, user_name at host with the IP domain name. And as you've noticed, the SSH command consists of 3 different parts. We've got SSH command, the username, and the host. So let's break down these parts. SSH command is where the system is instructed to establish an encrypted secure connection to the host. Username, of course, represents the account being accessed on the host. And the host actually refers to the machine being accessed, which can be a computer or a router. It can be an IP address or a domain name. There's another command that I want to introduce you to. It's called curl or curl. It's a command line program used to transfer data to and from a server using any protocol your current system supports. All right, so have a look at some of these and you'll know them. HTTP, FTP, IMAP, POP3, SCP, SFTP, SMTP, TFTP, Telnet, LDAP, or file protocols. So curl does not need user interaction. It's a command that allows transferring multiple files at the same time. I'll show you the syntax for this command, curl with options, and then the URL. For example, curl https://www.google.com. I want to show you another utility. It's called wget. So the wget is a command with different features than some of the other commands we've talked about so far. You can use this command to download files from the server even if the user's not logged into the system. It's a non-interactive network downloader, so it can run in the background without interfering with the current process. GNU wget is a free utility for non-interactive downloading of files from the web. It supports HTTP, HTTPS, and FTP, as well as retrieval via HTTP proxies. This utility downloader is specifically and specially designed to improve stability on slow or unstable network conditions. Now, in cases where stability is compromised, that is, when the download fails, it keeps retrying until the entire file is retrieved. So if the server supports resume, it will instruct the server to continue downloading. Let's check out the syntax for this utility. It goes like this, wget option URL. So yeah, there's a few different options about wget. So some are similar to some of the other command options, and we can just have a look at the different ones. We've got a -o log file. So this is used to redirect all system-generated messages to a log file that you specify. So when the process is complete, all messages generated in this way are in the log file. The syntax for this command goes like this, wget-o log file with the URL. -b/-background means send the download to the background as soon as the process starts so that other operations can be done. And the syntax for that is wget-b with the URL. The -a option allows the logs to be written to the existing log file as new logs. And the syntax for this command is wget-a log file with the URL. The -i option is used to read URLs from the file. If -i is specified as a file, URLs are read from the standard input. Now, URLs are not required on the command line if this function is used. So that means the syntax for this command looks like this: wget-i input file or wget-i input file URL. The -t number or -tries equals number. This is the option to use to set the number of retries to a certain number of times. Now you must specify 0 or INF for infinite retries. And the syntax for this command goes like this: wget-t number URL. That leaves us with the -c option, and this is used to resume the download if a file has the ability to continue and has been partially downloaded. The syntax for this command looks like this: wget-c URL. Now, we've got a few examples for you. If you simply want to download a web page, you can always use wget with the http urlname.com/page_name.php. And if you want to download the file in the background, you can use wget-b http://url_name.com/page_name.php. /url_name.com/sample.tar.gz. I want to tell you about another network management tool. We mentioned earlier Netcat, and this tool can be used for networking security and network monitoring. And you want to use this in a few different places: operations on TCP, UDP, or Unix domain sockets. You can use it for port scanning, port listening, port redirection. You can even open remote connections, data read-write over the network, network debugging, network daemon testing, and simple TCP proxies. So if you want to install the Netcat tool, you got to choose the appropriate command structure according to your Linux distribution. So that means for Debian and Ubuntu, you can use sudo apt-get install netcat. For CentOS and RHEL, you can use the yum install nc command set. For Fedora 22 Plus and RHEL 8, you can use dnf install nc for your command set. Yet another network utility tool is rsync. So sync, or rsync, stands for synchronization and remote synchronization. Now, the main task here is to ensure efficient synchronization of files and directories between two hosts or machines. There are basically two ways rsync can copy or sync data. Copy sync to, from, another host via any remote shell like SSH or RSH. Copy sync via rsync daemon using TCP. The syntax of rsync goes like this: rsync with options, source with a destination. So let's have a look at some of the options that you can use with the rsync command. -a or --archive puts it into archive mode, and it'll include all the necessary options, such as repeatedly copying files, protecting almost everything. -h or --human means it's going to output in human readable format. -z or --compress means it's going to compress the file data during transfer. So here's another network command. It's scp. So in Linux systems, scp is secure copy. It's a great command that's used to securely copy files between servers. So the scp command, or secure copy, allows files to be securely transferred between a local host and a remote host, or between two different hosts. scp stands out for its simplicity, security, and preloaded usability. So the syntax of this command looks like this: scp options, user at host 1, file 1, user at host 2, and file 2. But I want to take you through briefly some of the options for this command. Secure copy -P port means, well, it specifies a port to connect to on the remote host. SCP-P with a small p preserves the modification times, access times, and modes in the original file. SCP-Q, well, disables the progress meter. SCP-R recursively copies all directories. SCP-Big S, well, this just means the name of the program to use for the encrypted connection. And then, of course, there's the file transfer protocol that most everyone is familiar with, SFTP. SFTP stands for Secure File Transfer Protocol. So yeah, it's a file transfer protocol used for transferring files between clients and servers. Now, it's also known as Secure Socket Shell File Transfer Protocol. So this protocol provides secure access to a remote server for secure transfer of files. SSH offers enhanced security by owning the entire file transfer session. It only opens on a single port on your firewall, instead of the two that need to be opened for FTP and SSL connections. And all session control commands are always fully encrypted. Now, within our first title of System Management, we're up to the sixth subtitle, Build and Install Software. So within this topic, we're going to cover package management. So you now know much better that there are many different distributions of the Linux operating system. And when distributions are different, naturally the way they manage packages will be different. So package management is actually much more important in Linux than in any of the other operating systems. Knowing how to use multiple package managers, downloading or installing software from repositories, being able to update, handling dependencies, and uninstalling software are indeed critical issues for a system administrator. So first, let's talk about DPKG. This is short for Debian Package Management System. So dpackage, as the name suggests, is a basic package management system for the Debian Linux family. So it's used to install, remove, store, and provide information about .deb packages. It's a low-level tool. Other front-end tools are required to help users retrieve packages from remote repositories or manage complex package associations. One of these packaging tools is the advanced packaging tool known as APT. This happens to be a free, powerful, and moreover useful command-line package management system that's very popular among users. But there is another, Aptitude Package Manager. So this front-end package manager also works pretty similarly to APT. It was originally built for Debian and its derivatives, but now its functionality extends to the RHEL family as well. And that brings us to, finally, the Synaptic Package Manager. So Synaptic is a GUI package management tool for APT, and it's suitable for users who really don't want to mess around with the command line. Not that you don't need to learn it. But there's another package manager. It is called RPM, short for Red Hat Package Manager. And RPM is a basic package management system, but it's created by Red Hat. And here too, just like dpackage, there are several front-end package management tools that you can use together. The most prominent of these is known as Yum. You've heard us mention that several times. Yellow Dog Updater Modified is what that stands for. It's an open source and popular command line package manager that works as an interface to RPM for users. And there's also a new generation version known as DNF, or Dandified Yum, and a few other package management tools that you might run into. Pacman Package Manager, mainly used by Arch Linux users. Zipper Package Manager. This is a command line package manager in OpenSUSE Linux. Portage Package Manager is a package manager for Gentoo that is not really as popular as other distros. So here we are at sandboxed applications. So one of the sandbox applications is known as Snapd. So Snap, this is a package management system and software distribution. Now, usually these packages are called snaps. The tool for using snaps is called Snapd. Snaps are way easy to install, cross-platform application packages for the cloud and desktop. Snaps actually work on all Linux distributions, so it can be used across cloud, desktop, and servers, whatever you got. Snapd is a daemon or process that manages Snap's entire environment. The other sandbox application is called Flatpak. Flatpak is also a utility for software distro and package management for Linux. And going back to the almighty Wikipedia, it is advertised as offering a sandbox environment where users can run the application software separately from the rest of the system. Now, applications that use Flatpak must have permission to access resources like Bluetooth, audio networks, and files even. And these permissions are defined by the owner of Flatpak and can be added or removed by the users on their system. Another key feature of Flatpak is that it allows app developers to provide updates directly to users without having to go through distros and having to package and test the app separately for each distro. The other sandbox application is called AppImage, aptly named. And once again, according to Wikipedia, the AppImage is a format for distributing portable software on Linux without needing super user permissions to install the application. AppImage aims to be an application deployment system for Linux with the following objectives: simplicity, binary compatibility, distro agnosticism, no installation, no root permission, certainly portable, and keeping the underlying operating system untouched. So now we'll cover system updates. So we have two important headings here, right? The first of them is kernel updates. So the Linux kernel is the actual unit that enables the user, software, and hardware to work together by providing an interface between software applications and computer hardware. So from this point of view, you could consider the Linux kernel as the central kernel of the operating system. It's the underlying Linux kernel that all different Linux distributions run on. So as technology advances and needs arise, developers discover patches and updates to the Linux kernel, and these patches can improve security, add functionality, and even improve operating system operating speed. So if you are using a Linux operating system, checking and updating the kernel regularly can be a good but somewhat risky idea. Well, for example, let's try to update the Linux kernel for the Linux Ubuntu distribution. But before you start working on it, make sure that you have a server with Ubuntu installed, an account with administrative privileges, and your APT tool. So first we'll check the current kernel version. You can use the uname-sr command, and you'll be able to have a look. So in the terminal, you'll see an output in the form of Linux 4.4.0-64 generic. Now the first two digits, 4.4 in this case, show you the general kernel package. The third digit, the version, the fourth digit, will show you the level of patches and fixes. And now moving on to the second step, it's at this level that we'll update the repositories. Now for the update, let's go to the terminal and type sudo apt-get update. And then as a result of the execution of this command, our local software list will be refreshed. The system will note newer revisions and updates. And if there is a newer version of the kernel, the command will find it, flag it for download and installation. Then the third step is we can now run the upgrade. So then we'd go to the terminal, run sudo apt-get dist-upgrade. Now here we should open a parenthesis to the dist-upgrade key. This switch prompts Ubuntu to handle all dependencies intelligently. That is, if a particular software package is dependent on another software package to run, This command will make sure that the second package is upgraded before upgrading the first package. Now, this method is the safest way to upgrade your Ubuntu Linux kernel. Kernel updates available through this utility will always have been tested and verified to work with your version of Ubuntu. I would also like to remind you at this point that there are other upgrade methods besides this. So earlier I said that we have two important subheadings with system updates, right? The first was kernel update, and the second one is package updates. Now, just like in other operating systems, system maintenance of the Linux operating system ensures that the system is safe and maintains a sustainable operation. Other operating systems have scheduled windows or interactive alerts for package updates. Since there are no specific scheduled windows for Linux to release package updates, well, that means you're going to need to update the package periodically, like at least once a month. At least you can check. But anyway, you want to ensure you get the latest updates. So we call the files used in package updates patches. Although there are many alternative methods for installing patches, most companies prefer to install only the security patches necessary to make the system more stable and secure. We can actually list the package update methods as installing the full patch with security, bug fixes and enhancements, installing security patches only, and installing security and bug fixes. So now, why don't we have a look at how to list available package updates in various Linux distros. So I want to first have a look at how package updates are done for CentOS RHEL 6 and 7 distributions. As you may know, the default package manager for these systems is yum. There are 3 different ways to check and update packages using yum. First method might be easy to deduce, yum check-update. So when you run this command, it cannot update. It just returns a list of packages to be updated in a list format. Second method to use is yum list update. However, this command is also similar to yum check update. It just returns a list of the packages to be updated in list format. Now see here, the third method is yum update, which actually updates the currently installed packages to the latest version if there is a package update. So to explain that briefly, the first and second methods only list the packages that contain the update, but this third method also updates after the listing. CentOS 8, RHEL 8, and Fedora use the DNF package manager. Now, there are 4 different usage styles for performing update-related operations using the DNF command. Our first method, well, it's to use the DNF check-update. This command will only return a list of packages to be updated in a list format. Second method would be to use the DNF list update, and this command is very similar to DNF check-update, and it only returns a list of packages to be updated in a list format. So we've got a third method, DNF update. So when you execute this command, it will update the currently installed packages to their latest versions if updates are available. But here's where it differs. So the fourth method is to apply the DNF update info command set. And this command will list all the recommendations found in the system. The Arch Linux distribution uses Pacman for package updates. This distribution uses the Pacman command line utility to install, create, and remove managed packages. So with this command, the Pacman-QU command set is used to query and filter out of date packages on the local system. So you'll also need to run Pacman-QU pipe WC-L if you want to count the number of packages that can be upgraded. Now in the OpenSUSE system, the zipper package manager is used, and this command will be used to get an update list or to update. So if you want to see packages updated in list format, well, you can use the zipper list-updates command. If you want to find packages with available updates and install the updates, you can use the zipper update command set. Now in Debian Ubuntu, which is widely used, apt and apt-get are the commands that are used for package update operations. But before checking the list of package updates, we're going to need to refresh the repository metadata with apt-update or apt-get update. So you have 5 different command options to perform the renewal process. Let's go through them. apt-list --upgradable. This returns a list of packages to be updated in list format. apt-get upgrade --dry-run means return a list of packages to be updated in list format. apt-get-s upgrade returns a list of packages to be updated in list format. apt-upgrade will update currently installed packages to their latest versions if updates are available. apt-get upgrade means it will update currently installed packages to their latest versions if updates are available. Also, apt-upgrade and apt-get update commands will give you a list of packages to be upgraded as well as the total download size. So if you want to count the packages that need to be upgraded, you can just use apt-list --upgradable pipe wc-pipe-l. All right, so we are still within System Management, and we've arrived at Manage Software Configurations. So we're going to have a look at updating configuration files. So I want to review a little bit more about RPM new. This is the file. You see, an RPM new file is a configuration file created during the installation of the RPM file created with Red Hat Package Manager. So it contains the new default settings for Unix configuration, .conf file that you changed previously. RPM new files are generated so users can compare the updated configuration defaults of a package with the modified configuration files. The user can then apply the changes made to the RPM new file as you see fit. So typically, RPM packages produce RPM new files instead of RPM save files. So this ensures that users' modified configurations remain in place after the update is complete. You see, if a user wishes to apply any of the new default settings listed in an RPM new file to the corresponding conf file, they can just by examining the RPM new file and manually updating the conf file to match as needed. But I do also want to remind you that RPM new files usually have the .rpmnew extension appended to the name of the corresponding conf file. For example, an RPM new file that contains a new default configuration for httpd.conf will be named httpd.conf.rpmnew. So how do we go ahead and open and edit these files? Well, since RPM new files are plain text files, you can open and edit them in just a regular text editor. GitHub Atom is cross-platform. GNU Emacs, that's cross-platform. Vim in Linux or any similar editor is welcome. If you want to apply changes from an RPM new file to the corresponding conf file, well, you must update or replace the conf file to which the RPM new file corresponds. So, for example, you can open both the RPM new file and the conf file in a text editor and selectively copy the RPM new file's updates to the conf file. The .rpm save extension talked about earlier when we were talking about RPM new files. But what do you suppose the RPM save file is? Yeah, so this file, like the RPM new file, is a configuration file created by the Red Hat Package Manager during the installation of a .rpm file. But now it contains previously changed settings that you have stored in an updated Unix configuration or .conf file. So I want to take you through repository configuration files. So the first of the repository configuration files we call apt.conf. So apt uses a configuration file, and it resides at /etc/apt.conf. apt.conf is the main configuration file for the apt toolkit. In fact, all tools will use the config file and a common command line parser to provide a uniform environment. Now, when an apt tool is started, it will read the config specified by the apt_config environment variable, if there is one, and then read the files in directory :etc: parts, and then read the main configuration file specified by directory :etc: main. And finally, apply command line options to override config directives, possibly loading even more config files. A second repository configuration file would be called yum.conf, and yum uses a configuration file at /etc/yum.conf. There's a couple of types of sections in yum config files. So these are the main and the warehouse. Main defines all common configuration options. There should only be one main partition. The repository partitions will define the configuration for each repository server. So there must be one or more warehouse partitions. The third of the repository configuration files is called dnf.conf. So dnf uses a configuration file at /etc/dnf/dnf.conf. The configuration file for DNF and related utilities is located in /etc/dnf/dnf.conf. Now, this file contains a mandatory or main section that allows you to set DNF options with global effect, and may also contain one or more repository sections that allow you to set repository-specific options. Now, the values that you define individually in the repository sections of the /etc/dnf/dnf.conf file override the values set in the main section. But on the other hand, another title will be the sources.list or sources.list.d files. Now, it's pretty common to find instructions for adding a det store resource as a shell script. Normally, something can be added to /etc/apt/sources.list. Some system administrators prefer to create a separate file for each repo on /etc/apt/sources.list.d. Which brings us to configure kernel options. So we start our topic with the system control command. Systemctl is used to inspect and control the status of the systemd, System and Service Manager. Systemd is the System and Service Manager in most distributions for Unix-like operating systems. The first process created at system startup, that is the init process with PID equals 1, is the systemd system that starts the user space services. So the syntax of this command goes like this: systemctl options command name. So I want to talk about some of these options. -t or ~type equals, the argument in this case should be comma-separated list of unit types, such as service and socket. ~state equals, well, it's used to show only specified states. For example, ~state equals failed will show only failed units. -a or ~all, this shows all units regardless of their states. -r, ~recursive, although it lists units, it shows units of local containers as well. ~show-types shows types of sockets along with showing sockets. ~job-mode is the option that controls how to deal with already queued jobs in case of queuing a new job. "fail" means, well, it's similar to "job-mode equals fail." "I" "ignore" inhibitors. Well, when you request system shutdowns or sleep states, it will ignore inhibitor locks. "Q" or "quite" means suppressing printing of results of various commands and the hints about the truncated lines. "no block." This means don't wait synchronously for processes to finish. "user" means to talk to the service manager of calling user instead of system. "no wall" means don't send wall message before power off, halt, or reboot. "F" or "force" means when used with enable override any conflicting symlinks. "message" equals when used with halt, power off, reboot, kexec. Well, you can display a short message specifying the reason of the operation. "N" lines, when used with status, controls the number of journal lines to show. "H" or "host" equals execute operation remotely. So let's continue along with a few examples. So let's say you want to suspend your system. You can use the systemctl suspend or systemctl-I suspend command sets. Now, if you want to see the applications that are currently in the failed state, you can use one of these: systemctl-fail or systemctl-job-mode equals fail. So let's examine the commands that can be used with system control. If you want to list all units, just use the systemctl list-units pattern command set. If you want to list socket addresses sorted by listening address, go ahead and use the systemctl list-sockets command set. If you want to sort units by elapsed time, you can use the systemctl list-timers command set. And if you want to start, stop, restart, or reload a service, you can use the systemctl start pattern, systemctl stop pattern, systemctl reload pattern, and systemctl restart pattern command sets. So moving right along with sysctl.conf. So sysctl uses a configuration file at /etc/sysctl.conf. Now in Linux, the sysctl command gets used to dynamically act as an interface to change kernel parameters. So by using this command, you can change kernel parameters without recompiling the kernel or rebooting the machine. Now the parameters that can be changed are found under the /proc/sys directory. Therefore, procfs, or file system simulation to be able to communicate with the kernel via file system, is mandatory for sysctl. And incidentally, only the super user or root can execute this command. Now, earlier we mentioned that you can change kernel parameters using the sysctl command. You can actually make two types of changes to kernel parameters, temporary or permanent. So to temporarily change the kernel parameters, it's necessary to read the existing kernel parameters. And you can do that by executing the sysctl-a command set. So after reading, you will need to pass a value to a variable, and we can use the -w option for this operation. So for example, let's say you want to order a server to ignore ICMP packets to be forwarded. Well, the command set you would need to apply would go like this: sysctl-w net.ipv4.icmp_echo_ignore_all equals 1. So this ignore_all equals 0 would mean the ignore order is off. And ignore_all equals 1 just means ignore order is on. So this is a temporary change and will disappear when the system restarts. But if you do want to make permanent changes to kernel parameters, you have to directly change the values in procfs. So these files are located in /proc/sys directory. For the permanent version of the example, and this command will disable ICMP packets. We would execute the command echo 1 /proc/sys/net/ipv4/ICMP_echo_ignore_all. So now we'll continue with lsmod. So the lsmod command gets used to view the status of modules in the Linux kernel. So it displays a list of installed modules when you run it. So lsmod is a program that displays the formatted contents of proc modules and which kernel modules are actually loaded. Here's the syntax of the command lsmod. And if you want to, we can go now to the terminal to run the command. And as you can see, we have a list with 3 columns. So the first column is for the module name. The second column is for the size in bytes. Third column is for the number of instances of the module used. Okay, we'll continue with insmod. So in Linux systems, the insmod command is used to add modules to the kernel. Linux is an operating system that allows the user to load kernel modules at runtime to extend kernel functions. LKMs, loadable kernel modules, are often used to add support for new hardware, such as device drivers and/or file systems, or even adding system calls. So the command here adds the kernel object file .ko to the kernel with or without arguments, along with a few additional options. So the syntax for this command looks like this: insmod, file name, module options. Okay, for our next command, rmmod. So in Linux systems, the rmmod command is used to remove a module from the kernel. The syntax of the command looks like this: rmmod, options, module name. The -v option prints messages about what the program's doing. It prints messages especially when something goes wrong. So you can use the -f option to remove certain modules that are in use or that are not designed to be removed or marked as unsafe. And of course, its use can be very risky. But it has no effect unless config_module_force_unload is set when the kernel is compiled. This requires administrator privilege. So Linux users can use the modprobe command instead of adding and removing modules to the Linux kernel that we mentioned earlier. So you can load a module into the kernel manually or automatically using this command. Now I want you to make note that users with administrative privileges can manage kernel modules. If you want to install a module, you must execute the sudo modprobe module_name command set. Oh, and by the way, please note that you can only specify one module on the command line. The mod probe command will install the given module and additional module dependencies. And if you want to verify the module installation, you can use the lsmod pipe grep module _name command. But usually you will need to load the module during system boot. And you can do this just by specifying the module and its parameters in a file in the /etc/modules-load.d directory. Now, files must end in .conf, and they can basically have any name, but you can use a command set /etc/modules-load.d/module_name.conf. And you can use modprobe-r module_name command set to remove a module from the kernel. And modprobe will also remove unused module dependencies. Now, another command for kernel modules is modinfo. So the modinfo command is used to display information about the Linux kernel module. Now, this command extracts information from Linux kernel modules given on the command line. If the module name is not a file name, the /lib/module/kernel-version directory is searched by default. Modinfo can understand modules from Linux kernel architecture. In fact, the syntax for this command looks like this: modinfo -0-f field-k kernel modin pipe file name. Which brings us to configure common system services. So that means we'll start with SSH. As you know, SSH has a very important place in Linux, standing for Secure Shell. Of course, you remember that it's been mentioned in some of these earlier topics from time to time. So it's a protocol used to securely connect to a remote server or system. SSH is secure because it transfers data between a host and a client in encrypted form. SSH runs on TCP/IP port 22, and the syntax for this command looks like this: SSH user_name @host IP or domain name. Now, when you examine the syntax, you will see that the SSH command consists of 3 different parts. So let's break it down. SSH command, the username representing the account being accessed on the host, and the host representing the computer being accessed or the machine, and it could be a router. Now, while performing operations with the SSH command, a session is opened on the host. These post-processing commands will work as if they were typed directly into the host terminal. To secure their connection, we'll recommend using a public-private key pair, SSH key pair, or password to log into the remote host. However, a public-private key pair and the SSH key pair are more secure than using a password. The command set to be used to generate public-private keys will be something like SSH-keygen. Now, the public key must be copied to the remote host, while the private key must remain hidden. And then once the public key is generated for the connection is copied to the host, the connection will be established using SSH keys, not by using passwords. So let's have a look at some of the options for this command. -1 means forcing SSH to use only the SSH-1 protocol. -2 forces SSH to use only the SSH-2 protocol. -4 means only allowing IPv4 addresses. -6 only allows IPv6 addresses. -A stands for Authentication Agent Connection Forwarding is enabled. -a means Authentication Agent Connection Forwarding is disabled. -big C means compressing all data for faster data transfer. -F request SSH to go to the background just before command execution. A -G means allowing remote hosts to connect to local forwarded ports. -N prevents reading from stdin. -P port number means the port to connect to on the remote host. -Q means suppress all errors and warnings. All right, so moving right along, we've got NTP, short for Network Time Protocol. So the Network Time Protocol, or NTP, is a protocol that helps computers synchronize their clock time on a network. The NTP protocol is responsible for synchronizing of hosts in a TCP/IP network. So what are the advantages of NTP? Well, the absolute first thing that comes to mind will be to provide internet synchronization between devices. So it definitely plays a role in providing enhanced security within the facility. It's used in authentication systems such as Kerberos, and it's used in file systems that are difficult to synchronize on the network. Now, there are distinct disadvantages using NTP, and one of those would be when the servers are down. Well, the sync time will be affected in a working communication. But on the other hand, servers located in different time zones are prone to error due to this time difference, and the conflict may occur. Synchronization may conflict when NTP packets are increased, and manipulations can also be made with synchronization. So moving right along, we'll continue with another topic called syslog. So I want to talk to you about the syslog protocol, which is a standard for message logging. It's used for system administration, system auditing, general information analysis, and debugging. The syslog protocol has a layered structure and basically uses 3 layers. The first layer is the system log content, which lives the information of the payload in the system packet. The second layer is the system log application, which analyzes and processes the creation, interpretation, routing, and storage of its messages. The third layer is system log transport, and it's responsible for transporting messages. So we're going to continue now with CronY, a flexible network time protocol, or NTP application. CronY can synchronize the system time with NTP servers, reference clocks, such as a GPS receiver, and manual input via wristwatch and keyboard. It also allows other computers on the network to receive updates in a timely manner. Now, during boot, CronY synchronizes the computer's internal clock with higher stratum NTP servers, a reference clock, or the computer's real-time clock. In a LAN, the precision between 2 synchronized machines is usually within a few milliseconds. CronY is basically divided into 2 systems. These are CronYC and CronYD. So CronYC is a command line interface tasked with monitoring and adjusting the output of CronYD. CronYD is a daemon running in the background that starts and activates the CronY NTP service and then monitors the time and status of the time server. So now I want to cover localization. So, of course, there's a number of time management tools in Linux with which you can view the current time zone in your Linux system. We've got time, date, CTL, date, and many more. If you want to quickly use the time, date, CTL command, it's sufficient to go to the terminal and type time, date, CTL right here on the command line. And as you can see, it displays the time and time zone information on the screen. Another method of time management is to use the cat command. And just like we learned earlier, the cat command displays the contents of a file. But with this command, we will search for a file called time zone in the /etc Linux directory, and that'll give us our time zone. etc, well, I guess I don't need to remind you that there's a Linux directory containing all the system configuration files. And we can do this just by going to the terminal, running the cat/etc/timezone command set, or cd/etc, and then cat timezone. And yet another method to display the time zone is to use the date command. We can do this just by going to the terminal and typing the date command and running it. So another stage of customizing the operating system used is to specify a set of environmental variables that define the user's language, region, and custom variable preferences that the user wants to see in the Linux interface. System libraries and local aware applications on the system use these environmental variables. So these local settings usually consist of at least one language code, one country or region code, time date format, number format setting, currency format setting, color setting, and others. So, of course, our second title is Security, and our first subtitle is The Purpose and Use of Security Best Practices Within a Linux Environment. Sounds pretty important, huh? So let's get to it. The first thing that we're going to cover, though, is the purpose and use of security best practices within your Linux environment. It's managing public key infrastructure certificates, or PKIs. All right, what are you waiting for? Let's do this. I don't need to tell you that security is an important concept for every single operating system out there. Of course, various methods are available to ensure the protection of confidential and private data. So this public key infrastructure, or PKI for short, is the governing and overseeing body behind the issuance of digital certificates. So its mission is to help protect confidential data and provide unique identities. It gives these unique IDs to users and systems. See, so in this way, it provides security in communication. The public key infrastructure uses a pair of keys, actually. The first type of key is the public key, and the other is the private. So public keys are the ones that are vulnerable to attacks. A solid infrastructure is needed to secure these keys. So it might just be a great time to look at the management keys within the crypto system. So the security of an encryption system depends on the security level of its keys. That's why it's important to have solid key management systems in place. So key management is going to have three parts, mainly. Let's have a look. So first, of course, the encryption key is a piece of data that's got to be managed by security management. Second, it's also known that the key has a life cycle, and the cycle should be managed for security reasons as well. For an example, a key life cycle might consist of generation of key, the establishment of the key, and storage of the key, uses of the key, archival, as well as destruction of the key. Now, third, it's necessary to keep the private key secret and provide the public key. So the private key should be private. So that means it only belongs to the owner. It should be kept in a region that only they can access. The public key specifies the open fields. Therefore, the purpose of the public key should be clearly defined. So PKI, or public key infrastructure, it aims to provide assurance of the public key. We all need assurances. So why don't we just examine the digital certificate classes, and then you'll see what I mean. It's possible to collect digital certificate types in 4 different classes. In fact, I'll show them to you. Class 1 can only be obtained by providing email addresses. Class 2 requires more use of personal information. Class 3 first checks the identity of the person making the request. Class 4 is the one that's going to be used by organizations and governments. So PKI has become quite popular thanks to the problems that it solves, and some of the use cases of PKR include ensuring the security of web browsers and communication networks with SSL, TLS certificates, protection of access rights over intranets and VPNs, data encryption, digitally signed software, password-free Wi-Fi access. Now, of course, because it has such a wide area of use, there's a few disadvantages of PKI, and that's going to be speed and the private key compromise. Now, PKI slows down the process and the transfer of data due to the complex algorithms that it uses. PKI is difficult to hijack, though, for normal users. But in the hands of a professional hacker, a private key can actually very easily be compromised. But you see, PKI uses both public and private keys to encrypt and decrypt data. So it's pretty good at ensuring that the user's private key and public key are kept separate and used only when needed. Which brings us to another subheading. This is called the self-signed certificate. A self-signed SSL certificate is one signed by the person who created it rather than a trusted certificate authority. See, self-signed certificates can actually have the same encryption level as a trusted CA-signed SSL certificate. Web browsers do not recognize self-signed certificates, though, as valid. And when using a self-signed certificate, the web browser displays a warning to the visitor the website certificate could not be verified. Self-signed certificates are often used for testing purposes or internal use. So it's definitely not recommended to use a self-signed certificate on production systems exposed to the internet. And that brings us to the wildcard certificate. So wildcard certificate is a kind of digital certificate that is applied to a domain and all of its subdomains. What about certifying authorities? Well, a CA's job is to issue and verify certificates. This authority ensures that the information in a certificate is true and accurate, and digitally signs a certificate as well. So a CA or a certificate authority will perform these basic tasks: generating key pairs, providing issuance of digital certificates, allows the issuance of certificates, provides verification of a valid certificate, also allows cancellation whenever necessary. So another topic that we need to learn in the purpose and use of security best practices in a Linux environment is certificate use cases. All right, so let's have a look at SSL and TLS. You must know by now, SSL stands for Secure Socket Layer. TLS stands for Transport Layer Security. So both of these protocols aim to protect sensitive information that's used during transactions, such as payment transactions, that require authentication to prove the identity of the server to users. So SSL is an encryption protocol that uses open connections to establish secure communication between web server and the client. So this protocol, which has been published in 3 versions, has been deprecated as insufficient. TLS, on the other hand, is an encryption protocol that provides secure communication between the web server and the client through implicit connections. So it's a successor of SSL. The first 2 versions of this protocol, which have 4 versions to date, have been deprecated, though. So what do you think is going to be safer, SSL or TLS? Well, compared to SSL, TLS, yes, is more secure, providing more robust message authentication system, key material generation, along with other encryption algorithms. So before any data transmission, the TLS protocol requires both client and server to authenticate each other. So then, which is the latest TLS version? Well, we've got TLS 1.3, and that's the latest version of the TLS protocol. TLS, which is pretty much used by HTTPS and other network protocols for encryption, is the modern version of SSL. All right, so what about certificate validation? Okay, so we mentioned earlier that public key encryption should be used for authentication. It requires that the public key be copied from every client to every server that the client plans to log on to. So this requirement does not actually scale that well, and it may actually even become a burden for the administrative system. So you see what's next, right? Using a public key from a certification authority, or CA, to authenticate client certificates eliminates the need to copy keys across multiple systems. Now, that leads us to encryption. By now, you may know that passwords are one of the most basic security features in use today. It's obviously important to have secure and unguessable passwords. Most Linux distributions have password programs that do not allow you to set very easily guessable passwords, and Well, there's even a whole lot of encryption software out there on the market that can do this as well. But the point to be considered here is to make sure that your password program is always up to date and has such features. See, nowadays, encryption software is actually a huge necessity. There are many ways to encrypt data, and each method has its own characteristics. Most Linux distributions essentially use a one-way encryption algorithm called the Data Encryption Standard, or DES, to encrypt passwords. So these encrypted passwords are then typically stored in the /etc/password or etc shadow directory, but that one's kind of less common. So when the user tries to log in, right, the password entered is encrypted again and compared to the login in the file where that password is actually stored. And then if they match, the user is allowed access. Well, what do you know? It's time to talk about IPsec applications. You know about IPsec, right? Internet Protocol Security. So it's always necessary to establish cryptographically secure communications at the IP network level. Now, these are the result of the work of the IETF, or Internet Engineering Task Force. Sounds like a team of superheroes, doesn't it? But anyway, they ensure integrity, access control, authentication, and privacy. In fact, a freely available IPsec implementation on Linux is Linux FreeS-WAN IPsec. Such services will allow the user to create secure tunnels through untested networks. So it's thanks to the tunnel, passages through the unsafe environment will be secured. Now, another subtitle we have here is PAM, and that's Pluggable Authentication Modules. Say what? Yeah, because newer Linux versions come with a federated authentication scheme called PAM, P-A-M. Allows the user to change authentication requirements and methods on the fly. It also eliminates the need for all local authentication methods. Why don't we zoom in and have a look at what you can do with PAM? You can restrict users on ports and times. It can also impose resource limits on all of its users so they wouldn't be able to carry out denial of service or DOS attacks. It uses encryption other than DES to make their passwords harder to decrypt with brute force, and instantly enables shadow passwords. So the third topic that we will cover here in Security Best Practices in a Linux Environment is authentication. So here's our new title, Tokens. So this topic will include token authentication concept and token authentication configuration. Well, why don't we just knock off the concept then? See, one way to ensure security is to use two-factor authentication. So in this method, the users provide two forms of identity, right? For example, a single identity factor such as a password will be required, plus a second factor in the form of an authentication token. So this method provides a more reliable level of user authentication than a simple two-factor method of reusable passwords. And that leads us to Secure ID token authentication. Secure ID software tokens are used as binary programs that run on a workstation, loaded onto a smart card, or run as a plugin to a web browser. For example, Secure ID software tokens can run as an application. The application displays a window where the user enters a personal identification number or PIN, and the software token calculates the password. The user can then authenticate by entering the password in a login form. Now, users have three different options to generate Secure ID PINs. They are user-defined, system-generated, or user-selectable. And we're moving right along here now to multi-factor authentication, or MFA. So multi-factor authentication requires users to provide multiple forms of information to successfully authenticate to an account or Linux host. Specifically, when you sign into an account or device, you're prompted for a username and password. Additional information requested can be a one-time password or OTP sent to your mobile phone via SMS, or credentials from an app such as Google Authenticator, Twilio Authy, or FreeOTP. So we've been using this, so why don't we talk about the System Security Services Daemon, or SSSD. So this SSSD is used to provide access to remote identity and authentication providers. Native clients connect to SSSD and then communicate with SSSD providers. Oh, let me count the benefits of SSD. So the first would be reduced load. So the reduction in load happens because clients do not need to communicate directly with identification authentication servers. They'll do this by just simply communicating with the SSSD. Secondly, we could talk about the offline authentication facility. So SSSD can optionally keep a cache of user IDs and credentials, allowing users to authenticate offline. But third, you see, it's suitable for single user accounts. SSSD preserves network credentials, allowing users to connect to network resources by authenticating with their local username on their local machine. Well, it seems that you're ready to move on to Lightweight Directory Access Protocol, or LDAP. Yeah, so LDAP is a type of internet protocol that runs over TCP/IP. It's used to access information from directories. The LDAP protocol is basically used to access an active directory. LDAP has a pretty simple functional model, but it's not repetitive. It's not rarely used, and has no other features than, well, the most obvious. It also has some very easy to understand and implementable features. It uses strings, not complex databases, to represent the data contained. LDAP as a process defined for accessing and modifying directory entries, like searching for user-specified criteria, adding an entry, deleting an entry, changing an entry, changing the distinguished name of an entry, and comparing an entry. So a few of the advantages to count on with LDAP, well, data contained in LDAP can be used by many clients and libraries. It also supports many application types. LDAP is very general and has a basic level of security. But of course, it doesn't come without disadvantages. So we could actually say that it doesn't really work well with relational database structures. Which brings us to single sign-on, or SSO. So SSO allows a user to use a single set of login credentials consisting of just a username and password to access multiple applications. But for SSO to work, most applications rely on open standard protocols to define how service providers, or SPs, and identity providers, or IDPs, can exchange identity and authentication information with each other. Which leads us to the fourth mighty topic that we'll cover with the purpose and use of security best practices in a Linux environment. So it's Linux hardening. Now, Linux hardening just refers to a set of measures used to reduce attack points and increase the security of your servers. Hardening can be done at different levels, but at the physical level, it can be done by restricting access by unauthorized persons. And at the application level, by removing unwanted software that listens to incoming connections. Now, some of the applications that can be used to harden Linux servers and reduce their attack area are logging, auditing, and compliance troubleshooting. In fact, applications and support regulations will aim to aid early detection if your servers have been compromised. So we'll continue with the processes that you can do for Linux hardening. We'll get started with the use of the Secure Shell Protocol. So SSH, this is going to allow you to establish a secure connection with your network services over an unsecured network. So how and why, really, will we be using SSH? Well, to bring this all together, each server must be configured to use SSH for remote login. Vulnerabilities in other protocols are obviously more vulnerable to attacks. You can configure IP tables to restrict SSH access from known IPs only. You can prefer SSH version 2 for security enhancements. But please don't use SSH unless it's absolutely necessary. Also, prefer to use key-based authentication instead of password-based authentication. That means client keys must be encrypted. You can consider it to be a precaution to prevent them from being used in case they are stolen. But the root login must be disabled when configuring the server. Only authorized users should be allowed to log in. And in addition, users can use sudo to perform tasks that require elevated privileges. And now let's continue with close open ports. So in Linux, you can control which software is listening for incoming connections using a few great tools, for example, like netstat. If you encounter a service or application that you deem necessary as a result of listening, well, you'll either disable the port or uninstall the unnecessary application. Now, in particular, vulnerabilities in such applications can be exploited by attackers. In fact, one way to reduce attack points is to close unnecessary open ports. You can also block unused ports, preventing any new services from connecting to them in the future. So now in this next step, we're going to talk about enabling the firewall. We've already mentioned the concept of IP tables. You can keep a tab on incoming, outgoing, and forwarding applications using the Linux IP table. And this can help you secure your servers. So by editing the allow and deny rules, you can control the traffic in accepting or sending traffic from certain IP addresses. So this way you can prevent uncontrolled traffic movement on your servers. Moving right along to disabling USB and Thunderbolt devices. So one of the other ways attackers can infiltrate your operating system is through booting from external devices. Allowing booting from unauthorized external devices actually leaves an open door for attackers. So you can actually block this type of attack by turning off access permissions in the BIOS. Another feature that you can use for security would be to turn on SE Linux. So this is Security Enhanced Linux, or SE Linux for short. Well, it's a built-in access control mechanism. For systems connected to the internet and accessed by general users, SE Linux is an indispensable security tool. I'll show you quickly that, you see here, SE Linux can run in 3 different modes. Now, the first mode is disabled. So in this mode, SE Linux is completely turned off. You should always stay away from this mode, obviously, or not. Up to you. Second mode is allowed. So in this mode, SE Linux does not enforce any policies, but logs and audits all actions. So it's from this mode, which you will use during the configuration of the machine, you must switch to the application mode as soon as the configuration is finished. So obviously our third mode is application. So this mode is the safest and applies all the policies. This is SE Linux's default mode, and it's also the recommended mode. So now we come to a step that we need to pay particular attention to in all the services that we use. In this step, we're going to talk about strong password policies. Now, one of the most common mistakes is to use passwords that are either easy to crack or just continue using passwords that are subject to data breaches. This error can weaken the security of even the most complex systems. So I go through a couple of things to avoid problems. You got to disable accounts that don't necessarily have passwords and ask users to set passwords for their accounts. They do exist. And of course, it would be better if you disable the root account. The use of sudo should be encouraged as it provides better supervision and control. You also have to help users create stronger passwords and harder to guess passwords by asking them to follow some specific guidelines. The next step is to clean up unused, unnecessary packages. As you may know, some applications run in the background in the operating system. Some of these services, which may have been installed while the system was loading, others, well, they may have been installed without your awareness or request, alongside applications that were installed afterwards. So, to increase the security of your servers, list all the packages and software installed on your servers using your package managers, apt, yum, dpkg. See, vulnerabilities in these software, well, they continue to run in the background, and that can lead to compromised servers. So I recommend uninstalling unnecessary programs. All right, my friends, now it's time to talk about keeping the kernel and packages up to date. So obviously, Linux is used by a large and active open source community. This broad environment will quickly develop solutions to problems in kernels and packages. So stay informed. As you may know, these fixes are available in the Linux kernel in the form of updated packages or patches. So it's very important to keep your kernel and packages up to date with the latest security updates, and that'll help prevent exploitation of known vulnerabilities. Which brings us to our second title, Security, Identity Management. So the first topic that we're going to cover in identity management is account creation and deletion. So user account management. Well, it's got a pretty important place in Linux operating systems, as in perhaps other operating systems, but mainly in Linux. See, one of the main tasks of a Linux system admin is to know how to create a new user account, how to change it, how to delete it from the command line. All right, so there are some utilities that are used for Linux account management. Let's have a look at a few. So the first command that we're going to review will be user add. So this command used in Linux for adding user accounts to your system. The syntax for the command is user add with options name underscore of underscore the underscore user. All right, so let's just see what we can do with a command. So if you want to add a simple user, you can just use sudo user add username command set. If you want to give a home directory path for the new user, you can use the command set sudo user add -d /home/username, and this will set us a home directory /home/user_name. Now, if you want to create a user with a specific user ID, just use the sudo user add -u1357 user_name as your command set, and it's going to create a user with user ID 1357 user_name. Let's say you want to create a user with a specific group ID. Well, you can use the sudo user add -g5000 username command set. So this is going to create a user with group ID of 5000 and a username, whatever you put in. Should you want to create a user without a home directory, you can use a command set sudo user add -big M username. Let's say you want to create a user with an expiration date. You can use a sudo user add -e 2022-12-31 username. So, of course, this will create the username with an expiration date of December 31st, 2022. All right, that's all well and good. But let's say that you want to set an unencrypted password for the user. Well, go ahead and use the sudo user add -p user password username command set. So that will create a new user named whatever you name it with an unencrypted password. So we've got another command here that we'll get into. Let's look at group add. So groups in Linux refer to user groups. In Linux, a single system can have many users. Regular users can have UIDs from 1,000 to 60,000 and can be a root user ID, UID 0, and 999 system users, UID 1 through 999. So the syntax for that command goes like this. Group add with an option group name. For example, sudo group add Linux _trainer. Okay. Now, in addition, newly created groups are saved in the /etc/group file. You can use a sudo q/etc/group command set to verify that the group's been created. So in the file, you can see the group information with the tags group _name, password, group ID, and member list. So then what are the options for the group add command? Well, options look like this. -f, -force, and that just means force the command to abort silently if the given group already exists. So if this is used with the -g or -gid option, and the given group ID already exists, the command forcibly ignores the given group ID and then creates a new and unique group ID. The -g and -gid, well, GID is used to provide the new group with a group ID numeric and must be negative and non-unique unless explicitly created just by using the -o option to be non-unique. So if this option is not used, the default ID that is greater than any other currently available group is assigned. -o, non-unique, means allow adding a group with a non-unique GID. Now, another point of this command would be to add a new user to the group. Just mention the group using the -g option in the user add command. So an example of that command would be sudo user add -g Linux _trainers new _user. You can use the usermod command to add an existing user to a group. For example, usermod -g Linux _trainers current _user is an example of that. And the third command, let's have a look at userdel. So in Linux systems, userdel is the command to be used to delete a user account and all related files. This command basically modifies the system account files and deletes all entries referring to that login username. It's a low-level utility for removing users. Syntax of the command looks like this. Userdel with options, login, all caps. So let's have a look at the command's various options. Userdel -f. Well, this enforces the removal of the specified user account, so it doesn't matter if the user is still logged in or not. It also forces the user to remove the user's home directory and mail spooler, even if another user is using the same home directory or the mail spool is not owned by the specified person. For example, the command set sudo userdel -f redundant _user can be used for this and similar operations. Userdel -r. This means every time we delete a user, the files in the user's home directory will be removed, along with the home directory itself and the user's mail spooler. All files located on other file systems will need to be manually searched and deleted. So, for example, the sudo userdel -r new user command set can be used for this and similar operations. Which brings us to this fourth command, groupdel. So obviously this command is used to delete an existing group. It deletes all entries referring to the group as well as modifies the system account files, and it's handled by the super user or root user. The syntax for this command goes like this, groupdel with options group. And the files related to this command are /etc/group and /etc/gshadow. The group's account information is located in etc group, and the secure information of the group is in the etc gshadow file. So running this command produces 5 different output values, which are 0, and that means successful. 2 means invalid command syntax. 6 means the specified group does not exist. 8 means unable to remove user's primary group. 10 means unable to update the grub file. So if a user has a primary group, you can use the -F option to delete the group. And then the 5th command that we'll examine will be usermod. So in Linux, the usermod or modify user commands are used to modify a user's properties via the command line. Now, you may not have configured all of its properties when creating a user, right? Sometimes password or login, directory, etc. We're going to need to change the properties. That's when the usermod command gets used. So user's information is in the files etc/password, etc/group, etc/shadow, etc/login.defs, etc gshadow, and etc/login.defs. Okay, so we're going to talk about all these files a little bit later after the utilities are complete. But I do need to remind you that the usermod command should only be run as a root user. See, when this command is run in terminal, the command makes changes to these files itself. So we'll continue working with a usermod command with a few examples. So let's say you want to add comments to a user. You can use the Linux trainer command set, sudo usermod-c this Linux trainer. So this form of implementation will add a comment about the user or a short description about the user. If you want to change a user's home directory, you can use the command set sudo usermod-d/home/trainer Linux trainer. So this is going to change the user's home directory to /home/trainer. So let's say you want to lock a user account. You can use the sudo usermod-L Linux trainer command set. So this will lock that Linux trainer account. Also, an exclamation mark will show in the shadow file before the username. Now, if you want to unlock a user, you can use the command set sudo usermod-U Linux trainer, and this will unlock the Linux trainer that was locked by the previous command. Which brings us to the 6th command that I want to tell you about. It's group mod. So in Linux, the group mod command is used to modify or change the existing group. It can be handled by super user or root user. But basically, it modifies a group definition on the system by modifying the right entry in the database of the group. So the syntax of this command goes like this: group mod with an option group. Now, running this command produces 5 different output values, and those would be 0, which would mean successful. 2 means invalid command syntax. 3 would mean invalid argument option. 4 would mean the specified group does not exist. 6 means the specified group does not exist. 9 means the group name already is in use. And 10 means unable to update the grub file. So the 7th command that we want to talk about here is ID. The ID command is used in Linux to find usernames, group names, numeric IDs, UID or group ID of the current user or any user on the server. Information available with this command is username and real user ID, specific user UID, list UID and all groups associated with a user, list of all groups a user belongs to, security context image of the current user. So the syntax for this command goes like this: ID with an option, triple dot, username. If you want to print your own ID without any options, just type ID on the command line and run it. So on the screen, you can see the ID of the current user, UID and GID. If you want to find a specific user ID, for example, Linux Trainer, just run the ID-U Linux Trainer command set. Let's say you want to find the GID of a particular user, Linux Trainer, let's say. Well, you can run the ID-G Linux Trainer command set. If you were wanting to find the UID and all groups associated with a particular username, like Linux Trainer, why not? You can run the identity Linux_trainer command set. But wait, there's more. If you want to display a name instead of numbers, you see by default the ID command displays UID and GID in numbers, and that might not necessarily be understood by the user using -U, -G, and -G with the N option. So ID-NG Linux Trainer or ID-NU Linux Trainer. And you can run any one of the command sets. Right? So let's have a look at this other command, who. The who command. Well, this is used in Linux operating systems to obtain information such as the last system boot time, the current run level of the system, and the list of logged in users. The syntax for the command goes like this: who, options, and file name. Now, if no option is provided to the who command, it's going to list user's login name, terminal line numbers, user's login time, and user's remote host name for each user logged into the system. If you want to display the host name and user associated with standard inputs such as keyboards, you can use the who-m-H command set. So you can see that name, line, time, and comment information is listed on the screen. Now let's say you want to show all active processes created by the init process. You can use the who-p-H command set. And here you see that name, line, time, PID, and comment information gets listed on the screen. If you want to show when the system was last booted, you can use the who-b-H command set. Let's say you want to count the number of logged in users. Just use the who-q-H command set. And if you want to view the current run level of the system, you can use the who-r command set. Now, let's say you want to display the username of the system. You can use the whoami command set. And it brings us to our 8th command. Let's have a look at W. Now in Linux, this command gets used to show who is logged in and what they're doing right now. This command shows information about users and their processes that they're doing currently on the machine. The header in that order shows the current time, how long the system's been running, and how many users are currently logged in, as well as the average system load time for the last 1, 5, and 15 minutes. Also, the command line tools for each user are login name, TTY name, remote host, login time, idle time, JCPU, pCPU, and their current processes. So the syntax for the command, W with options, user, and many of the options used with the command are used to filter the displayed information. Now say you don't want to print the header. You can just use a W-H command set. If you want to get an output by ignoring the username while calculating the current process and processor times, you can use the W-U command set. And let's say you don't want to list the login time, JCPU or pCPU times. you can use the command set W-S. Now, if you only want to list information about a specific user, just go ahead and use the W-user_name command set. All right, so now we get to dig into the default shell. Now, on most Linux systems, the default shell is bash, but we can replace it with any shell like ZSH, fish, sh, and others. Of course, there's many ways to change a shell of any user on a Linux system, but first you would need to find your current shell name. We mentioned earlier that /etc/password file stores the basic information of user accounts required at login. You can find the current user login shell using this file. So to see the current user information in /etc/file, well, we got to run the grep who am I /etc/password command set. And then to change the shell, we'll first need to see which shells are installed on the system. We can do that using this command set, cat /etc/shells. Normal users can change a shell to any other shell listed in /etc/shells/. If it is the root account, any user can change the login shell. Also, a restricted login shell of an other account can be modified by the root account. For example, you can change the default shell to another shell using the usermod command. And the command set would go like this: sudo usermod -- shell /bin/bash username. All right, so our next title will be configuration files. So let's have a look at the files used by Linux to manage user accounts in order. So we'll first have a look at the /etc/passwd file first. So this file, which stores basic information about users in the system, is the most important file within the Linux operating system. This file is owned by the root user, and we need root privileges to edit this file. However, I recommend that you avoid editing this file. But don't you want to have a look, see what it actually looks like? Okay, so this file contains one entry per line. So it means that a user stores her information in one line. User information consists of 7 fields, and the fields are separated from each other by the colon. So why don't we take a quick look at these 7 areas? The first field represents username. The length of this field can be from 1 to 32 characters. Second field is password. So in this field, which stores the user's password, the characters will be displayed as X characters. The third field is the user ID or UID field. It consists of numbers assigned to each user by the operating system to direct users. UID 0 is reserved for the root user. 1 through 99 UIDs get reserved for other predefined accounts. 100 through 999 is reserved by the system for management and system accounts or groups. The fourth field is group identity or GID. The group identifier is the number representing the primary user group. Most of the time, it's the same as the UID. The fifth field is the user identity information, GECOS. So this is a comment area. This field contains information such as user's phone number, address, or even the full name. Now the sixth field is the home directory field. It contains the absolute path to the user's home directory, and by default, users are created under the /home directory. So if this file is empty, that user's home directory will be /. The seventh field is the login shell. So it stores the absolute path of the user's shell. This shell is started when the user logs into the system. In fact, why don't we have a look at the contents of the /etc/password file after we talk about it. So we can do this just by running the cat/etc/password command set. Cool. So let's have a look at the /etc/group file. It defines the default system group entries for system groups that support some system-wide tasks, such as, printing, network administration, electronic mail, that sort of thing. Most of these groups have corresponding entries in the /etc/password file. Due to the schema used by Linux systems, a new entry is automatically created in etc group when a new user is added. So the group name is going to be the same as the username. Now, let's talk about this etc shadow. So this file contains a real password in encrypted form, the username, the last password change date, the password validity rules, and other information about passwords. It is a text file and can only be read by the root user and therefore poses, less security risk anyway. So this /etc/shadow file contains each user detail as a single line with 9 fields, and each of these fields are separated by a colon. Now, talking about the /etc/password file format, we said that it consists of 7 parts, and the second field is the password field, right? So passwords in this file were represented by the symbol X. Well, you can see this image shows that shading is active. And it leads us to another file, the /etc/profile. The etc profile is a file that's used to set system-wide environmental variables in user shells. Now, the variables are sometimes the same as those in the .bash_profile, but this file is used to set an initial path, or PS1, for all shell users of the system. Next file we'll talk about is /etc/skell. And obviously, it is an abbreviation of skeleton. So it's used to initialize the home directory when a user is first created. Another file is the .bash profile. So the /etc/profile is a system-wide file that the system admin maintains and defines the tasks that the shell executes for each logged-on user. The .bash profile is a configuration file for configuring user environments. So users can change default settings and add any extra configuration to it. So our next topic that we're going to talk about in identity management is account management. So I want to first start with the password command. Now in Linux, this command is used to change user account passwords. So a root user reserves the privilege to change the password of any user in the system, while a normal user can only change the account password for their own account. Make sense? So the syntax of the password command goes like this: PASSWD with options and the username. However, I would like to remind you of this again. Sudo can be used by normal users to invoke root privileges and change the root's password. And you can actually do this by executing the sudo PASSWD root command set. Now, during this operation of changing the password, you're going to first verify the current user password. So when the user enters the password command, it asks for the current user password, which is then authenticated with the password stored in the /etc/shadow file. However, root user can skip this step and change the password directly so that any forgotten password can be recovered or subsequently changed. Now, second off, you will need to verify the password aging information. Remember, in Linux, a user password can be set to expire after a certain period of time, or a time period that can be defined for the password not to be changed. So the third and final step, go ahead and change the password. So after authentication, the user is prompted to enter the new password, and verify it by retyping that password. Moving right along, we'll continue with the change command. So this change command, this is used when a user will be logged in for a limited amount of time or when the login password needs to be changed from time to time. So it's with the help of this command, we can set the aging information of an account, the date the password was changed before, the password change time, and we can actually lock an account after a certain period of time as well. The syntax of the command goes like this: chage with some options and the login. The L option is used to display account aging information. So if you want to view the aging information for root, you can use the sudo change-l root command set. The D option is used to set the last password change date to a desired date. So if you want to change the root's aging information, you can just use sudo change-d 2016-09-01 root. The capital E option gets used when you want to specify the date the account should expire. So if you want to specify the date the root account should expire, you can use the command set sudo change-E root. All right, we're going to continue on here with pamtally2. This is our third command here. And in order to ensure session security in operating systems, the login should be locked as a result of repeated incorrect logins, right? So in a Linux-like operating system, the pamtally command gets used to lock and unlock failed SSH logins. So we provide the security with the PAM module called pamtally2. The module can display user login attempts, set numbers individually, as well as unlock all user accounts. Okay, so now I want to show you the fail lock. This is our fourth command here. So it's a tool for viewing and modifying authentication failure log files. The PAM faillock.so module. Well, this keeps a list of failed authentication attempts per user at a specified interval, then locks the account. The faillock command is an application that can be used to examine and modify the contents of the tally files. It can display the recent failed authentication attempts of the username, or clear the tally files of all or some of the individual usernames. So when you want to use it, it goes like this: faillock $dir/path/2/tally-directory close square bracket, open square bracket, username, close square bracket, open square bracket, /reset, close square bracket. So we'll talk about a few of the options of faillock. Of course, one of the options would be $dir/path/2/tally-directory. Right, so this is a directory where the user files with the failure records are kept. And the default is /var/run/faillock. The second of our options is the user username. So this is a user whose failure records will be displayed or cleared. Third option would be to use the reset. So you need to use this option when you prefer to clear the records instead of displaying the user's failure records. All right, so that means we can move right along with our etc/login.defs file. So this is the file that provides default configuration information for several user account parameters. The user add, user mod, user del, and group add commands, as well as other user and group utilities, all get default values from this file. Each line in the file consists of a directive name and its corresponding value. So we'll move on to our second title in this group, security. The third subtitle is implement and configure firewalls. So the first thing that I want to cover here in implement and configuring firewalls is firewall use cases. So I want to start, though, really basically with the issue of opening and closing ports. So indeed, one of the most important steps in ensuring security is checking the ports. You can open a port when you need it or close a port to address security concerns. In Linux, port opening process is pretty simple. For TCP, you can use the IP tables -A input -P TCP --D port no and O for number -J accept as your command set. What about for UDP? Well, your IP tables -A input -P UDP --D port number -J accept. Now, there's a couple of different situations for when you want to execute port closing. Let's examine our first case. It's to close requests from the outside. So you can do this using the IP tables -A input -P TCP --D port number -J reject command set for TCP. And for UDP, guess what? IP tables -A input -P UDP --D port number -J reject. I mentioned earlier there's another case for port closing, and that would be to close outgoing requests. So you can do that using the IP tables -A output -P TCP --D port number -J reject instruction set for obviously TCP. And then for UDP, IP tables -A output -P UDP --D port number -J reject. Oh, and by the way, I want to briefly compare TCP and UDP. So TCP is more secure but slower in data transfer than UDP. So in data transfer, it actually checks whether the packets are forwarded to another party or not. But on the other hand, UDP is preferred for larger media transfers. All right, so what about viewing the open ports? Well, you got to remember first that a port is a 16-bit number between 0 and 65,535. So to classify port numbers between 0 and 65,535, we've got a few different categories. There's 0 to 1023. These are well-known ports. 1024 to 49,151 are registered ports. And then 49,152 through 65,535 are known as dynamic and private ports. So, a registered port. This is a network port assigned by the Internet Assigned Numbers Authority, IANA, and it's stored in the etc services file. To have a look, you can use the cat command or the grep command or egrep command, and you'll be able to view port numbers and service mappings. So the command sets go like this: cat/etc/services or grep-w /80/TCP/etc/services or grep-w /443/TCP /etc/services or even egrep-w /22/ TCP pipe UDP /etc/services. All right, so moving right along, we have got to check open ports in Linux. It's pretty easy with the Linux terminal application. You have some alternative methods for monitoring and displaying open ports in Linux. The first of these is by using the ss command, using the netstat command. You can also use the lsoft command or the nmap command. So let's check them out with a few examples. So first of all, if you want to use netstat to list open ports, you can just use sudo netstat-tulpn pipe grep listen for a command set. Now let's talk about a few of these options. T means all TCP ports. -U would mean all UDP ports. Okay. L means display listening server sockets. P shows the PID and the name of the program to which each socket belongs. And then the -N means don't resolve names, which leaves us with pipe grep listen, which is only going to display the open ports because you're applying the grep command filter. Now, we have used the concept of open port many times, so it's pretty useful to, explain that a little further. So the fact that a port is open, well, does not mean that every outsider can access this port. Up until now, we've been talking about how to find and list OpenTCP and UDP ports in Linux. However, these ports can still be blocked by software, cloud or hardware firewalls as well. So that's why you should verify that your corporate firewall is not blocking inbound or outbound access. But on the Linux server, you can actually list and search for firewall rules using these command sets. And it kind of goes like this. For IPv4, sudo iptables-s, and for IPv6, sudo ip6tables-s. Make sure that's a capital S. So we're going to move along here. I want to cover a topic called enable and disable IP forwarding, right? There may always be a need to configure Linux IP forwarding within your Linux system. If the Linux server is acting as a firewall, router, and NAT device, it should be able to forward packets to other destinations other than itself. So this IP forwarding should usually be turned off unless you're using one of the configurations that we've been talking about. So for right now, I want to review step-by-step instructions for enabling or disabling IP forwarding via command line examples. And you'll check out how to edit the net.ipv4.ip_forward parameter to a Linux distribution. So this is going to control whether IP forwarding for IPv4 is on or off. So we're going to evaluate our subject under 3 separate headings, actually. We're going to check the current IP forwarding status, enable or disable IP forwarding, as well as check out some of the common troubleshooting procedures for IP forwarding. All right, so let's get started with our first subheading, checking the current IP forwarding status. Now, most Linux systems can use the syscontrol command. Therefore, you can use the syscontrol command to check, see whether IP forwarding is enabled or disabled. And you can do this just by executing the sysctl net.ipv4.ip_forward command set. Now here, you can see a couple of different types of results on the screen. So this net IPv4 IP forward equals 0 means IP forwarding is off. When net.ipv4.ip_forward equals 1, this means obviously that IP forwarding is on. So to see these settings, you can just look inside the proc sys net IPv4/IP_forward on systems with systemd or any other init system. But I find it's a lot easier just by using the command set cat/proc/sys/net/IPv4/IP_forward. So let's continue on. Let's check out enabling or disabling IP forwarding. So if you want to enable or disable Linux IP forwarding, you can just use sysctl-w net.ipv4.ip_forward equals 0. See how that works? Or of course, if you want to turn it on, sysctl-w net.ipv4.ip_forward equals 1. If you've successfully enabled IP forwarding, but you're still not receiving traffic on target systems, you should check the IP tables forward rules. And you can do this just by using the command set iptables-L-V-N. So your forward chain should either be set to accept or list rules that allow specific links. And you can see if traffic is reaching the next IP tables chain just by checking the amount of packets and bytes hitting the chain. If not, you may have higher rules in your chain blocking traffic. All right, so another topic that I want to talk about here in Implement and Configure Firewalls is some common firewall technologies. We'll start with Firewall D. The dynamic firewall manager on Linux system is called Firewall D. So with this service, you get to configure network traffic, and you can decide which external network or internal packets are allowed to pass through to the network or out of the network, and which get blocked. You're going to be able to configure two different types. So we've got permanent and runtime. Your runtime configurations are actually lost when the service is restarted. For persistent ones, the ones that are retained throughout system boot, they're tracked every time the service is activated. Permanent. There you go. Firewall D has a couple of directories corresponding to these configurations, as you might have guessed. These are /usr/lib/firewall and /etc/firewall. Moving right along, continuing with IP tables. So IP tables is the service that decides to allow, drop, or return IP packets. IP tables are used for IPv4, while IP6 tables are used for IPv6. Okay, so the service manages a list of tables where each table is kept for different purposes. For example, the filter table. This is used to keep track of firewall rules. NAT table for new connection states, and the mangle table for packet changes. It's the IP table that keeps a list of tables like this and manages the use of these tables as well. So I want to show you how to start, stop, and enable and disable the Firewall D service. So if you want to start up the Firewall D service, you should use the systemctl start firewall D command set. Not too difficult. And of course, if you want to stop the Firewall D service, just go ahead and use the systemctl stop firewall D command. And if you want to check the status of Firewall D, just use systemctl status firewall D. And let's say you want to check the state of Firewall D, use the command firewall-cmd --state. Oh, and by the way, you can disable the Firewall D service so that it doesn't apply rules, or enable once you need them. So if you want to disable the Firewall D service, just use the command systemctl disable firewall D. Or to enable the Firewall D service, use the command systemctl enable firewall D. Now, if you want to mask the Firewall D service, use the systemctl mask firewall D command. Also, you can mask and unmask the firewall service, which creates a symbolic link of the firewall service to dev null. For unmasking the Firewall D service, you can use systemctl unmask firewall D. So this operation is going to remove the symlink of the service created during masking, therefore re-enabling the service. All right, so now that you know all of that, it's time to talk about the UFW command. Now, for some other Linux distros, and especially on Ubuntu, UFW is a command which gets used to manage the IP table's firewall service. UFW is going to provide an easy interface for the user to handle IP table's firewall services. So if you do want to enable UFW IP table's firewall, just use sudo UFW enable. To disable UFW IP table's firewall, you can use sudo UFW disable. And if you just want to check the status of UFW IP table's firewall, you can go ahead and use sudo UFW status for your command set. Now, just like we said before, if you want to list the chains containing all the rules in IP tables, just use a command set IP tables -L-N-V. All right, moving right along with NF tables. Now, according to the Arch Linux wiki, it's a NetFilter project. And this aims to replace the existing IP, IP6, ARP, EB tables framework. So it's going to provide a new packet filtering framework, a new user space utility. This is NFT. And a compatibility layer for IP and IPv6. So it's going to use existing hooks, connection tracking system, as well as user space queuing components and logging subsystems of NetFilter. But guess what? It has a simple firewall configuration. Just to meet basic user needs, configuration information is stored in the file etc/nftables.conf. Now, nftables.service is going to load rules from this file when started or enabled. There are no actual built-in tables in nftables to replace the tables used in IP tables. The number of tables and their names are actually user-dependent. However, each table has only one address family and is valid only for packages of that family. But there only happen to be 5 families, and I'll show them to you. IP, IP6, INET, ARP, and Bridge. Now, the default family is IP, that is IPv4, and will be used unless otherwise specified. Use INET to create a rule that applies to both IPv4 and IPv6. INET will allow combining the IP and IP6 families to make it easier to define rules for both. All right, it brings us to key firewall features. So firewalls, these are configurations that provide protection for business systems and information. They'll work according to pre-written security rules. Applications that monitor and manage traffic entering and leaving your network is going to be based on those rules. And we can define firewalls. We'll split them up in a couple of different parts, right? But these will depend on whether there is stateful information or not. You got to remember, stateful firewalls have the ability to monitor and detect the states of all traffic in a network. And it'll monitor and it'll defend based on these traffic patterns and flows. Stateless firewalls, on the other hand, focus only on individual packets using preset rules to filter traffic. Now, I'm sure you know by now, firewalls can be different from each other because they will be determined according to the particular needs of a particular network. The differences also create diversity in firewall types. Of course, network security measures are designed to keep out untrusted, corrupt files while protecting the company's network assets. But of course, we do have, on the other hand, network firewalls running on network hardware or host-based firewalls that rely on hosts to control traffic. These are also types of firewalls. So we're going to break it down even further. What's a stateful firewall? Firewalls that can monitor all aspects of traffic flows, properties, communication channels. These are stateful firewalls. So these firewalls can integrate encryption or tunnels and identify TCP connection stages, packet status, as well as other important status updates. How does that compare to a stateless firewall? Well, stateless firewall configurations will use hints from the destination address, source, and other key values to assess whether or not threats are present. Then block or restrict what is considered untrusted. So stateless firewalls do not look beyond the packet content header in order to determine whether traffic is authorized or not. Make sense? Yes. So let's have a look at the pros and cons of stateful versus stateless firewalls. I want to make a list of the pros of stateful firewalls. Definitely capable of detecting unauthorized attempts or fake messages. It preserves the essential features of network connections with powerful memory. With a small number of open ports, they can create smooth traffic. Stateful firewalls base future filtering decisions on the aggregate of the past and current findings. Building an intelligent system is easier with stateful firewalls. Now, of course, there are some cons of stateful firewalls. Those would include a firewall that has not been updated with the latest software version will not be too difficult to compromise and gain control over. So vulnerabilities do need to be audited and fixed frequently to be able to resist attacks. Stateful firewalls that can withstand very sophisticated attacks can be tricked into allowing or even pulling external connections with a simple operation. Man-in-the-middle attacks can create greater vulnerabilities. What about the pros of stateless firewalls? Now, obviously, the first one will be faster performance. Heavy traffic's not going to be a problem with stateless firewalls because it performs really well under pressure without getting hung up on too many details. Stateless firewalls will cost less than stateful ones. But of course, there are some cons as well. So the cons for stateless firewalls would include they don't do traffic control. They do not examine the entire package, but instead check and decide whether the package meets the current security rules. Their configuration is essential to achieve an appropriate level of protection. All right, so that brings us to our title, Security, and configure and execute remote connectivity for system management. So the first topic that we're going to cover here in Configure and Execute Remote Connectivity for System Management is SSH. Now, we mentioned in many places before SSH, it's known as Secure Shell Protocol. It's going to manage remote systems using an encrypted connection between users and the remote machine. Now, on Linux systems, SSH is the most common method for remotely connecting to your servers or machines and making remote connections more secure, because you can use dual key encryption. So I want to start with configuration files. The first file is etc sshd_config. So this etc sshd config file is the system-wide file configuration for OpenSSH. So this is used to set the OpenSSH daemon's running options. So when you open this file with a text editor, you're going to see that keywords are case insensitive, containing keyword value pairs, one per line. So this is going to tell the sshd config file to set itself up for this particular configuration setup, like this. Port 22 means the port number that SSH daemon listens for incoming connections. That's the default port, 22. The listen address means the IP address of the interface network on which the SSH daemon server socket is binded to. Host key /etc/ssh/ssh_host_key means the location containing the private host key. Server key bits means how many bits to use in the server key. Login grace time. This means how long in seconds after a connection request that the server is going to wait before disconnecting if the server is not successfully logged in. Key regeneration interval. This is just talking about how long in seconds the server should wait before automatically regenerating its key. Permit root login. Well, guess what? This means whether the root can log in using SSH or not. I want you to remember this. Never say yes to this option. Ignore rhosts. So this will mean whether rhost or shost files should not be used in authentication. Now, for security reasons, it's recommended to not use rhost or shost files for authentication. Remember that too. Ignore user known hosts. So this is going to mean whether the SSH daemon should ignore the user's home known hosts file during rhost's RSA authentication. Okay, strict modes means whether SSH should check users' permissions in their home directory and rhost files before accepting a login. Now, this option must always be set to yes because sometimes users may accidentally leave their directory files writable. XL forwarding just means whether XL forwarding should be enabled or not on this server. print MOTD. This is going to mean whether the SSH daemon should print the contents of the etc MOTD file when a user logs in interactively. The etc MOTD file, it's also known as the message of the day. Syslog facility just means the facility code used when logging messages from SSHD. Log level means a level that's used when logging messages from SSHD. Info is a very good choice. rhost authentication. This just means whether SSHD can try to use rhost-based authentication or not. rhost RSSA authentication means to try rhost authentication in concert with RSA host authentication. RSA authentication just means to try RSA authentication or not. Anyway, password authentication means just that, whether we should use password-based authentication or not. But for strong security, of course, this option must always be set to yes. Please, yes, please. Those are the magic words. Anyway, permit empty passwords. Well, this means whether the server is going to allow logging into accounts with a null password. Allow users. Of course, this means which users can access SSH services. Multiple users can be specified, separated by spaces. So we'll have a look at the second file, which is here, /etc/ssh/ssh_config. All right, so this SSH config file, this is also known as a system-wide configuration file for OpenSSH. It's allowing you to set options that change the operation of client programs. Like the SSHD config file, it does contain keyword value pairs, one per line, where the keywords are case insensitive. And the third file is tilde/.ssh/known_hosts. So the host key is an encrypted key used to authenticate the machine. When the client first establishes a connection to the host, it stores the host keys for later access. This key is then stored in each user's home directory. Hopefully you know where that is. etc ssh known_hosts, right? Or .ssh/known_hosts. All right, so in other words, the purpose of the known host file is to hold the host keys of the servers so that the client authenticates the server to which it connects, and also the SSH client, because that's going to use this file as well, okay? Now, the use of this file is actually optional, and if there is such file in the system, it just means that this file has been prepared by the system administrator. Could be you. It automatically keeps the file in the system separately for each user. So every time a user connects to an unknown host, and the unknown host key is added to this file. There you go. Now, in case of an attack or security breach, hackers know that they can use the known host file. So, of course, that means displaying a list of all the machines connected to this machine and making these machines targets. Let's have a look at the fourth file, which would be tilde/.ssh/authorized_keys. All right, so having a look at the SSH authorized keys file. So you're going to see that this file contains a list of public keys authorized to log on to a server. And the purpose of this file is to help protect your server from unauthorized users. It allows the user to log in only based on SSH key verification without asking for a username and password. So the SSH daemon on the SSH server side verifies the SSH key by reading this file. Now, this user-specific file should be placed in a directory accessible only to the user, for example, the tilde/.ssh directory. Also, SSH authorized keys file permissions need to be set to 600. This permissions value means that only the user who owns the file can read and write to this file. The SSH authorized keys file is located in the .ssh directory, and this directory is located in the user's home directory. Moving on to the fifth file, we've got tilde/.ssh/tilde/.ssh/config. All right, so this is the configuration file. It stores data from IP addresses, usernames, non-standard ports, and various command line options. So this data is the information that's needed in cases where it's necessary to connect to more than one remote system regularly via SSH. Creating a bash alias for each server could actually be a solution to this problem. However, you can choose OpenSSH as a simpler and more effective solution. OpenSSH just allows you to set up a per-user config file where you can store different SSH options for each remote machine you connect to. This configuration file is, well, it's called config, and it's stored in the .ssh directory. Of course, the SSH directory will not be created by default. You will need to run the SSH command just once to create this directory. All right, so let's continue by issuing some commands. Let's run down the first command, which is /ssh-keygen. So this SSH keygen is a utility for authentication keys in SSH. Naturally, it's used to generate, manage, and convert authentication keys. New authentication keys for SSH are generated in pairs, and these such key pairs are used to authenticate login, single sign-on, and hosts. SSH keygen comes pre-installed with SSH on most operating systems. SSH keygen is able to generate a key using one of 4 different digital signature algorithms. Let's have a look briefly. RSA, DSA, ECDSA, ED25519. Now, the syntax for the SSH keygen command goes like this: SSH-keygen with a few options thrown in. Let's have a look at the options. -B bit. Now, this is going to mean you're specifying the number of bits in the key to be generated. -C comment means it's going to provide a private key comment. -P means, well, it just prompts to change the password of the private key file instead of generating a new private key. And when you use -T as an option, it's going to indicate the type of key to generate. -O is going to be using the new OpenSSH format. Brings us to our second command, which is /ssh-add. Perhaps you might know that the task of the SSH add command is to add RSA or DSA identities to the authentication agent. The syntax of the command goes like this: SSH-add with options -T, lifetime, and file. So when you run it without arguments, it appends the files //.ssh/id_RSA, //.ssh/id_DSA, and //.ssh/identity. Now, it can also be run by giving alternate file names on the command line. If any file requires a password, SSH-add prompts the user for the password. The password is read from the user's TTY. SSH-add will retry the password if multiple identity files were given. So let's have a look at some of these commands options. The -C just indicates that added IDs must be subject to validation before they can be used for authentication. The -D, well, this is going to delete all IDs from the agent. When you use -D, it means that it's going to remove the IDs from the broker instead of adding IDs. When you use -E reader, that's going to remove the key in the smart card reader. -L, this is going to list the public key parameters of all IDs currently represented by the agent. -L means to list fingerprints of all IDs currently represented by a delegate. When you use the -S reader, is going to add a key in the smart card reader. Now, -T life means life, and you should set a maximum lifetime when adding IDs to an agent. So the lifetime can actually be specified in seconds, or if you want to increase that to a specific time format. -X, this is your unlock tool. And when you use the regular -X, it means lock the agent with a password. And that brings us to the third command, which is ssh-copy-id. Now remember earlier we mentioned that key pairs are used to control communication between client and server. So then how will these generated public keys be delivered to the server? Well, yeah. Now we're going to need to copy the public key to the server. And we can do this just by using the ssh-copy-id command or manually copying it to the server. I'll show you an example if you want to copy your public key file located in $home/.ssh/id_rsa.pub to your user account on the remote server. The command set that you're going to use goes like this: ssh-copy-id-I, and then the $home/.ssh/id_rsa.pub user at your remote host. Very good, very good. So I want to continue here and talk about tunneling. The first method is X11 forwarding. So a user needs a procedure to be able to launch a graphical application installed on a remote Linux system and forward those application windows or the screen to the local system, right? So we call this method that performs the procedure X11 forwarding. Now, the remote system doesn't need to have an X server or graphical desktop environment to perform this procedure. Therefore, configuring X11 forwarding using SSH allows users to run graphical applications securely over an SSH session. And it brings us to another topic that we're going to cover in configure and execute remote connectivity for system management. We're going to be executing commands as another user. So we're going to start with this file, /etc/sudoers. So the sudoers file, this is located in this /etc directory. Its main purpose is to check how sudo works on your machine and then determine which users and groups can actually run with super user permission. And speaking of permissions, the sudoers file can also allow a specific user to run commands on the system as another user. Now, when you first install a Linux version, you're going to create an account, right? So this account is saved in the sudoers file. So in short, you can run admin tasks with a sudo command after installation. You probably know that, but when you do need to create a new account, that account will not have super user permissions, right? Now, you may want to grant super user privileges to a new user that you create, and you can do this by editing the sudoers file. Although the sudoers file looks like a text file, I'm going to actually recommend not opening it in just a regular text editor because it can lead to simultaneous editing and corrupted files, potentially denying any admin access. So it's just going to get you in a world of trouble. So just do it like this. Run visudo in terminal. That's how you edit sudoers. visudo. In fact, let me just show you the command set. It goes like this: sudo visudo. You do need to use sudo, though, to run visudo. You see that. Okay, good. So we are moving on to policy kit rules. Now, according to the wiki at debian.org, policy kit is an application-level toolkit for defining and handling policy that allows unprivileged processes to talk to privileged processes in order to grant some users the right to perform certain tasks in certain cases. So it can sometimes be referred to as sudo of systemd. Now, in many distributions, PolicyKit is replaced by polkit, so it's going to rewrite the system component, breaking backwards compatibility. Just keep that in mind. But I want to show you a few example uses. It's going to allow the user to hibernate and shut down the computer. It'll let the user manage wireless and other connections. It will also allow the user to insert or remove removable media like CDs, DVDs, USB keys, whatever. It allows access to devices like user's audio and the browser, that kind of thing. Now, unlike mechanisms used in the GUI, PolicyKit is a central place to define and enforce policy. Locally installed policies need to be installed in this directory /etc/polkit-1/local authority/. All right, so let's have a look at some of these commands for executing users. So this subheading is commands, right? The first command that I want to take you through is sudo. Now, this command gets thrown around a lot, and we frequently use it throughout our training. Sudo is basically short for super user do. But a lot of people just like to say sudo because it makes it easier. You could say sudo, but that also becomes a little awkward. But anyway, some commands require you being a super user. So just remember, it is super user, all right? It's going to require that, or at least having that privilege. Anyway, to solve that problem, we just add the prefix sudo to these commands. So with this prefix, we'll run the command with elevated privileges. Or in other words, we allow a user with the appropriate permissions to execute a command as another user, such as a super user. Now, you could liken this process to the run as administrator option, if you're familiar with Windows operating systems. In any event, thanks to sudo, there can be more than one administrator in our system. Now, please remember that sudo is not the actual user's root password itself. It's going to require the user to authenticate with a passphrase. And then the syntax of the command just is simply expressed as sudo options command. So let's take you through some of these options then, huh? -L is list, and this means that it's going to print the commands that are allowed, as well as prohibited, to the users on the current host. When you use -V for validate, this means that sudo updates the user's timestamp and asks for the user's password if needed. -K is kill, and it invalidates the user's timestamp. Therefore, a password will be required the next time sudo's run. -K is sure kill, and this is going to completely remove the user's timestamp. -B for background. This is going to tell sudo to run the given command in the background. -P for prompt is going to allow you to override the default password prompt and use a custom password. -N is going to execute the command without asking for a password. So it's very useful when we want to run some sudo commands as background jobs or in a shell script when we don't want sudo to prompt for a password. The -N option means non-interactive. Okay. -U for user. So this is going to allow sudo to run the specified command as a user other than root. So you should use the -UID to specify a user ID instead of a username. -S is shell. So it runs a shell specified by the shell environment variable, if set, or the shell is specified in the password file. All right, so we'll have a look now at our second command because I'm sure you have questions about vsudo. So vsudo, which we talked about in the previous section, is just the command to edit the configuration file for the sudo command located in /etc/sudo-ers. Now, you may remember editing the /etc/sudo-ers file requires super user privileges. Now, the vstudio command, unlike regular editors, locks the etc sudo-ers file, but it also replies with a message denying access requests from other users and allowing them to try later. And more importantly, vstudio will not allow saving the file with edits if it checks the syntax of edits and detects any errors. Cool. Third command that I want to talk about is su-. So this command is one of the essential utilities in Linux. Okay? Its purpose is to allow users to execute commands as another user. So undoubtedly, the most common use of su is to gain super user privileges. And that's what leads to the common confusion that, hey, this must be an acronym for super user, but it's actually an acronym for standby user. Ha, TIL, yeah. Anyway, when using su, we can run it with or without the dash argument. This argument is just telling su to call a login shell that resets all environment variables and recreates them. So if we omit this option, almost all the available environment variables will remain the same. This single character has a lot of effect on commands that we will be running after changing the user. So keep it in mind. All right, so what are some of the folder differences between su and su dash? Well, when you use su dash, the command changes your current working directory to the target user's home directory. And on the other hand, the su command doesn't change your directory. It will stay in the same directory after the user change. So if you want to check out the difference, just go to terminal and write this command set. All right, so you can see our working directory is this, right? /home/Linux_trainer. Linux_trainer at server:\su password: root at server: /pwd/root. So after using the su dash, well, our working directory is now /root. Root at server: #logout. All right, so we're logging out Linux_trainer at server: $$su password: root at server: /home/Linux_trainer /pwd/home/Linux_trainer. Right, so after using su, our working directory is /home/Linux_trainer. Which brings us to our fourth command we're going to have a look at, pkexec. So this command is another one that will execute a command as another user, like su sudo vsudo. Okay, so the syntax of the command goes like this: pkexec in square brackets _username, program in square brackets argument. So the pkexec command allows an authorized user to execute the program as another user. Okay. However, if no username gets specified, the program is executed as the administrator superuser root. Awesome. So that brings us to our next title, security. And here we're going to figure how to apply the appropriate access controls. So the first topic that we're going to cover, obviously, in applying the appropriate access controls is going to be file permissions. So I want to get started with access control list, which is oftentimes known as the ACL. So an access control list, the ACL, is simply a permission manager. It provides an attachment for file systems as well as a more flexible permission mechanism for users. It's designed to assist with Unix file permissions, right? So ACL is used to define permissions to a disk resource for users and or groups. All right, so let's just say that you are a system administrator and you create and manage a group for that purpose, and you're dealing with a new user. However, you really don't intend to add this user to your group, but you may want to give this user some read and write permissions. So how would you go about doing that? Well, this is where the ACL actually becomes your friend, because remember we said earlier that ACLs are used to create a flexible permission mechanism in Linux. So ACLs are used to define more granular optional access rights for files and directories. And naturally, there's a couple of different commands for this purpose. So our first command that we'll look at is set FACL. So this command is used to set up the ACL. Then the other command that you'll use is get FACL, and this is used to show the ACL. So, for example, let's run a command set like get FACL file _name. So you'll get the name of the file owner and the group information, and you see the permission information for the user group as well as others on the screen output. Now let's move along with our list of commands that you can use to set up ACL. So let's say you want to add permission for a user. You can use set facl-m in double quotes, u:user:permissions, double quotes, /path/to/file. Now let's say you want to add permissions for a group. Well, you can use set facl-m double quotes g:"group:"permissions double quotes /path/to/file. Now let's say you want to remove all entries. Just use the command set facl-b path/to/file. All right, so now we're going to move along to the next subheadings, which are SUID and SGID. So SUID stands for Set User Identification, and SGID stands for Set Group ID. Now, these two are very special permissions that can be set on executable files. These permissions allow the currently executing file to be executed with the privileges of the owner or group. So we'll start off with SUID. So this is going to allow users other than the file owner to run the file with the file owner's active permissions. But instead of the usual X representing executable permissions, you're going to see the S for special permission. All right, so that means SUID of the user, right? Special user ID. Okay. Let's move along to SGID, another special file, but it's a permission for executables that allows other users to inherit a group owner's active GID, or the group identifier. Right? So again, here you'll see S for the special permission representing SGID, or the group of users, again, instead of the X representing executable permissions. So you want to see how to find files with SUID and SGID using the find command? Sure enough. I'm going to show you anyway, whether you want to or not. So this command set goes like this: find directory -user root -perm -4000 -exec ls -ldb, open and close curly braces, / semicolon, right angle bracket, /tmp /file name. Now, if you're thinking, that's not very clear, well, let's break it down. Find directory, that's checking for all mounted parts starting with the specified directory. -user root is going to display files owned by root. -perm -4000 is going to print files only with permission set to 4000. The -exec ls -ldb is going to display the output of the find command in the ls dash. Right angle bracket /tmp /file name is going to write the result to the file name that we specify. All right. So now let's have a look at how to list all the files which have SUID permissions. So for this operation, you can use a command set that goes like this: find directory -user root -perm -4000 -exec ls -ldb, open close curly braces, / semicolon, right angle bracket /tmp /ckprm. All right, so that command will dump all of our files having SUID permissions into the ckprm file. And that brings us to yet another subtitle. You might have misread. It's not sticky bun, it is sticky bit. All right, so you know that there can be more than one user on a Linux system. Now, if there is more than one user, of course, there will be more than one file belonging to the users. Well, that's not a problem so far. However, just imagine that a file in a directory accessible to all users, for example, this /temp. Well, just imagine for just a moment, it's intentionally or unintentionally deleted or renamed by a user other than its owner. That's going to cause some problems. Is there a way to avoid it? Of course there is. So, in order to avoid that kind of situation, we'll say, the concept of sticky bits comes into play. So a permission bit, it's set on a file or directory that only allows the owner of the file or directory or the root user to delete or rename that file. No other user is given the privilege to delete a file created by another user. Well, check it out. It's time for our second topic that we're going to be covering in applying the appropriate access controls under Security Enhanced Linux, or SE Linux. Now, sure, as the title might suggest, SE Linux stands for Security Enhanced, and it's a security architecture integrated into the Linux kernel using Linux security modules, or LSM. So SE Linux defines the access and access rights of every user, application, process, and file in the system. Also in these files, a 1 will represent enforcing mode and a 0 will represent permissive mode. All right, now that you got that out of the way, when you're working with SE Linux, instead of operating in enforcement mode, you can work in a permissive mode where AVC, or the access vector cache, is checked and rejections are logged. Okay, so let's see why that would be important. First, we're going to talk about SE Linux configuration files and the related file systems. So here we've got the /SE Linux /sudo file system, and this is going to consist of some commands. Now, at the same time, these commands are among the most frequently used commands by the kernel subsystem, and you can always compare this type of file system to the proc sudo file system. It's, well, under normal circumstances, administrators or users don't even need to modify this file. But now you're going to know about it. So we'll continue with our SE Linux configuration files, and first file would be /etc/sysconfig/SE Linux. All right, so here's our configuration file. There are two methods of configuring SE Linux. In fact, first method we'll use is security level configuration tool, system config SE Linux. And the second method that we'll look at is, well, how to manually edit the configuration file, which is, like I said, in the etc sysconfig. So the etc sysconfig/SE Linux file is the primary config file for enabling or disabling SE Linux, as well as for setting what policy to apply and how to apply it on the system. All right, so let's have a look at the full subset of options available for configuration. So the first is SE Linux equals enforcing pipe permissive pipe disabled. So this defines the top level state of SE Linux on a system. So let's break down the terms enforcing, permissive, and disabled. Now, enforcing just simply means that SE Linux security policy will be enforced. Of course, permissive would mean SE Linux system prints warnings but does not enforce the policy. So it's very useful for debugging and troubleshooting. Actions that will force a transition in enforcing mode will be denied in permissive mode, but will be able to continue like this. So too many rejection messages are going to be logged. So SE Linux will stop the first pass and then will prevent any further rejection messages from occurring. So the term disabled just means SE Linux is fully disabled. SE Linux hooks are disengaged from the kernel and the sudo file system is unregistered. And that brings us to our second one here. SE Linux type equals targeted pipe strict. And it specifies which policy SE Linux should enforce. All right, let's have a little peek here at targeted and strict. So according to mit.edu, so it must be correct, targeted means that only the targeted network daemon is preserved. See, so policy enforcement for these daemons can be turned on or off using Boolean values controlled by the security level configuration tool, system config SE Linux. So you see, setting a Boolean value to 0 for targeted daemon disables policy switching for the daemon. All right, so strict means that full SE Linux protection for all daemons is enforced. Security contexts are defined for all subjects and objects, and every action is processed by the policy enforcement server. Which brings us to our third set local DEFS equals 0 pipe 1. Now, this is going to control how local definitions, so users and booleans, are set. You can set this value to 1 to have these definitions controlled by the load_policy from files in/etc/selinux/policy name, or you can set it to 0 to have them controlled by semanage. So moving right along with the directory /etc/selinux/. So this directory is obviously the primary location for the main config file and, well, all policy files. So I want to take you through some of the commonly used SELinux utilities. All right, so the first of the utilities is this set enforce, right? So you're going to use it to change the mode in which SELinux is running in real time. So for an example, set enforce 1 means SELinux runs in force mode. Set enforce 0 will mean SELinux runs in allowed mode. Now, if you really truly want to disable SELinux, you will need to specify the appropriate set enforce parameter in /etc/sysconfig/SELinux, or pass the SELinux equals 0 parameter to the kernel in /etc/grub.conf, or at boot time. Second one is /usr/sbin/SEstatus-v. So that's going to be used to view the detailed status of the system that SELinux is running on. Now, when you view it, you can see SELinux status, SELinux FS mount, current mode, mode from config file, policy version, and policy from config file. And the third utility is new role. All right, so /usr/bin/new role. And we're going to use that to run a new shell in a new context or role. Now, the prerequisite here is that the policy allows a transition to the new role. And let's have a look at the fourth utility, bin restoreCon. So this sets the security context for one or more files by marking extended attributes with the appropriate file or security context. And you'll find the fifth utility in fixed files. So this checks or fixes the security context database on the file system. Cool. And it brings us to the third topic that we're going to cover in Apply the Appropriate Access Controls, AppArmor. Now, AppArmor, just like SELinux, is used to provide MAC mandatory access control security. I know, it's easy to confuse MAC address and mandatory access control. Just don't. Anyway, the context is pretty self-explanatory. It's used by default, especially in Fedora and Red Hat distributions. But on the other hand, AppArmor is used by Ubuntu developers to allow processes to restrict the actions that they can take. And so AppArmor is particularly useful for restricting exploitable software such as a web browser or server software. If you happen to want to view the status of AppArmor, simply go to a terminal and run the sudo apparmor_status command set. So then once that command gets run, you can see if AppArmor is running or not. The installed AppArmor profiles, as well as the limited processes that are running. Awesome, we're moving right along to command line utilities as we apply the appropriate access controls, right? All right, so let's start with a umask command. Now, in Linux, one of the commands used to set default permissions for files or directories that the user creates is the umask command. So, how does this command work? Well, it's a command that the user uses to specify permissions that they do not want to be given to the newly created file or directory. So umask works by making a bitwise and, with a bitwise complement it uses, where bits are inverted. So 1 becomes 0 and 0 becomes 1. So the bits set in the UMask value refer to permissions that are not assigned by default, as these values are subtracted from the maximum permission for files or directories. The syntax of this command goes like this: UMask. So by running the command, you're going to get 0002 or a similar output. The first 0 starting over here on the left. So this value is the sticky bit. Now, hopefully you remember, this is a special security feature. Then the next 3 digits represent the octal values of the UMask for a file or directory. Okay, but what are these octal mode security settings? Okay. Read R, write W, execute X. So those permissions are used, but as 3-bit binary values. So I want to explain these triple permission values. 000, you might see it as -- means no permissions. 001, you might see it as -- means only execute permission. 010 or -W- means write only allowed. 011, you might see it as -WX, means write and play aloud. 100, you might see it as R-, means read only. All right? 101, R-X, this means it has read and execute permissions. 110, you might see it as RW-, this means it has read and write permissions. 111, RWX, this means it has read, write, and execute permissions. Okay, sure, you say, but wasn't our output 0002? Well, yeah. Okay, well, we got the first bit. How are we supposed to interpret the other bits? Well, first of all, just want to remind you that each number here is for different user classes. In Linux, there are user classes, right? Owner, group members, and, well, everyone else. So I want to come over here down to our 002 value, all right? 0 represents access to the owner. 0 represents access to group members, and 2 represents access to all. All right. So what would you notice here? This value 2 is an octal value and actually corresponds to the value 010. And now you know 010 is 0 for read, 1 for write, and 0 for execution. The value 0002 means giving write permissions to everyone. Okay, so we could also say that a UMask value can take a value between 000 and 777, not counting the leftmost security value. So if you want to set a UMask value, you just use the command set that goes like this, UMask 543. So let's figure out how to answer the question of how to calculate UMask values for files and directories. So UMask uses 666 as the full permission set for files and 777 as the full permission set for directories. So files are not given execute permissions by default. That's to avoid causing security issues. Well, if you execute the UMask 543 command, values of 5 for owner, 4 for group members, and 3 for all the rest are not directly assigned. These values are subtracted from the maximum permission set for files and directories. All right, so let's say that we use the UMask 543 command for a directory. Well, we'll first subtract 543 from 777. That's full permission for directories, right? So 777 minus 543 equals 234, right? Now, 234 means 2 for owner, right? 010 in binary, and means write permission for owner, 3 for group members, 011 in binary, write and execute permission for group members, and 4 for everyone else, which is 100 in binary, which means read permission for everyone. All right, so the output of the command will be D-W-WXR-. Now, if you want, we can edit it a little bit. It'll be a lot more understandable if we edit it to be D-W-WX R double dash. You see, so here D stands for directory. All right. So let's move on to creating permissions for a file then. When you create a new directory, the permission will be granted similar to the permissions on the directory. But there will be a small change, and watch this. You do remember that the full permission value for the file was 666, right? So we arrived at 666 minus 543 equals 123. Now, just as a little reminder here, Linux does not provide execute permissions by default for files, even if it is specified in the UMask. So let's start by explaining the value 123. All right. So 1 for owner. So 001 in binary. So the owner must be given execute permission. But Linux does not grant execute permission. By default, the execution cannot be 1, increasing the value by 1 to obtain 010. So the owner is given write permission. 2 for group members. That is 010 in binary. So write is allowed for group members as well. And 3 for everyone else. That is 011 in binary. And this value means write and execute permissions. But you also know that execute permissions cannot be granted. Therefore, the value is increased by 1. The value 011 plus 001 equals 100 is now obtained, right? So this value means this is going to allow everyone to read only. Cool. Now, when the command is executed, the output will be -w-w-r-. And I want to edit it a little bit more to make it clearer. And its final form will now be -w-w-r-. So now when you try to open this file as owner, access will be denied as the owner of the file only has write access to the file. You see that? So in other words, in order to open the file, we must either be an admin or group members except the owner. All right, so it really is time to introduce you to the chmod command. It's another command that is used to change the access mode of files. Chmod is short for change mod, okay? The syntax for this command is chmod reference operator mode file. So the references here are used to distinguish the users to whom the permissions apply. That is, the list of letters indicating to whom the permissions are granted. Okay? Now, one or more can be used. So in references, U stands for the file owner, G for the group members, O are users that are different from the file owner and group members, and guess what? UGO denotes all 3 groups. Now, let's have a little chat about operators. The plus operator means add the specified mods to the specified classes. The minus or dash operator means remove the specified mods from the specified classes. The equals operator means that the specified mods will be made full mods for the specified classes. Now, I do want to give you a little reminder here, though, too. Putting space or spaces around the operators are going to cause the command to fail. All right, so let's get into mods a little bit more. Mods specify which permissions to grant or remove from the specified classes. So as you know, there are 3 basic modes to corresponding basic permissions. These are R for permission to read the file, W for permission to write or even delete the file, by the way, and X is for the permission to execute the file or search in the case of a directory. Now you can use the ls-l command, and you'll be able to see all permissions of the different files in the Linux terminal. So this command will list the files in the working directory in long format. Now, if you look at this screen really closely, you can see that the leftmost column tells us that there is a file with minus and a directory with D, right? The next three columns indicate permissions granted to the owner of the file directory. The next three columns are the permissions granted to group members, and the next three columns, the permissions of the other users. Then the column after represents the file owner's name, and the next column represents the group that the file owner belongs to. Okay. Now, also, you got to remember that when a directory has a set X, it takes the special meaning of this directory has search permission. All right. So now you're ready to check out how chmod can be used to change the access mode of a file. So let's say you have a file called linux_trainer.c, and this file permission looks like this, -rw, -rw, -r-. Now you can see the owner of the file has permission for reading and writing. If you want to change this permission, you can use this command set, chmod u equals r linux_trainer.c. All right, so then after using this, you can see that the owner of the file only has read permission now. -r, -rw, -r-. Yeah. So then perhaps you might ask, what's the difference between using chmod and umask? Well, the umask command can only be used on new files and when creating new files. See, the umask command cannot change the permissions of previously created files. The chmod command naturally should only be used on files that already exist. So it's used to change the access permissions of previously created files. All right. So then we need the umask command set to set default access permissions for future created files and directories. And then we use the chmod command to change access permissions for already created and already existing files. Awesome, we're moving right along to command line utilities. All right, let's continue with the chatter command. Yeah. See, the chatter command is a file system command used to change the attributes of a file in a directory. Its most important use, though, is to make a file unmodifiable for non-super users. As you may know very well, Linux is a multi-user operating system, and a user has a chance to delete a file that could be very important to another user. We won't get into that. But it's always going to create a security vulnerability. Think of it that way. So that means we can use the chatter command to prevent the security issue even before it occurs. So with this command, you can make a file immutable, undeletable, and only appendable. So I'll show you the syntax of this command. It goes like this: chatter, in square brackets, -rvf, in square brackets, -v, version, in square brackets, mode, files. Now, we have talked about this before, but I want to run it down again. In the beginning of a mod string, one of the following operators needs to appear. The plus is going to add selected attributes to existing attributes of files. The minus will remove the selected attributes. If there's an equals, that means that the selected attributes are the only attributes that the files have. So it can actually go like this, in square brackets, plus, minus, equals, in square brackets, options of the command. So let's have a look at a list of the common attributes and associated flags that may or may not be edited using the chatter command. The capital A set means a time record is not updated. The capital S set means changes are updated synchronously on disk. The A set means file can be opened in append mode for write only. The I set means the file cannot be modified, unchanged. Only super user can unset the property. The J set means all file information is updated to the ext3 log before updating the file itself. The T set means QMerge is not allowed. The D set means, well, there's no more backup candidates when the dump is run. When U is set, it means when such a file is deleted, its data is saved, and it allows a user to undelete. But see, all of those commands are not for files. They can be used in directories or folders, and to protect a directory from deletion or other similar accidents. However, when securing a directory, it is recommended to use the -R flag to recursively secure all content in the specified directory. Now, there are a few different options, though. So these will be -R, and this is used to display the list of attributes of directories and their contents, again, recursively. -V means it's going to display the version of the program. -A is used to list all the files of a directory, which also include the whose name starts with a period. -D means this option will list the directories as regular files instead of listing their contents. -V means, well, this is just used to display the file's version and generation number, that kind of thing. So this chatter command can be used to preserve some system files that are very important, and it needs to remain in the host PC no matter what, right? It's also used to make a directory undeletable or unmodifiable for users other than super user. So in other words, it's the "this is absolutely necessary" stamp. Now, if you want, why don't we just go ahead and make a chatter command application on a test_file.txt. That way I'll give you some better understanding about this. So I want to see the attributes of the file using the ls_attr, or the list attribute command. Then we're going to make our file immutable by executing the command sudo chatter +i test_file.txt. So let's see the change that we made first. So we use the ls_attr command. All right, so now let's restore our file whose attributes we changed. And you can do this with a sudo chatter -i test_file.txt command set. Now, let's check to see if we actually got it back. Of course, we'll use that ls_attr again. Now, if we want to open a file in append mode only and not change any previous data, we can use the A option, and we'll do this with the ls command. So first, we're going to list our file and have a look at its attributes. So we'll do this with ls_attr. All right. So now we'll edit our file so that it only works in insert mode. And the command set for that would go like this: sudo chatter +a test_file.txt. So now I want to look at the contents of our file again with the cat test_file.txt command. All right, let's try to write some text that we want into the file using echo Linux users right angle test_file.txt command set. So to write a file using the echo command, we use the right angle bracket sign before the file name. However, if it has been written into the file before, well, this application is going to give an error. So that means we just use the double right angle bracket instead of a single angle bracket. Did you get an error message? Well, then let's go ahead and apply echo Linux users double right angle test_file.txt command set, and then look at the content with cat test_file.txt command. All right, so we're going to continue here with chgrp. So this is obviously the command used to change the group ownership of a file or directory, right? So it's, well, however you want to say it, chgrp. But every file in Linux has an owner and a group it belongs to. And you can edit the owner using the chown command, as well as the group by using the chgrp command. Chgroup, if you want. So the syntax for this command goes like this: chgroup option, group file, or chgroup option -reference equals rfile file. You see that? So I need to remind you that in order to add or delete groups, we must first have administrator permission. Now, if you do want to create a new group, you can use the sudo add group Linux_trainer command set. And now we're moving right along. we got the get se bool command. So, we're here under this topic of SE Linux. Talked about Booleans and how they allow you to change the SE Linux policy at runtime without any need to write additional policies. Now here we have the set se bool command, and this can be used to change or turn on or turn off an SE Linux Boolean value at runtime. So for example, it could go like this: set se bool Linux _trainer on. Yeah. The get se bool command can be used with the -a option to display a list of all SE Linux Booleans and their current values. For example, it could be like this: get se bool -a. All right, so moving right along, we can go ahead with the chicon command. Chicon can be used with SE manage and restorecon to fix an incorrect SE Linux context. So in short, this command is a helper command to change SE Linux content or file type. Another command that you'll find useful is restorecon. Another way to change the SE Linux context of a file or directory is to use this restorecon command. You can use this to restore the default context of a file or directory by reading the default rule set in the SE Linux policy. So if you do want to restore files to the default Linux security context, you can use restorecon as your command. All right, so moving right along, we'll go to audit to allow. So you can think of this as a utility. So when the system refuses to allow transactions, it scans the logs for logged messages and creates a policy rules widget that, when uploaded to the policy, may have allowed these transactions to succeed. However, this utility only creates type enforcement, or TE, allow rules. So audit to allow generates SE Linux policy allow don't audit rules from logs of denied operations. Add containers and automation. So our first subtitle here is create simple shell scripts to automate common tasks. Sounds like it could be very useful. So the first thing that we want to cover here in create simple shell scripts to automate common tasks is going to be the shell script elements. Now, an important part of process automation in Linux is shell scripting. This process actually helps you write a series of commands to a file and then execute those commands. You don't have to type specific commands over and over to perform these tasks. You can also automate these tasks repetitively by scheduling them. You can set certain scripts to be executed at startup, for example, the message to be shown when a session is started, or the setting of certain environment variables. So we'll start with the bash shell. Now, the Linux command line is provided by a program called a shell. You know this. But different users can be configured to use different shells. However, despite this diversity, most users prefer to stick with the current default shell. So the default shell for many Linux distros is the GNU Born Again shell, or bash. So bash is replaced by the Born shell, which is history, and you can read about that on your own time. So when you first start the shell, it's going to use a startup script located at .bashrc or .bash_profile. And this is the file that will allow you to customize the shell's behavior. As you've seen with terminal applications, when a shell is used interactively, it displays the $sign while waiting for a command from the user. This is actually called something. It's called a shell prompt. So for example, username at host tilde with the shell prompt at the end. All right, so an important detail here is that if the shell is running as root, the prompt is changed to the $sign. Follow? So the super user shell prompt will look like this: root at host tilde shell prompt. Now, why do users use bash and not a GUI? I'll tell you why. Bash is actually preferred because it can really simplify certain operations that are difficult to perform efficiently, when you're talking about time, your own time, human time, when you're using a GUI. So I also want to remind you that most servers don't actually have a GUI, and learning to use the privileges of a command line interface or CLI will be very helpful when you're solving problems. So then, what is a bash script? How's it written? How do you run it? Cool. We can briefly describe a bash script as a series of commands written to a file. So this script is read and executed by the bash program. An important point here, though, is that these scripts work line by line. Okay. For example, using the command line, you can navigate to a specific path, create a folder, and create a process in it. If there is a need to run these command line operations more than once, you can follow the same steps by saving these commands in a bash script and running them. You can also run the bash script as many times as you want. So why don't we just take a look at the steps of defining the bash script. So first of all, I really do need to point out that the bash script files have this .sh, the extension, but it can work out just fine without the sh extension. The first thing to notice here when we move on to the file contents is that the scripts will start with a bash bang. Scripts can also be identified with a shebang. And these are used to follow the bash shell path. So in other words, the first line of the script, the shebang, tells the shell to execute it through the bash shell. The shebang is an absolute path to the bash interpreter. So an example of a shebang statement goes like this: shebang /bin/bash. And if you want, you can change the path of the bash program. And we talked about user permissions for files and directories earlier. For bash script files, well, these have execution rights for the users executing them. Now, an execution right is represented by an X. So, for example, we'll create a bash file called test_script.sh. We'll define the permissions for the user like RWX, right? Read, write, execute. And we'll do that to this test script. Now, on the other hand, executable scripts appear in a different color than other files and folders. That way you can easily notice them. So I do want to show you how to create a simple script that outputs Linux Academe in bash. So firstly, you create a file called linux_academe.sh. And for this process, you can use touch linux_academe.sh for your command set. Then you can just find the path to your bash shell. And for this process, you can use which bash for your command set. And you can easily find the bash path. All right, so let's type the command. We'll edit the Linux Academe file using a text editor of your choice. And you'll add the shebang usr/bin/bash line. Then add echo double quotes, hello Linux learners, double quotes. Cool. So now it's time to decide the user permissions. And for this process, you use the chmod u+x linux_academe.sh command set. Now, you know this process meaning. Chmod changes the existing rights of a file for a specific user. We'll add +x for execute to user u, which is the owner of the file. Very good. So the last step here is then to run the script. So for this process, you can use ./linux_academe.sh or bash linux_academe.sh. Now, like other programming languages, bash script has a syntax. Of course, that's a set of rules that has to be followed in order to create computer understandable programs. Anyway, let's start just by examining the syntax of the bash script. So what we do is let's have a look at defining the variables. We can define a variable using the syntax variable_name equals value. To get the value of a variable, just go ahead and add the $sign before the variable. And if you want, why don't we just write a simple example program? Even if you don't want, we're going to do it anyway. We'll start with the shebang /bin/bash. Okay, you can also add in a comment line, starting with the # sign. So I'll add a comment like, hash variable usage in bash. And I'm going to make my first variable definition be var underscore first equals high. And my second variable definition will be var underscore second equals learners. So the next one would be to call and use these variables. And you do that just by typing echo $var underscore first $var underscore second on the command line. And you can see the output. Very cool, very cool. Of course, there are arithmetic operators that bash supports that you can always use when writing programs. As in most programming languages, operators like plus for addition, minus for subtraction, the star key for multiplication, and the / for division, double star for exponentiation, as well as the % sign for modulus get used. Also, you can use numeric expressions to be calculated and truncated in a variable using a syntax such as this. Var equals $, double parentheses, expression, close double parentheses. So, for example, you can use var equals $, double parentheses, 3 * 7 for 3 times 7, close double parentheses, followed by echo $var, and display the output. Okay, now fractions are calculated and truncated correctly in a different method. For decimal calculations, we can use the BC command to get output to a certain number of decimal places. BC just stands for bash calculator. It's a command line calculator that supports calculation up to a certain number of decimal places. So, for example, echo scale equals 2 semicolon 22/7 pipe BC. This is going to have 2 decimal digits in the output of the command line. All right, now, user inputs also need to be reliable to increase user interaction. That makes sense. But it's actually done by the read command. I'll show you how to use that command. It goes like this: read variable underscore name. You can also use the -p flag to prompt the user for a custom message. For example, if an operation requires a number to be entered, you can use the read-p. Please enter number variable underscore name command structure. So, for example, let's say you want to calculate the product of 2 entered numbers. Well, we can write a bash script for that to do it. So we'll write shebang /bin/bash on the first line, then echo, and in double quotes, enter the first number equals, close double quotes for your message. So the next is to read the entered number. We'll read it with the read n1 command line, and then transfer it to the n1 variable. So now let's execute the read-p, enter the second number equals n2 command line, and this will be reading the value of n2. All right, read-p, double quotes, enter the second number equals double quotes n2. So now let's multiply these two values and print them on the screen. And you can do that with the command lines var equals $, open double parentheses, n1 * n2, close double parentheses, and echo $var. Now, as in some of the other programming languages, numeric comparison logical operators get used in a bash script. Now, these operators are used to decide whether 2 or more expressions being compared are true. All right. So for comparison purposes, for equality, we've got -eq for greater than equal, dash GE for greater than, dash GT for less than equal, dash LE for less than, dash LT for not equal, dash NE. Now, if the syntax for comparison operation goes like this, if, in square brackets, conditions, then commands FI. In fact, let's just do an example application, and we'll create the output by comparing two numbers that the user will enter. So we'll write read N1 to read the first number and read N2 to read the second number, and we'll move along to the comparison part. If, open square bracket, $N1 dash GT, $N2, close square bracket, then echo $N1 is greater than $N2. If, open square bracket, $N1 dash LT, $N2, close square bracket, then echo N1 less than N2. Elif, open square bracket, $X dash EQ, $Y, close square bracket, then echo N1 equals N2, FI. Of course, the loop and skip commands are also used in Bash. You know what? Let's get started with a for loop. So this loop structure is going to allow you to execute statements a certain number of times. That is, it will iterate from a start value through to an end value that you specify, as long as it doesn't break. So for example, let's try to print the numbers from 1 to 10, so our cycle will repeat 10 times. All right, so we'll start off by typing shebang /bin/bash for I in, open curly braces, 1 through 10, close curly braces, do echo $I, done. So we could print the variable I from 1 to 10 by setting up a loop. We can loop not only with numbers, though, but also with strings. So I want to just explain this process a little bit with an example. All right. So we start by typing shebang /bin/bash for I in London, Paris, Madrid, do echo $I, done. See, so now we can print the specified cities one after the other, establishing a loop. Cool, let's take a peek into the while loop. Now this type of loop will repeat as long as a condition is true, not within a certain range, right? So these loops need a counter in order to, check after each iteration. But this counter also needs to be incremented or decremented at each iteration. So for example, the operation I plus equals 1 increases the value of I by 1 at each iteration. Now this expression has the same function as I equals I plus 1. Very cool. So let's print the numbers from 1 to 10, which we did in the for loop, but we're going to do it this time with a while loop. And as usual, we'll start with the command line shebang /bin/bash. And we'll assign the value 1 to the I equals 1 counter value, while, open square bracket, $I dash LE 10, close square brackets, semicolon, do, echo $I, open double parentheses, I plus equals 1, close double parentheses, done, and in curly braces, click. So when we write this command, as long as the I value is 10 and less than 10, it will print the numbers on the screen. Now we could make that work automatically by programming the jobs that we write in the bash script. And for that, we'll use the cron utility for this process. So cron is a job scheduling tool found on Unix-like systems. You can schedule jobs to run daily, weekly, monthly, or at a specific time of day. Automation in Linux actually relies heavily on cron jobs. And the syntax for scheduling crons goes like this: *********************************************** /path/2/script.sh. So here, each star represents minutes, hours, days, months, as well as days of the week, respectively. And it represents 5 different arguments. So, for example, the value 50*8* means at 0005 in August. And the value 022**1-5 means at 2200 every weekday, Monday to Friday. All right, so we're moving right along. We are going to cover the next topic in Create Simple Shell Scripts to automate common tasks with common script utilities. So I don't know if you've heard of awk, but awk is a scripting language. Scripting language is used to process data and generate reports, AWK, awk. So this command programming language does not require any compilation. On the other hand, it allows the user to use variables, numeric functions, string functions, as well as logical operators. awk is a find and replace utility that allows programmers to write small but effective programs in the form of statements on each line of a document that describe the text patterns to search for and the action to take when a match gets found. awk is pretty much mostly used for pattern scanning and processing. It searches one or more files to see if they contain lines that match the specified patterns and then perform those associated actions. So then, what is all that? What are these operations that we can do with awk? Well, I suppose to answer this question, we could scan a file line by line, split each input line into fields, compare the input line or lines with patterns, and perform actions on the matching line or lines. All right, so awk is also very useful for converting data files and generating formatted reports. Why didn't you say so at first? Well, from a programming logic perspective, you can format output lines, perform arithmetic and array operations, as well as using conditions and loops. Yeah, we're getting deeper. awk's syntax goes like this: awk options, single quote, selection underscore criteria, open curly brackets, action, close curly brackets, single quote, input dash file, right angle bracket, output dash file. Ooh, there's options in awk. Yes, of course. The dash F program dash file, we use this to read the awk program source from the program file instead of from the first command line argument. Okay. Dash capital F, FS, is used for the input field separator. All right, and this brings us to the sed command. The sed command in Unix, just like awk, stands for stream editor, and it can perform many functions on the file. That's just like awk, such as searching, finding, and replacing, adding, deleting. Now, although the general purpose of this command is for substitution or finding and replacing, I mentioned that using sed, you can edit files without even opening them. You can imagine that finding and replacing something in a file would be a lot slower and way more inefficient than replacing it before you even ever open it. But you got to be careful. Duh. Okay, so let's just say, again, that sed is a very powerful text flow editor. You can add, you can delete, you can search, you can replace, or even substitute, okay? You don't take that responsibility lightly, my friends. All right, let's get to the syntax for the sed command. It goes like this: sed, single quote, s, /Unix, /Linux, single quote, Linux underscore trainer.txt. All right, now we're going to continue with the find command. Find command, obviously, is a command line utility, and it's used to examine a file hierarchy. Now, we can use it to find and perform operations on files and directories. Support searching by file, folder, name, creation date, modification date, owner, permissions, and just by using the -exec, other Unix commands can be executed in files or folders that will also exist. So the syntax of the command goes like this: find, and in square brackets, where to start searching from, and in square brackets, expression determines what to find, and in square brackets dash options, and in square brackets what to find. Okay, so let's talk about some of the command options. Let's just go through them one by one. Dash exec cmd. So the file that's being searched, which meets the criteria and returns 0 for its exit status for successful command execution. Dash OK cmd. Works the same way as dash exec, but the difference is the user is prompted first. Dash inum-n. This will mean searching for files with inode number n. Dash links-n. This is going to search for files with n links. Dash name demo. This is going to search for files that are specified by demo. Dash newer file. This will search for files that were modified or created after file. Dash perm octal. Now this means it's going to search for the file if permission is octal. Dash print is going to display the path name of the files found by using the rest of the criteria. Dash empty. Well, this is going to search for empty fields, files, and directories. Dash size plus n slash dash n means search for files of n blocks. N followed by C can be used to measure the size in characters. Plus n means size. Right angle bracket n, blocks, and dash n or minus n means size. Left angle bracket, n blocks. Dash username. Well, this is going to search for files owned by username or ID name. Backslash, open parenthesis, expr, backslash, close parenthesis, means true if expr is true, and this is used for grouping criteria combined with or and. Those are the operators. Bang expr. So this is going to mean true if expr is false. So if you want to search a file with a specific name and in a specific directory, just use this find dot / in square brackets directory underscore name, close square brackets, dash name, open square brackets, file underscore name, close square brackets. So this will search for file underscore name in directory underscore name as the directory. Now, if you want to search a file with a pattern, you can use this command set, find dot / in square brackets directory underscore name, dash name star.txt. And then this is going to search for all the files in the directory underscore name directory, which have the .txt file extension. Now, if you want to search for empty files and directories, you can use this command set, find dot / in square brackets directory underscore name, dash empty. And this command is going to find all empty folders and files in the entered directory or subdirectory. So moving right along, we'll continue with xargs command. So the xargs command, it's a Unix command, but it can be used to create and execute commands from standard input, for example, a txt file. So some commands like grep can accept input as parameters, but xargs accepts arguments. So the syntax for this command is xargs in square brackets options in square brackets command. So before we move ahead with this, I want to show you some of the command's options. -0. This is going to mean that input items are terminated with a null character instead of a space. -a file means read items from the file instead of standard input. -delimiter equals limit means input elements are terminated with a special character. -E EOF-STR means set the end of the string file to EOF-STR. -L replace-STR means replace occurrences of replace-STR in first arguments with names read from the standard input. -L maximum lines. This is going to mean using a maximum of non-blank input lines per command line. -P. This is going to ask the user whether to run each command line and read a line from the terminal. -R means do not run the command if the standard input does not contain spaces. -X is going to mean output if the size is exceeded. -help means print a summary of options to xargs and exit. -version, well, this will print the version number of .xargs and exit. All right, so let's get into the command usage with these options. So if you want to display the contents of a file, you can just use xargs-a file_name.txt. If you want to prompt for a confirmation before running each command line, well, you can use xargs-p-a filename_.txt. So this is only going to run the command line if the response starts with Y or capital Y. All right, so moving right along, we'll continue with egrep. So the egrep command, as the name would suggest, is a pattern search command, and this belongs to the grep family of functions. It performs the same task as grep-E. It's going to print the lines that match the pattern. If there are several files with a matching pattern, it's going to also display the file names for each line. So the syntax of the command goes like this: egrep, in square brackets options, in single quotes, pattern, files. So my question, or your question might be, why use egrep when grep-E is available? Well, the egrep command treats meta characters as they are and quickly performs a complete search. Keep that in mind. Okay. That brings us to the T command. So the T command, this gets used when it's necessary to read the input and output at the same time, or to write the same output to a file. So this command reads standard input and can write to both standard output and one or more files. It basically cuts the output of a program so it can be both viewed and saved to a file, right? So it's doing both tasks at the same time, right? Copies the result to the specified files or variables and displays the result. So the syntax of this T command goes like this: T, in square brackets, option, file. So here you have a file named linux_trainer.txt. And let's say that you want to find out the number of characters in your file and save the output to a new text file. So you're going to be able to do both operations at the same time. And the command set's going to look like this: wc-l linux_trainer.txt, pipe t new_file.txt. And you see, as a result, you're going to have that output both on the screen and in the new_file.txt. All right, so we're going to continue now with the wc command. All right, no jokes here. WC stands for word count. All right, so as the name suggests, it's mainly used for counting words. Now, in our previous application, we used it together with a T command. You might have seen that. This script gets used to find the number of lines, words, bytes, and characters in files specified in the file arguments. Not just for words anymore. So it's going to display a 4-column output. The first column shows the number of lines found in the specified line. The second column, the number of words in the file. And the third column is the number of characters in the file. This fourth column is the file name given as argument. So the syntax of the command goes like this: wc in square brackets options and square brackets file. So I want to consider a couple of files having this name state.txt and capital.txt, containing 5 names of the states and capitals respectively. So let's do a couple of sample applications of this wc command. So let's say you want to count all files and folders present in a directory. Well, you can use ls in square brackets directory_name square brackets pipe wc-l for the command set. So with this -l option, the command shows the count of all files and folders present in the current directory. Now, let's say you want to display the word count only of a file. You can use wc-w linux_trainer.txt. See, so that command is going to show you 2 columnar outputs. So one is the count of words, the other is the file name. All right, that's how that works. So I want to continue on with this tr command. So in Linux, another command line utility is tr, or the tr command. The tasks will include a number of conversions, such as translating characters like uppercase to lowercase, squeezing duplicate characters, deleting certain characters, and some basic find and replace processes thrown in for a bonus. All right, so the syntax of the command goes like this: tr in square brackets option set 1 in square brackets set 2. So you want to talk about options, huh? -C is going to mean to complete the character set in the string. That is, operations are applied to characters not in the given set. -D means to remove characters from the first set of the output. -S is going to mean to replace duplicate characters listed in set 1 with a single occurrence. -T just means to shorten set 1. So let's say you want to convert from lowercase to uppercase the content of a file. You can use the cat new underscore file pipe tr, open double quotes, in square brackets A through Z, or A-Z, close square brackets, double quotes, open square bracket, capital A dash, capital Z, close square brackets, double quotes. Or you can use this one as well: cat new underscore file pipe tr, double quotes, open square brackets, colon lower colon, close square brackets, double quotes, open square brackets, colon upper colon, close square brackets, double quotes. Moving right along, we've got the head command. So obviously it's a complement to the tail command. The head command, as the name would imply, prints the top n number of data of the given output. Now, by default, it's going to print the first 10 lines of the specified files. So if more than one file name is provided, then data from each file is preceded by its file name. All right, so the syntax of this command goes like this: head, open square brackets, option, close square brackets, and in square brackets file. So this command will display only the first 10 lines of the file specified without any options. For example, head Linux underscore trainer.txt. I mentioned there's a few different options to this command. We'll have a look. -n num, this is going to mean to print the first num lines instead of the first 10 lines, right? So num is mandatory to be specified in the command. Otherwise, it's going to give you an error. Okay, so for example, -n5 new underscore file.txt, you can see the first 5 lines. -cnum means to print the first num bytes from the file selected. So new line count as a single character. So if the head prints out a new line, it's going to count it as a byte. Num is also here a mandatory specification in the command. Otherwise, it's going to give you an error. All right, so for example, head-c8 new underscore file.txt, you'll only see the first 8 characters. -q is used if more than one file is given. All right, so this command ensures that file names are not displayed before the data. Now, if you use head Linux underscore trainer.txt new underscore file.txt as your command set, you're going to see the file name before the contents. You see that, right? But if you use head-q Linux underscore trainer.txt new underscore file.txt command set, you're not going to be able to see that file name before the contents. All right, so that's how that works. So we'll continue with the tail command. Obviously, it complements the head command. I gave that to you previously, but this tail command has a couple of things unlike the head command. See, it prints the last n lines of the given input. Now, by default, it's going to print the last 10 lines of the specified files. If multiple file names are provided, well, data from each file will precede the file name. So the syntax of the command looks like this: tail in square brackets option in square brackets file. Now, if you use it without any options, it's, like I said, going to display only the last 10 lines of the specified file. In addition, its options are similar to the head command. So some of those options will be -n num, -cnum, -q, -f, and it goes on, okay? And we've got another topic here to cover in Create Simple Shell Scripts to Automate Common Tasks. We're going to talk about environment variables now. So environment variables, or ENVs, these are going to determine how the environment behaves. Now, these are also going to affect ongoing processes or programs that are running in the environment during behavior determination. It's going to determine the scope of the region that an environment variable can access and is actually defined on. So in Linux, we can talk about two types of scopes for an environment variable. That's going to be global or local. A globally scoped environment variable can be accessed from anywhere in the terminal. All right, so this means that it can be used in any script, program, or process running in that terminal-bound environment. Now, likewise, an environment variable defined in the terminal with a local scope can only be accessed by the terminal itself. All right. So the syntax for accessing ENVs goes like this, $name, and there's no distinction between global and local scope ENVs for access mode. So if you want to display an ENV, the syntax that you'd use would be echo $name. And of course, if you want to view all ENVs, you can do this one with one of these, print ENV, set, or ENV commands. Of course, setting ENV is also an important issue. You can use the export name equals value or set name equals value command sets to set global environment variables, and the name equals value command set to set local environment variables. All right, so it's also possible to set ENV on a user basis, and the variable is set and configured in the files ~/.bashrc ~/.bash_profile ~/.bash_login, and of course ~/.profile, depending on the need. And of course, these variables will be able to be accessed by a specific user. Very cool. So how should we go about setting up system-wide ENVs? That's always a good question. So based on needs to edit an EN variable system-wide, it's first necessary to set and configure it in the files /etc/environment /etc/profile /etc/profile.d/ and /etc/bash.bashrc. Now, you know, these variables can be accessed by any user and it'll persist through shutdown. So for this editing process, we just follow the user-based editing steps the same way. Let's have a look at some of the commonly used ENVs in Linux and their functions. $user. So this is used to get the current username. $path is used to give the search path for commands. $pwd. It's used to give the path to the current working directory. $home. This is used to give the path to the home directory. $hostname is going to be used to give the name of the host. $lang. Well, this is used to learn the default system language. $editor is used to find out the default file editor. $uid. This will give you the user ID of the current user. $shell. This will find the location of the current user's shell program. Very good, very good. So we're moving right along here to the next topic that we're going to cover in Create Simple Shell Scripts to Automate Common Tasks. We're going to talk about relative and absolute paths and learn them. Now, in all operating systems, files and directories are stored according to a certain hierarchy, right? The location of files and directories in an operating system's file system is what we call a path. So this path, it's a unique location to a file or folder. It gets a combination of slashes and alphanumeric characters. All right, so let's break down the hierarchy a little bit, and we'll examine the absolute path name. So this concept of an absolute path, well, we define it as specifying the location of a file or directory from the root directory slash. So if you want to type an absolute path name, you start at the root directory slash and go down in the file system hierarchy, right? So you type a slash after each directory name, and the last one could be optional. Now, as you can see, the levels in the hierarchical structure are separated from each other by this slash, the / sign. You cannot run a non-root application with a command set like cat linux_trainer.txt. You need to type the path where the linux_trainer.txt file is located, followed by the file name. For example, cat/home/linux_trainer/linux_trainer.txt. Awesome. So that means we can now talk about relative path. So to evaluate the relative path with your current directory in mind, I'll tell you that this path is defined as the path directly related to the current work, PWD, right? So it starts in your current directory, and therefore it never starts with slash. Got it? So let's say we have a path like /home/linux_trainer/docs. Okay. Now, under normal circumstances, we'll need to write the absolute path /home/linux_trainer/docs to access the documents in the docs directory. Yeah. However, if we're already in the Linux_trainer directory, we just need to write docs. So Unix provides a shortcut in the relative path name that references the current or home directory and specifies the path relative to it. So a relative path name uses one of the symbols, a single dot or two dots. A single dot will represent the current directory, while two dots represents the home directory. You might even hear me say double dot from time to time. All right, so if we were, let's say that we want to change the directory with this relative path concept, these are the commands. $pwd/home/linux_trainer, $cd docs, $pwd/home/linux_trainer/docs. Now, let's say that we want to change the directory with the concept of the absolute path. It goes like this. $pwd/home/linux_trainer, $cd/home/linux_trainer/docs, $pwd/home/linux_trainer/docs. Yeah, so that brings us to our next title, which is Containers and Automation. And we've got our subtitle here, Perform Basic Container Operations. So you see why we break it down like this. Because the first topic that we're going to cover here in Perform Basic Container Operations will be container management. Now, just like in the Windows operating system, Linux operating systems also have virtualization and virtualization tools. You might have heard of Docker. This is a virtualization tool that runs on Linux. So each environment is called a container. Okay. Managing containers is essential for running in Docker. A container uses an image of an operating system that's optimized and pre-configured for a specific task. So when a Docker image is launched, it resides in a container. For example, multiple containers can run the same image concurrently on a single host operating system. There are several methods that you can use to list Docker containers. And the basic syntax for using Docker goes like this: Docker command with options. And you can use the command set Docker PS to list all running Docker containers in a terminal window. Now, if you want to list all containers with their run states, you must add the -A option. So the command set will be like this: Docker PS -A. So let's say you want to list containers by ID. Use the -AQ option. So that changes the command set a little bit. It'll look like this, Docker PS-AQ. And then let's say that you want to list all containers with their total file size. Well, you got to grab the -S for size option. And the command set will look like this, Docker PS-S. Now, if you want to list the most recently created containers, you can use the -L option. And that'll change your command set to look like Docker PS-L. Now, apart from what we've just mentioned, there are columns of information provided by the PS command. So let's run them down. Container ID gives you a unique alphanumeric number for each container. Image means the underlying OS image on which the container is based. Command is that which starts the container. Created will give you how long ago the container was created. Status will give you uptime or downtime. Ports will give you specifications on all ports forwarded to the container for networking. The name is, well, basically gives you a memorable name assigned by the Docker software. Which leads us to the next topic. In Perform Basic Container Operations, we're going to learn all about container image operations. Now, according to linuxize.com, a Docker image is the blueprint of Docker containers. It contains the application, everything you need to run the application. So a container, is a runtime instance of an image. All right, then, what is a Docker file then? A Docker file is a text file that contains all the commands a user could run on the command line to create an image. It includes all the instructions needed by Docker to build the image. Docker images are made up of a series of file system layers representing instructions in the image's Docker file, and that makes up an executable software application. So the form of a Docker file goes like this: instruction, arguments. Now, instruction doesn't happen to be particularly case sensitive, but the convention is and has been and probably always will be to use uppercase for the names. So let's break down and I'll describe to you some of the most used Docker file instructions. Arg. So this will mean that you want to define variables that can be passed at build time. So if you need, you can set a default value. From. This will mean getting the base image for building a new image. Label. Use this to add metadata to an image, such as description, version, author, that kind of thing. And that goes on, etc., etc. Run means the command specified in this instruction will be executed during the build process. By using add, you can copy files and directories from the specified source to the specified destination on the Docker image. And copy is pretty similar to add. The source can be only a local file or directory, however. env. Well, you use env to define an environment variable. Use cmd to specify a command that will be executed when you run a container. Then we got entry point. It's similar to cmd. This instruction defines what command will be executed when running a container. Workdir. Well, you use this and it'll set the current working directory for the run, command, entry point, copy, and add instructions. User will allow you to set the username or UID that you want to use when running run, cmd, entry point, copy, and add instructions. And volume, you'll use this to mount a host machine directory to the container. And you can use the option expose to specify the port on which the container listens at runtime. So the first topic that we want to cover here in performing basic version control using Git is indeed version control. So version control, or revision control, or source control, Now, these expressions are very close to each other. They're similar, and they're very important for both users and the management of the operating system. So it's really important to keep them clear. It's part of version control to be able to recall specific versions later or save changes made to the file collection over time. Now, also, the version control system, or VCS for short, is a tool that records changes made to files in a file system. You will definitely encounter many version control systems out there in the market. Especially Git is currently known as the most popular and frequently used system for source code management. Now, version control can also be used for almost any type of file on a computer, by the way. But I'll break down some of the most popular things that we can do with version control systems and their tools. Create versions of a project, Natch. Keeping track of changes and resolving conflicts, of course. Merging the changes into a common version. Undo changes made to selected files or the entire project. Accessing past versions of a project for comparison when that's needed. See who last changed the source of the problem. Creating a secure offsite backup for a project. Now, a project under a version control system will have three major parts. These partitions are the repository, the workspace or directory, and the staging area. So the repository contains all necessary Git metadata and objects for the new project. The working directory or space stores a copy of the project files that you can work on. And the staging area is a file in the Git directory that you are ready to save that stores information about changes. So there are two main types of VCS. There's centralized version control systems and distributed version control systems. Perhaps the key feature of centralized version control systems, or CVCSs, is that each project team member has their own local working directory, and they commit all their changes in only one central repository. And then in distributed version control systems, or DVCSs, each project team member has their own local working directory and Git directory that they can commit to. And then once someone has made a commit locally, other team members won't be able to access the changes until they push the changes to the central repository. All right, so that means, yes, Git is basically an example of DVCS. If you happen to be looking for a version control system that is free and open source, fast, powerful, distributed, easy to use, very efficient on large projects, with a remarkable branching and merging system, Git is for you. And this isn't even an advertisement. So let's say that you want to install Git on Linux. You can start by choosing the appropriate command for your distro. So that means for Debian and Ubuntu, you can just use the sudo apt install git command. For CentOS and RHEL, you can use the command set sudo yum install git. All right. Now, after installing Git, you will need to register with Git by entering your full name and email address. And you can do that very easily. And the command sets will look like this. Git config --global user.name, and then in your double quotes name and surname. But there's also the command set git config --global user.email in double quotes name surname at gmail.com, for instance. And if you want to check your Git settings for testing purposes after that process, you can just use the git config --list command set. All right, so now it's time to create a new Git repository. I'm sure you know shared repositories or centralized workflows are the most common and very useful, especially for group work projects. So for example, let's say that, let's assume that you have been tasked to set up a remote central repository for system administrators, programming from various departments in your organization to be able to work on a project called Recode. This is going to be stored under /blueprint/code/ on that server. So you first SSH into the remote server and create the necessary directory. Create a group called sysadmins. Add all project team members to this group, for instance, user admin, and then set the appropriate permissions on this directory. All right, so let's break down the steps and how you would do that process. Follow along if you dare. So the first step, type in the command set mkdir-p/blueprint/code/. Next step, type in group add sysadmins. For the next step, type the command set user mod -a capital G sysadmins admin. And for the next step, type in the command set chown :sysadmins-R/blueprint/code/. And then for the next step, type the command set chmod :770-R/blueprint/code/. And that brings us to initializing a bare project repository. So for this process, you might just use git init :bare/blueprint/code/recode. All right, so we have now successfully created a bare Git directory with a central storage facility for that project without much of a problem. Hopefully you were able to recreate that, or you followed along, or you watched and now you're going to try it. In any event, our next step is going to be to clone the Git repository. So to clone the remote shared Git repository to your local computer, we use SSH, and you can do that just by using the command set. It goes like this: git clone SSH : /admin@remote_server_IP : /blueprint/code/recode. Now, let's say that you want to clone to a specific directory, like your /home/Linux_trainer. Just use the command set that looks like this: git clone SSH : /admin@remote_server_IP : /blueprint/code/recode /home/Linux_trainer. So the first topic that we're going to cover in common infrastructure as code technologies is file formats. So this first subtopic, this is YAML, ain't markup language. YAML. So YAML, it's actually a data serialization language. It's user-friendly and very easy to read and write. But on the other hand, it's specifically designed to represent settings and data structures, and it works really well with modern programming languages. So I want to show you a peek at some of the main features of this particular language. And the first thing to know is that spaces and only spaces can be used for indentation in YAML syntax. And indentation is semantic as it is in the Python programming language, as it's used to describe structures and data trees. Document delimiters also are used. Triple dash and triple dot icons indicate the beginning and end of a document, respectively. Now, these are optional, so a YAML file can be perfectly valid even if these are not used. They become necessary only in certain special cases. These 3 dashes should be used when directives appear before a document. Directives basically consist of a percentage sign followed by a name and space-separated parameters. Now, currently only 2 directives are defined, percentage YAML and percentage tag. The triple dash symbol indicates the end of directives and the beginning of the document. And because a single file can contain multiple documents, only the ellipses or triple dot, followed by the instructions and or the triple dash delimiter, are used to separate them. Now, everything in YAML files is basically part of a dictionary because data is represented in the form of key values. YAML is case sensitive and keys must be unique. And let's see, finally, YAML files have to end with .yaml or .yml for their suffixes. Now let's get into data types. So we've got 3 basic groups of data types. These are scalar, list, and mappings, which are key value pairs. So the concept of scalar is expressing data that can be defined as a single value. For example, it can be a string, an integer, Boolean. So using scalars in YAML syntax is pretty straightforward. It could go like this: image, HTTPD, latest. But you got to notice here that you don't need to use quotes to define a string, right? Numbers, that is both integers and floating point values, are also easily represented. Age, 42, weight, 75.7. Now, Boolean values are not limited to only one representation. Yes, no, true, false, YN, on, off, etc. You can use any of these. For example, it could be like this: overwrite, no. And that's scalar. So that brings us to lists, because you can also create lists in YAML syntax. There are a couple of different ways to create a list. The first would be to create a structure that precedes its elements with a hyphen and a space on each line. So that would look like this, for example: list dash name dash surname dash age. The second would be to enclose its elements in a comma-separated square bracket. So here's an example of the second syntax: list space, open square bracket, name, comma, surname, comma, age, close square bracket. So now another way that we can define data is with matches or hashes, dictionaries. We refer to unordered sequences of key values as matches. And like we were saying before, everything in YAML is a member of a dictionary. So we can express it with an example like this: employees, name, John, last name, Tux, age, 49. So in this example, the keys first name, last name, and age are members of the same directory mapped to the values, John, Tux, and 49. Right? So the dictionary itself is the value associated with the character key. Now, just like lists, mappings can also be represented with an inline syntax using curly braces. So in this case, the keys and their associated values will be separated by a colon and a space, which is required. The mapping of the previous example can also be represented like this: employees, curly braces, name, space, John, comma, space, last, space, name, Tux, comma, age, space, 49, space, close curly brackets. Which brings us to another subtopic, and we're going to cover JavaScript Object Notation, or JSON. Now, these days, it's often preferred to represent data structures and to exchange data between different layers of applications, or to go through the use of API calls. So this uses the structure in Python, so you need to often have at least a basic working knowledge of programming languages, how they get used. But what if we need to interact with it from the command line or from a bash script? Well, there is something that we need to talk about here. It's the JQ utility. Definitely the answer to this question, so don't get too anxious. Here we are, the JQ utility, and it's actually available in repositories of almost all Linux distributions. So it's very easy to find, easy to access, easy to set up. We just need to use your package manager that is appropriate for your particular distribution. So for example, with the sudo apt install JQ command set, we will install using the apt package manager. Alternatively, you can use one of the other command sets, sudo dnf install JQ or sudo pacman -S install JQ or sudo yum install JQ. So this brings us to the second topic that we're going to cover in Common Infrastructure as Code technologies, utilities. So the first of the utilities that I want to go through here is Ansible. This is an IT engine that's used to automate IT tools. You can make application deployments, cloud storage allocations, and in-service arrangements. So obviously it's widely used. And some of the reasons for that is it's got simple installation, it's free, it's open source, and it's consistent and low consumption of resources. And it's also very secure with OpenSSH features. The basic concepts for Ansible include control node, managed nodes, inventory, modules, tasks, and playbooks 3. So in order to install Ansible on a Linux distro, Python must be installed first. So we'll continue with the Ansible installation because I'm sure that you have provided the prerequisite for your system. So first of all, we'll go to the terminal, run the command set, sudo apt-add-repository-y ppa:/Ansible/Ansible. And with this command, you can add the Ansible repository. And you might be able to update the system repository list. So for this process, use sudo apt-get update. All right, so once you're up to date, you can install the Ansible package. You can do this with a command set, sudo apt-get install-y Ansible. Very good. I want to show you the second utility that we're going to talk about here, Puppet. So Puppet's also an automation tool. Like Ansible, it's open source, used for configuration management. It's a little different. You use the Puppet descriptive language. And when similar tools, customized or individual codes get used, it's, well, helpful for system administrators or users who have made incorrect interventions in the system to check to see whether the changes that they've made are supported or not, or to reverse the change. So I want to show you Puppet uses the client-server model as its architecture. The server is called the Puppet Master. Clients are called Puppet nodes, and they run the Puppet agent software. Node runs a Puppet daemon to connect to the Puppet Master. So Puppet run starts with the NOTs, not the master. So this run uses SSL services to forward data packets back and forth between the nodes and the host. Nodes run the factor command to gather information about the system. Now these facts are then sent to the master. All right, so let's have a look at Puppet blocks. So our first block is resources. Now, many built-in resources are available, such as files, users, packages, and services. I'll show you an example resource. Resource_type, open curly braces, single quote resource _title, single quote colon, attr1 equals or greater than value 1, comma, attr2 equals or greater than value 2, comma, attribute 3 is equal to or greater than value 3, comma, triple dot, attribute capital N is equal to or greater than value N, comma, close curly braces. Our second block is manifests. So Puppet Manifest, essentially, it's a text document. Its task is to tell the latest status of the host system. It can be created just with the extension .pp using any text editor. Third block, classes. So it helps ensure that the Puppet resource definitions can be made more robust and reusable so they can be applied to multiple hosts. I'll give you an example definition. Class _name, open parentheses, $param equals, single quote value, single quote, close parentheses, open curly braces, source definitions, triple dot, close curly braces. Fourth block would be modules. So this is used to bundle Puppet Manifest and related files into a single file. So I want to show you some frequently used directories, and these directories will be manifest directory, file directory, lib/factor directory, and test directory. The manifest directory contains all the dummy manifests defined. The file directory contains static files. The lib/factor directory just contains special fact definitions. And the test directory functionality, test declarations. And the third of the values we'll review here is chef. We can define it as a configuration management technology developed to manage infrastructure in physical or virtual machines. Let's try to break down the components of the chef architecture. All right, the main components that make up the architecture of chef. We've got workstation, cookbook, node, and chef server. Now, the workstation is used to establish the interaction between the chef server and the chef nodes. It's also used to create, test, distribute notebooks, as well as to test code generated on the workstation. The chef server stores all the configuration data, cookbooks, recipes, and the metadata that describe each node in the chef client. Communication between the workstations and nodes is completely under the control of the chef server. Nodes configured by installing Chef Client on it are managed by Chef. Chef nodes can be physical, virtual, cloud, etc., and they all refer to a machine. Cookbooks, on the other hand, contain recipes that specify the resources to use and the order in which they ought to be used. The fourth of our utilities will be Salt Stack. Now, Salt kind of brings a new approach to infrastructure management. It can create a suitable infrastructure to keep up with a rapidly advancing technology. It can be commissioned in a very short time. The commissioning procedures are actually quite simple and scalable enough to manage thousands of servers. Thanks to its dynamic nature, it offers ideal data paths for orchestration, remote execution, and configuration management. Now, basically, a remote execution solution, Salt will have a Salt Master, a Salt Minion, Salt Key, and Salt Cloud components. And the fifth of these utilities we'll review is Terraform. Terraform is also a cloud orchestration tool. It supports public, private, and hybrid clouds. Terraform architecture is pretty simple. All you really need to do is download the Terraform binary to your local server machine, which will serve as your base machine. Now, like we mentioned before, for other utilities, we do need to express the syntax to run tools in our file. Then Terraform will actually download the plugin, execute the execute procedure, and request authentication. Terraform installation files come in a .zip format, and you can also easily install Terraform using appropriate package management tools. Which brings us to our third topic to cover in common infrastructure is code technologies, continuous integration, continuous deployment. It's often known as CI/CD. So CI/CD, it's a method. It's a method to frequently deliver apps to customers by introducing automation into the stages of app development. Main concepts attributed to CI/CD are continuous integration, continuous delivery, continuous deployment. All right, so CI/CD is a solution to the problems integrating new code can cause for development and operations teams, sometimes known as integration hell. So specifically, CI/CD introduces ongoing automation and continuous monitoring throughout the lifecycle of apps, from integration and testing phases to delivery and deployment. So taken together, these connected practices are often referred to as the CI/CD pipeline, and consequently are supported by development and operations teams working together in an agile way with either another DevOps or site reliability engineering SRE approach. So it can be fantastic. Now, what is the difference between CI and CD? Well, CI, this is always going to be used to refer to the concept of continuous integration, which is an automation process for developers. A CI refers to code changes, bug testing, and merging into common repositories for an application. Successful CI means that it passed these steps without any problems. CD means continuous delivery and/or continuous deployment, sometimes interchangeable, sometimes not, but it relates to automating later stages of the pipeline. Now, the goal of continuous delivery is to ensure that minimal effort is put into deploying new code. Now, in modern application development, the goal is to have multiple developers working simultaneously on different features of the same app. However, if an organization is set up to merge all branching source code together on one day, which is known as merge day, the resulting work can be tedious, manual, and time-intensive. And that's because when a developer working in isolation makes a change to an application, there's a significant chance it's going to conflict with different changes being simultaneously made by other developers. This problem can be further compounded if each developer has customized their own local integrated development environment, or IDE, rather than the team agreeing on one cloud-based IDE. Now, I don't have any emotions attached to this at all. Just learn from our experience. Continuous integration, CI, helps developers merge their code changes back to a shared branch or trunk, more frequently, sometimes even daily. So once a developer's changes to an application are merged, those changes are validated by automatically building the application and running different levels of automated testing, typically unit and integration tests, to ensure that changes haven't broken the app. So this means testing everything from classes and function to the different modules that comprise the entire app. See, if automated testing discovers a conflict between new and existing code, CI makes it easier to fix those bugs quickly and often. All right, so you want to know some of the common CI/CD tools. So these are the CI/CD tools used to automate development, deployment, and testing. Of course, some tools specifically handle the integration side, that's the CI side. Some manage development and distribution, CD, while others will specialize in continuous testing or some related functionality. Now, when we're talking about CI/CD tools, the first thing that comes to mind will be Jenkins, an automation server. Jenkins is designed to handle everything from a simple CI server to a complete CD hub. Tecton Pipelines provides a CI/CD framework for Kubernetes that performs a standard cloud-native CI/CD experience with containers. And of course, there are open-source CI/CD tools besides Jenkins and Tecton Pipelines. Another of these tools is Spinnaker, a CD platform built for multi-cloud environments. Another tool is GoCD. It's a CI/CD server that focuses on modeling and visualization. And of course, there are a couple of other tools, Concourse and Screwdriver. So I want to cover the fourth topic that we're talking about here in Common Infrastructure as Code is advanced Git topics. So let's have a look at some of the advanced Git commands. Now, under this heading, we're going to talk about the basics of commands that will take a little more time and require a little more practice. But of course, once you learn the basics, it's going to be easier to understand and apply. So the first command that I want to examine here is merge. Now, previously, our topics, we talked about branches and generating code and incorporating these code into the application. So the git merge command is a command that you can use to integrate changes from two branches into one. The syntax of the command looks like this: git merge branch name. So when you apply it, it's going to merge the branch name with your currently selected branch. And the second command will be rebase. So it has a similar function to the git merge command, and also git rebase rewrites the commit history. Now, if you want to merge both bases and branches into one, the command that you'll turn to will be rebase. The syntax of that command looks like this: git rebase and the base. Third command is going to be pull. So the pull command is used to download content and update your local repository with the latest content. And the syntax looks like this: git pull with your remote URL. Our fourth command will be pull rebase. So this command can actually be considered an option. Most of the time when you use git pull, you will need to merge with rebase. So you can use this option instead of using the two commands separately. The syntax of the command looks like this: git pull --rebase. And then with this command, you'll get rid of the hash in your commit history. You can also prevent multiple merges that are out of your control. All right, that brings us to our third title: Containers and Automation. And the subtitle is Container, Cloud, and Orchestration Concepts. So yeah, the first topic that we'll cover in Container, Cloud, and Orchestration Concepts is Kubernetes benefits and application use cases. So I want to first talk about the concept of pod. A pod gets formed by the use of one or more tightly coupled containers. So a Kubernetes pod is a collection of one or more containers making up the smallest unit of a Kubernetes application. Its main purpose is to increase resource sharing efficiency. So for this purpose, containers are grouped into Kubernetes pods. So in Kubernetes system logic, containers in the same pod should share the same compute resources. Computing resources are pooled in Kubernetes to create clusters, and this can provide a more powerful and intelligently distributed system for running applications. All right, might be a little complex at first, but I do want to continue with explaining the parts of the Kubernetes pod. So we need to first talk about hardware units. We'll talk about two hardware units, the node and the cluster. So you got to think of the node concept as a single computer, right? It's the smallest hardware unit in Kubernetes. A cluster is a grouped form of nodes. So the purpose of grouping can be explained as providing intelligent resource sharing and balancing. Now, perhaps you've already guessed, there are software units, and there are two basic software units: Linux container and Kubernetes pod. Linux container is a set of one or more processes. So these transaction sets contain all the files that need to be run. The Kubernetes partition is a kind of Linux container collection. It contains Kubernetes pods packaged together to maximize benefits of resource sharing through cluster management. Well, we can't go on any further until we talk about the concept of sidecars. So you can think of sidecar as a separate container running alongside an application container. So it's actually responsible for implementing the functionality and deployment test patterns required by all applications within a service network. One of the usage areas is to collect and format log messages from multiple application instances in a single file. All right, so now we can continue with the concept of ambassador containers. An ambassador container, it's also a kind of a sidecar container. It's responsible for proxying connections between the application container and other services. A client acts as a proxy, right? Proxy management is needed for proper routing of containers, efficient use of resources, as well as controlling data traffic. Which brings us to the second topic that I want to cover here in Container, Cloud, and Orchestration Concepts. We've got single node, multi-container use cases. Now, the main task of a multi-container is to manage auxiliary processes in their common areas, common functions with other containers that they work in coordination with. So pods use some patterns when running help processes. One of these patterns is the sidecar containers that we mentioned earlier. See, sidecar helps containers to parent containers. Examples of such containers are log stream monitors, change monitors, countable, etc., right? Now, the other pattern used can be counted as proxies, bridges, and adapters that connect the main container to the outside world. For an example of that, we've got Apache Web Server, for instance. Which brings us to our third topic that we're going to cover here with container cloud orchestration concepts. We've got container persistent storage. So, persistent storage, or non-volatile storage, is storage devices that retain data even after power is turned off. Persistent storage with containers is often used in stateful applications such as databases. Now, the lifetime of the container will be equal to the lifetime of the permanently stored data. So then, what are the types of persistent storage? Persistent storage can be used for data in order to be reused. Reuse can be for different instances or for use after a specific instance. Persistent storage units include containers and Kubernetes. Now, need to explain how persistent storage works with containers. Now, in this case, we've got three different terms. First term is persistent volume, or PV. PVs are the resources in the cluster. They have a life cycle independent of any individual capsule. We can refer to it as the physical unit on the host that stores persistent data. Persistent volumes can be provided statically or dynamically. So features such as performance, size, and access mode can be defined and customized for use. And the second term is persistent volume claim, or PVC. So PVCs can be explained as requests that regulate the control of demands for the resource. Last term is trident. So the trident provides a unified interface for expansion storage systems and storage provisioning in the Kubernetes persistent volume framework. Yeah, so let's run down a few persistent storage use cases. Now, it may be necessary to store the data that the applications need at startup or that the applications produce. The same data may need to be stored permanently for processes that need to be reused in raw form. We can talk about different methods for critical data that should be permanent, and that is the data that you want to keep. We can define our first method as data infrastructure management. So data infrastructure automation enables the agility to keep pace with evolving and changing IT systems as they rapidly expand and change. Multi-cloud, DevOps, and virtualization environments can be used for agility. And another method is the continuous integration and continuous delivery method. Right? Remember, this method is two software development approaches designed to improve code quality and ensure fast delivery and distribution of code. And the last method would be migrating traditional apps to the cloud. In current tech, in particular, the uninstall and replace approach paves the way for IT modernization by moving to open and more extensible architecture in the cloud. For companies, it means reduced cost, improved performance, and flexibility. Which leads us to the next topic that we'll cover here in container cloud and orchestration concepts, container networks. So Docker containers and services are very powerful because they can connect to each other and to non-Docker workloads. So it doesn't matter whether they are Docker workloads deployed or mapped to Docker containers and services. It doesn't matter which operating system is also installed on Docker hosts. So why don't we start talking about Docker networks and network components in a sort of rolled out fashion, if you will. Docker's network subsystem can be mounted using drivers. Several drivers are available by default, and they provide core networking functionality. The first of the network units is the bridge. And this is the network type that you create if you don't specify whether it's the default network driver. Bridge networks are typically used when your applications run in standalone containers that they need to communicate with. Our other network unit is the host. For standalone containers, the network isolation between the container and the Docker host is removed and exposes the host's network directly. Which leads us to another concept, overlay. This is used to eliminate the need to do OS-level routing between containers. Overlay networks connect multiple Docker daemons together, and we could describe this as a swarm service. So you can use overlay networks to facilitate communication between a swarm service and a standalone container, or between two independent containers in different Docker daemons. Another concept of our network is IPVLAN. IPVLAN networks give users full control over both IPv4 and IPv6 addressing. So after IPVLAN, there is MAC-VLAN. MAC-VLAN networks allow you to assign a MAC address to a container to make the container appear as a physical device on your network. Now, we need to talk about the none container. It's often used in conjunction with a dedicated network driver and won't be available for swarm services. And the last subtitle is network plugins. Now you can obtain, install, and use third-party networking plugins from Docker Hub or from other third-party vendors. Which leads us to the fifth topic that we're going to cover here in Container Cloud and Orchestration Concepts. We've got service mesh. So this is a configurable infrastructure layer designed for your applications in microservice architecture. So in this way, applications can communicate with each other more reliably, more flexibly, and certainly faster. Service mesh also provides you with a feature such as service discovery, load balance, encryption authentication, as well as authorization. Now, as the size and complexity of service mesh increases, it certainly becomes more difficult to understand and manage services running in this layer. Kubernetes is a solution developed to meet the requirements of the microservice applications that we talked about. In fact, we can call each part of an application a service, and the services that want to respond to the requests of the users make use of other services when necessary. Now, they also need to rely on other services for resolution. So this is where the main task of the service network comes into play. Service networks should also optimize the interoperability of all moving parts by routing requests from one service to the other. On the other hand, without a service mesh, each microservice must be coded with logic to manage service-to-service communication. I'm sure you might agree this coding process means developers focus less on their business goals. So we should not also overlook that it'll be more difficult to diagnose communication errors as the logic governing inter-service communication is hidden in each service. So adding a new service to an application or a new instance of an existing service running in a container complicates the communication environment and introduces new potential points of failure. In a complex microservice architecture without a service mesh, figuring out where problems occur is an intractable mess for the user or system administrator. So naturally, we want to avoid confusion. It'll be certainly a lot easier to resolve with a service mesh that evaluates every aspect of service-to-service communication with performance metrics, right? So over time, data made visible by the service mesh can be applied to inter-service protocols, resulting in more efficient and reliable service requests. So should a service fail, a service mesh can collect data on how long it takes to retry that service to succeed. When data on downtimes are collected for a particular service, rules can be written to determine the optimal wait time before retrying that service, thus avoiding overloading the system with unnecessary retries. Which brings us to another topic that we're talking about here in Container Cloud and Orchestration Concepts, bootstrapping. So when you consider the concept of bootstrapping in terms of computer science, we can define it as a method of producing a self-compiling compiler. Now, early versions of compilers are often called kernel versions, and they're built in assembly language. Later on, compiler versions are developed with existing programming languages, but are built on the core version. As we mentioned in the BIOS and boot issues, a computer system can boot in two ways, and these boot variants are automatic mode and manual mode. So if the system performs the entire boot procedure without external assistance or guidance, the process is called automatic mode. But in manual mode, however, the system initially follows the automatic procedure up to a certain point before most startup scripts are run, and then hands over the control to an operator. So up to this point, the computer will run in single user mode. Okay? So most of the system processes will not run, and other users will not be able to log in either. So to pass in multi-user mode, a bootstrapping process must go through 6 different steps. These are loading the code, then starting the kernel, detection and configuration of existing devices, creation of spontaneous system processes, operator intervention, and this is applicable for manual boot only, of course. Then step 5, execution of system startup scripts, and to complete, transition to the multi-user transaction phase. And that brings us to our 7th topic that we're going to cover here, container registries. So the most basic building block for container tools is the container's storage library, which locally stores and manages containers and container images. So the container's image library, this is one level above the container's storage library. This library, or image library, takes care of container images and is incredibly powerful. So it's going to allow you to pull and push images, process images, configure images, and review them with their layers, as well as copy images between so-called image transfers. Now, the image library also supports some configuration files, such as registries.conf, most importantly. So why don't we actually try to explain how to manage the container registry with this registries.conf file. So when you contact a container registry, push or pull an image, registries.conf is the configuration that comes into play. So for a configuration that will actually apply to all users, the location of the file is /etc/containers/registries.conf. Now, if you ever want to make any changes just for one user, you can create a new file at $home/.config/containers/registries.conf. All right, so the topic that we'll cover in Analyze and Troubleshoot Storage Issues is high latency. Now, in this situation, our first subtopic would be I/O wait, or input-output wait. Now, based on what we've done so far, and perhaps what you know already, we could say that Linux is a powerful and reliable operating system. Now, it offers various tools for troubleshooting. I/O waiting is a problem that requires advanced Linux tools and the use of some of the most basic tools together. But there are too many arguments to cause I/O wait issues. So that's why we'll need to choose tools that will produce a more specific result for us. Our preferred tool here should be able to limit the problem to one process, or at least a few different processes, right? So the problem that all users are experiencing or unlikely to experience would be a system slowdown. And the best command that we could use to find out if the I/O is causing system slowdowns is the top command. All right, so when we ran the top command, it listed 5 lines of information. And in the third line, starting with CPU, you can see the current CPU usage and what the CPU time is spent upon. You can also examine the I/O waiting as a whole with the top command. So which disk is affected by this issue? I can use the iostat command to find the answer to that question. And the syntax of that command would go like this: iostat-x37. See, so the -X option gets used for the IOSTAT command to print a detailed and extended report. 3 is used to print a report every 3 seconds. 7 is used for 7 iterations. Now, the first report's not going to give you very accurate information. It's going to print statistics based on the last time the system was started. Each new report printed will be based on the time elapsed since the previous interval. All right, so 7 reports. We requested a 3-second delay between each report. Now, in particular, I want you to pay attention to the device heading and the %util heading in the report. Right, so by looking at the values under these headings, you can determine which disk is used and at what rate. Now, the next command line tool would be IO-top. You can regulate the load of your system by detecting processes that cause high I/O. After running the IO-top command, you can easily see the program causing high I/O in the report you'll see on the screen. Now, this tool is very easy to use. However, it's not installed by default in many Linux distros. Sometimes the system may prevent you from installing this or a similar tool. So if you have installed the IO-top tool on your system, that's okay. What about anything else? Another problem that is pretty constantly encountered is overwriting some files. So to find the overwritten file, we will need to identify first which files certain processes are opening. And you can do that with the ls-of command. Now, once you have the open files list, it's going to be a lot easier for you to find the most heavily typed files. For example, with the command set ls-of-p, square brackets PID, it's going to be possible to print opened by a specific process, ID, the PID, right? The -p option narrows the output. Moving right along to this third topic that we'll learn here in analyzing and troubleshooting storage issues, we're going to talk about input-output operations per second scenarios, IOPS. So our first subtitle here is low IOPS. Now, storage units have an important place in the operation of systems, obviously. We here want to talk about the problems experienced in storage units consisting of disks, especially servers. Although the issue of disk I/O errors is not entirely related to the physical properties of the disks, we cannot ignore the limitations of the disks. As you may know, hard drives, except for SSDs, have speed limits. So when software wants to manipulate CPU or memory frequencies, hard drives are not going to be able to respond. So in other words, storage devices will create a bottleneck, preventing the server from reaching its full performance potential. Now, maybe an extreme example, but web hosting servers often experience this problem. Now, of course, disk I/O issues aren't the only cause of slow servers. So then how do we, as a user or system administrator, notice that there is a disk I/O error? Now, of course, as with any problem, there will be some symptoms in the system when there is a disk I/O error. Let's have a look at some of them. So if the sites hosted on the server are taking longer than expected to load, that is, if the website latency is increased, if the CPU and other components are overworked, that is, high I/O traffic creates a high server load, if you receive an overload message from the system, if slow data delivery and reception or user interface freezes occur during operation, we might just have a disk I/O error. Now, I say let's talk about this because there's absolutely no certainty. These problems can also be network or CPU related. But it is very important in terms of time and cost that you correctly identify the cause of poor performance. An I/O bottleneck, is it a network lag, or is it a CPU issue? Now, in order to make this determination, we're going to first go to the command line and use the top command. Our first goal here is to detect if the CPU is waiting for disk operations to complete. Now, of course, you recall, right? The top command listed server statistics and running processes. What will interest us the most will be the WA value. Remember, the value represents I/O wait as a percentage. So I/O wait is one of a series of processor activities in line, starting with %CPU. You can also see the US, the time spent on user processes, the SY, the time spent on system processes, and the ID, or idle time. Now, let's just break down a little bit more how to interpret the WA value. Now, first of all, I got to tell you that it's actually pretty easy to interpret in single processor systems. If the WA value is between 0 and 1, we can accept it to be normal. If the value is above 1, it means that the hard drives of the server are having trouble supplying data to the CPU. So, what do we do if we have a multi-core system? Well, you're going to see the WA value for each core separately. And then, when you add all the WA values and divide by the total number of cores, well, you can go ahead and interpret that according to the average WA value that you get. Now, it's not that any WA value is greater than 1, but that the mean value is greater than 1. That's going to indicate a problem. So the WA ratio, or I/O wait times, may not always indicate an I/O bottleneck. So we are going to need to obtain some more reliable information by doing a little bit more research. And another tool that we use for this purpose will be vmstat. So let's just run a command with a syntax that goes like vmstat37. Now vmstat will give you 7 readings at intervals of 3 seconds. So the first line, as usual, lists the average I/O stats since the last reboot. The column that we're going to need to pay attention to in the report list will be I/O. And during the test that you've done, you can observe the amount of data written to and read from the storage device. And you can decide the stress rate of the system just by looking at the values. Now, why don't we determine which driver is under load? Yeah, you can do that with the iostatmd command. So the -m option indicates that it will display the amount of data per second in megabytes, and the -d option indicates the device usage, %util, is taken care of. So when the report is examined, you can decide whether the source of the problem is excessive disk I/O by examining the amount of data written to the disk per second and read from the disk per second. All right, so let's say we identify the affected drivers. Then your next task will be to repair disk I/O problems. And then, of course, the simplest solution that would come to mind might be to increase a hard drive or memory capacity. There are a few hard drive configuration settings that you can make before making such physical changes, however. So the first would be turn on the write cache. So turning on write caching, which contributes positively to performance in some applications, should generally not be preferred except in very specific situations. You see, the write cache collects data for multiple writes in a RAM cache before permanently writing it to the drive. Of course, data loss can be inevitable if the server is powered off before that data is written to disk. So one of the utilities that we can use to easily turn the write cache on or off is hdparm. So it's not usually installed by default in Linux distros. You can always start to use it by installing it with your package installer. So for example, you can use a command set that looks like this: apt install hdparm. So you can use the instruction set hdparm-w1/dev/sda to turn on the write cache. And if you want to turn off the write cache, just use the opposite instruction set, hdparm-w0/dev/sda. So the second is to turn on the direct memory access state. As you may know, this process allows components to reach RAM directly without going through the CPU. You can use the hdparm-d1/dev/hda instruction set to enable DMA, and the hdparm-d0/dev/hda instruction set to disable it. But I do want to make an important point here. DMA is not available on some servers, especially virtual servers. Now, a third option might be to upgrade the server hardware. So if these settings don't fix the problem, you may want to consider upgrading, replacing, or refactoring the hardware. Hardware improvements that you can make include changing the hard drive by prioritizing capacity and RPM. Using SSDs will certainly be a very good choice. Make the application load more balanced by sharing the workload among the hard drives by adding more hard drives. Increase RAM capacity. That's going to allow more data to be cached at the same time. So thanks to the data in the cache, applications do not need frequent read and write operations. Now, if you are using a hardware RAID, check the RAID array. A failing RAID controller will adversely affect I/O performance. All right, so let's have a look at the fourth topic that we're covering here and analyze and troubleshoot storage issues. We've got capacity issues. So let's talk about inode exhaustion. In the Linux operating system, information about a file, the creator of the file, the date of creation of the file, the size of the file, all this. In other words, the file meta information is stored in the block. So this field, which is used to store file meta information, is called the index node, or inode for short. All right. Index nodes are kept in a table and store the information of the file they belong to with a much smaller capacity. So for example, 10.25 gigabytes of an 80 gigabyte hard drive is used. So let's take a hard disk, and when you format the hard disk, the operating system splits the hard disk into two parts without your request. And the first part's going to store the file data, while the second part is the inode table containing the inode information. So using inodes is similar to using storage spaces, though. When the storage area is full, it cannot create a new file, or some commands won't be responded to normally. But on the other hand, when nodes run out, there may still be storage. However, the inode tables are full because many small files have been created. So, of course, the opposite is also possible. When you run out of storage, there may be plenty of room in the inode table. So this is often much easier to spot and actually can be ignored. But it brings us to the df command. This is what we use to check the usage status of the inode table and the disk usage status. You can see the usage status of your disk when the df command gets run, while you can view the usage status of the inode table with the df-i. Which leads us to the fifth topic that we're going to cover here with analyzing and troubleshooting storage issues, file system issues. So here I want to cover some of the subject of controls in file systems. The command line utility we will use here to perform consistency and interactive repairs to the file system will be fsck, sometimes referred to as fsyscheck, fscheck, fisc, physic, fsic, fsoc, but really there is no agreed upon pronunciation. That's why pretty much you want to pronounce it fsck for file system check, or fscheck. All right, so anyway, you can use this fscheck utility to repair corrupted file systems, especially when your system cannot boot or a partition cannot be mounted. Syntax of the command goes like this: fsck, in square brackets options, in square brackets file system. So this advances the checking process on the specified file system. Now, if no file system is specified as an argument, fscheck checks the devices listed in the fstab file. And you'll also hear fstab. Anyway, don't ever use this utility on mounted partitions. In fact, to prevent such irreversible damage, you should unmount it before you start checking or repairing file systems. Excellent. So the sixth topic that we're covering here in analyze and troubleshooting storage issues is the I/O scheduler. So the I/O scheduler is a kernel process that regulates how I/O requests are sequenced. So for individual users, there are no major problems with I/O requests. If there are some inspections of the CPU, memory, and hard disk drive may resolve the issue. But if we're having the problem on a Linux server, CPU and memory are pretty good. The problem's usually the storage channel. On today's systems, there are too many factors to determine the operation of storage channels with a very complex management structure. So in short, storage performance depends on many factors, only one of which is the I/O scheduler. Now, there are a few timers out there. The most commonly used timer were CFQ, or completely fair queuing, NOOP, anticipatory, and deadline. These are the most popular. However, anticipatory was used in older kernel versions. Let's run through them. CFQ organizes the queue by assigning different time slots to requests based on I/O priority. There's a time slot at the end of each transaction. Although this interval is determined to optimize issues such as opening a new queue, waiting for a new request from the process, etc., it can be reconfigured as the first variable, and that is considered when performing performance tuning. NOOP. So this scheduler is the simplest one. Its work is based on being thrown into the tail on the principle of first come, first serve. So such an operating mechanism can only be effective when the host system is not aware of the priority of incoming requests, or for disks such as SSDs, where the position of the disk head has no effect on read-write efficiency. Well, because there is no disk head. Yeah. Anyway, the reason why anticipatory timer has been removed from the kernel since version 2.6.33 is that its tuning mechanism and performance increase can be achieved with newer versions of CFQ, and the hardware type it serves is particularly limited. There is deadline scheduler, and this one differs from the others in that it can give a request a deadline. So it uses two different queues for read and write operations. So thanks to its ability to give a deadline, it is aimed to prevent the productivity of the main process that started the process from decreasing due to not knowing how long the processes will wait while waiting for read-write I/O. Now, the above-mentioned settings can be rearranged via sysfs for performance optimization. Check out FIFO_batch, in parenthesis, INT, close parenthesis, comma, read_expire, in parenthesis, int, comma, write_expire, in parenthesis, int, comma, write_starved, in parenthesis, int, comma, front_merges, in parenthesis, int. All right, so let's address the role of the I/O scheduler in performance optimization. Now, multiple I/O schedulers are available in the Linux operating system. However, the kernel does not have the ability to choose the most performing scheduler for you. So for this reason, depending on your intended use and how much performance you actually want, you should be able to select the I/O scheduler for the relevant disk volumes whenever necessary. So say, for example, you have SSDs in your own notebook. Well, you can simply use NOOP, deadline, or NOOP for guest systems and virtualization. And if you don't know what to do, you can always use the default CFQ scheduler. Now, if you do want to see what timers are on the system and what is being used, you can run the cat/sys/block/sda/q/schedule command set, and the active timer is displayed in square brackets. And we arrive at the seventh topic that we're covering in analyzing and troubleshooting storage issues. This is going to be device issues. So it's another type of problem that you might encounter, PCI card issues. The lspci command is used to view PCI and PCI Express cards in Linux operating systems. Now, of course, this command also has many options, and it's used to display different information about these cards as well. Let's have a look at some of the options. The -A defines a method to access PCI information. The -B displays connection information by card. The -K displays kernel driver modules for the PCI card in use. The -M displays information in machine-readable format. The -N displays vendor and device information as numbers instead of text. -Q will query the central PCI database for information about PCI cards in use. -T will display a tree diagram showing the connections between cards and buses. -V will display additional and detailed information about cards. And the -X will display a hexadecimal output dump of card information. Now, of course, you've heard of a universal serial bus. Well, this is the concept that has made our lives a whole lot easier for quite a while. Now, you can connect many different devices to your system using that USB port. But a computer system must have a standard USB hub to be able to connect USB devices to the USB controller. Now, Linux distributions include the device drivers necessary to communicate with each of the USB hubs. So in this way, when the USB device is included in the system, Linux system detects the device and associates it with the required driver. The ls-USB command and its options are going to assist you in viewing information about the USB devices connected to your system. Why don't we have a look at the options? So first off, we have -D, which will display only devices with the specified vendor ID. -D displays information only from devices with the specified device file. -S will give you information only from devices using the specified bus. The -T will display information indicating related devices in a tree format. And when you use the -V, you'll get a display of additional information about devices. And the -V will display the version of the ls-USB program. Now, just like in other operating systems, controlling the display interfaces is an important part of the Linux operating system. Running under the graphical desktop environment on a Linux system, X11 interacts with the hardware level of a system's video environment. You know, the video card, the monitor, keyboard, mouse. And it provides a standard interface that any desktop management software can use. X11 actually has a couple of different implementations used throughout Linux. There is X386 and X11.org. Now, X386 is the original X11 build for Linux, and it's kind of difficult to configure for different video hardware. X11.org is a simple text-based file, and that can be easily configured by users. In fact, X11.org tries to automatically detect the video-related hardware installed on the system at every boot. It actually dynamically changes the configuration files when it encounters a change. Now, both application packages store their configuration files in the /etc/x11 directory. But different drivers are going to be included that support common video cards and monitors. However, if your video card or monitor is not recognized, packages will default to generic drivers that usually don't produce the best quality video. If you are using a dedicated graphics card or a particular kind of monitor, well, you're going to need to obtain those Linux drivers for them and install them manually. Not such a big deal, but something to be aware of. Now, another indispensable tool in the office environment is the printer. Printer configuration troubleshooting in Linux involves dealing with different types of printers, installing the correct printer drivers, and using the correct printer protocol to communicate. Have no fear, there is something called the Common Unix Printing System, or CUPS. CUPS typically solves many of the problems by providing a common interface for working with virtually any type of printer within a Linux system. So it's going to allow you to accept and start jobs using a print queue structure. So print queues are repositories that hold jobs sent for printing together. It's built to support a specific printer, but they also support certain print formats, such as landscape or portrait mode, single-sided, double-sided, that kind of thing. Now, of course, there can be multiple print queues, and these can be assigned to a single printer. There may also be multiple printers that can accept jobs assigned to a single print queue. Now, typically, I don't recommend using the CUPS interface to set up a new printer. Open up your browser and go to the URL http://localhost:631/. So if you don't see the CUPS main web page, just run the sudo system control status cups.service command set and have a look and see if CUPS is actually enabled. If CUPS is not found, you will need to install the CUPS package. If CUPS just isn't enabled, you can enable it just by using the sudo systemctl start cups.service command set. Now, using the web interface, you can actually define new printers, replace existing printers, check the status of print jobs sent to the printer, and configure network printers using several standard network printing protocols, such as IPP, Internet Printing Protocol, or Microsoft Server Message Block, SMB protocol. But like I said earlier, just remember, I recommend not using the CUPS web interface to set up a new printer. So we've got several command line tools for interacting with print queues, and these include LPC. So it's used to start, stop, or pause the print queue. LPQ is used to display the print queue status. LPR is used to send a new print job to a print queue. LPRM, this will remove a specific print job from the print queue. Now for each of these commands, you can use the -P command line option with the printer name to specify the printer. Now Linux as an operating system supports hot pluggable devices. I'm sure you know computer hardware can be divided into a couple of different parts. Cold pluggable devices, and these can be plugged in when the system is completely shut down. Hot pluggable devices refer to devices that can be plugged in while the system is running. So a few examples of cold pluggable devices: RAM, PCI cards, hard disk drives. Examples of hot pluggable devices: external devices like network connections, monitors, USB devices, that kind of thing. Now the task of detecting dynamic devices in Linux is given to the UDEV device manager. Now automatically at boot time via script /etc/rc5.d/udev, or it gets started by the systemd, system running in the background. You can interact with the UDEV program just by using the udev adm command, and you'll be able to troubleshoot problems encountered in dynamic devices with Linux. The syntax of the command goes like this: udev adm command with options. So udev adm produces different solutions with many commands. The first of the commands that I want to take you through that can be used with udev adm is a control command. You can actually change the internal state of udev with this command. For example, just by adding the -R option, you can force udev to reload the rules defined in the /etc/udev/rules.d directory. Another useful command is info, and this command queries the udev database for device information. Another useful command is monitor. This command listens to and displays kernel events. Another command is settle. So this command monitors the udev event queue. Yet another command is test-built-in. So this is used to run a built-in device command for debugging. And the last command here is trigger, and this is used to request device events from the kernel. Moving right along to our 8th topic that we're covering in analyzing and troubleshooting storage issues is mount option problems. Now, as you may remember, we talked about network file systems, or NFS. It's a protocol that allows a system to share directories and files with others over a network. So let's check out our main command. Troubleshooting NFS connection issues. It's a very important issue, especially for support workers. Of course, depending on the client and the problem, a wide variety of error messages may appear when attempting to mount an NFS share. We're going to talk about some of these error messages as well as their solutions. Error 1. Mount Mount to NFS server failed, system error, no route to host, or route to host, depending upon where you're from. So this error message may be caused by RPC messages filtered by the host firewall, the client firewall, or a network switch. So you need to first check to see if a firewall is enabled and if NFS traffic is allowed. Normally, NFS uses port 2049. You should also check the server's show mount output and verify that the file system has been exported for the client IP. You can do this using the command set show mount-e NFS server IP pipe grep-i client IP. Then you should check the port of the NFS server using telnet. And you can do this with the command set telnet NFS server IP 2049. Then we come to error 2, and the mount NFS can't mount because RPC prog.dot is not available. This error is port mapper failure, unable to receive. So the Linux NFS implementation requires both the NFS service and the port mapper, that's the RPC service, to run on both client and server. So you can check up on that using RPC info-p for your command set. Error 3, you'll see the error NFS stale file handle. Now, unlike traditional Linux file systems, which allow an application to access an open file, even if the file's been deleted using unlink or rm, NFS does not support that feature. So an NFS file is deleted immediately. Any program that tries to do more I/O on the deleted file will get the NFS legacy file handle error. For example, if your current working directory is an NFS directory and it's been deleted, you're going to see this error at the next shell prompt. Error 4, the error is access denied or permission denied. So then you check the export permissions for the NFS file system, and you can do that from the client using the command set show mount-eserver_name. All right, so it brings us to our fourth title, troubleshooting, and the second subtitle, analyze and troubleshoot network resource issues. So first things first, we're going to talk about, and analyzing and troubleshooting network resource issues is going to be network configuration issues. I might not need to tell you that network issues may require more effort as they involve a larger area than other hardware issues. A problem in the network may be one of many network elements throughout the network. So before you start troubleshooting a problem that you've identified, you're going to need to have a clear understanding of what the problem is, how it came about, who it affects, and how long it's been going on. So gathering the right information and clarifying the problem is going to save you a lot of time. See, that way you'll actually be able to avoid unnecessary interventions. So I want to walk through a little bit of this troubleshooting process step by step, and it'll help you diagnose and fix an issue. Now, of course, the first step would be to check the related hardware. So you have to confirm that the network elements are properly connected and the devices are turned on and working. The device may be out of power, cable might be disconnected, or a network device might be locked. In particular, check the cables first, visually and then manually. Make sure the switches are in the correct position. As you may know, network equipment, like many IT devices, can only be reset to return to normal operation. So turn off your network equipment, wait for a little while, and turn it back on. Although it may seem like a very simple solution at first glance, it usually solves many problems. There's many jokes about it, even t-shirts, maybe even a bumper sticker. Anyway, for step 2, use the ipconfig command on the command line. So you can check if your computer has a valid IP address. So for example, if your computer's IP address is 169.whatever, when you run the command, it's going to mean that your computer's not getting an IP address, right? So if it starts with a number other than that, it means it has a valid IP address. All right, so for step 3, use the ping and tracer commands. That's on the command line. Now you've confirmed that your router's working If your IP address starts with a number other than 169, the source of your problem is between your router and the internet, so it's time to use the ping command. For example, you can ping Google DNS servers just by typing ping 8.8.8.8 on the command line. Now, if you have detected an error, so in other words, if you don't get a positive response to your ping packets, you can display every hop between your router and Google DNS servers by typing trace RT 8.8.8.8. By following along the way, you can identify where the error originates. And for step 4, you can check DNS access. You will need to go to the command line and use NSLOOKUP for your command to determine if there is a problem with the server you're trying to connect to. So for example, if you do a DNS check on google.com, you'll get results like timeout, server error, denied, no response from server, or network unreachable. Well, then the problem is with the DNS server for your destination. And for step 5, check the ISP. If you could not find a solution as a result of the examinations and the other steps, check to see if there's a problem with the internet service provider. Examining the interruption maps will be another solution method. And step 6, check the virus and malware protection installed on your system. Check if any changes have been made to the protection system, and those might affect the operation of your network system. Although I actually don't recommend it too much, you can also test by disabling security measures for a short period of time, especially for systems with individual users. Which brings us to the next topic that we're covering here in analyzing and troubleshooting network resource issues, interface errors. So here's a new subtitle, Drop Packets. When packets get dropped on a computer, they are dropped for a particular reason, but users don't even notice the drop packets. In fact, let a packet enter your computer's RX network stack on port 8000, the application listening on port 8000 crashes before getting it. So you send a packet, TX, it crashes before it leaves your computer. So packets are dropping and you'll have a hard time detecting them with normal command line applications for determining why. Perhaps the best utility, though, for the process that we're talking about is DropWatch. You can actually get it from GitHub. You just click on this URL here or search for DropWatch. And you can run this utility with the command set sudo /dropwatch-lkas. And you'll have a look at your dropped packets. So moving right along to collisions. Now, I wonder if you remembered that we mentioned earlier, we use the netstat command to check the network status. So by using this command, we can get statistics about the status of network interfaces, routing tables, various protocols, and the syntax for the command looks like this, netstat with options. So then what are these options? Well, I'll show you a few. The -I gets used to display the state of TCP/IP interfaces. -R is used to display the IP routing table. -S is used to display UDP, TCP, ICMP, and IGMP protocols. Now, if you do want to display the state of the interfaces that are used for TCP/IP traffic, you may use netstat-I for your command set. Now, on the screen here, you may see the number of packets that a machine's transmitted and has received on each interface. If a machine has active network traffic, it should show both I packets and O packets. These are values continually increasing. Now, to calculate the network collisions rate, you need to divide the number of collision counts, COLLIS, by the number of out packets, O packets. And then a network-wide collision rate that is greater than 10% is going to indicate a problem. To calculate the error rate for the input packets, you should divide the number of input errors by the total number of input packets. L errors or divided by L packets, PKTS. Now, to calculate the error rate for the output packets, you really do need to divide the number of output errors by the total number of output packets. So in other words, O errors divided by O packets. For example, if the input error rate is over 0.20%, well, the host might be dropping packets. So if you display the IP routing table with netstat-r, you will see destination, gateway, flags, and interface for fields. And under the flags heading, you can see U, G, H, and D flags, or a combination of those flags. U means that the route is up. G means the route is through a gateway. H means the route is to a host. D means the route was dynamically created by using a redirect. Interface is used to list the network interface that is used for the route. All right, so our fourth title here in troubleshooting, our third subtitle, Central Processing Unit, CPU, and Memory Issues. Yeah, that's a lot to cover, huh? That's okay, we'll break it down. The first topic that we're going to cover in analyzing and troubleshooting network resource issues is CPU utilization. Now, of course, not only in Linux operating system, but in all server applications, the CPU specifications must be above a certain level in order for the server system to respond to the demands. Right? So otherwise, upgrading the CPU may be a solution. But on the other hand, the CPU may not be used efficiently. In order to detect a problem originating from the CPU, first of all, the number of cores, whether hyper-threading is used, cache sizes, etc., these need to be determined and examined. Now in Linux, you can use the less utility to access this data. You can get information about the CPU and its parts just by typing less/proc/CPU info right there on the command line. Then the next step would be find out CPU usage, system uptime, and CPU load average. And the command that we would use for that process will be uptime. And you see this displays the average load number of 1, 5, and 15 minutes with the uptime command. And you can also use the syscontrol utility to change certain kernel parameters to improve CPU performance. So by load, the average is meant the average amount of processes that are waiting or using the CPU. So if this value is above 0.70 on a single core processor, this is going to indicate a serious problem. Levels of 1.00 indicate an emergency. You follow? Which brings us to the second topic we're covering in Analyze and Troubleshoot Network Resource Issues, Memory Utilization. I'm sure you know, random access memory, RAM, basically used to temporarily store the data needed by the system and the applications running on the system. Now, this method is actually much faster than reading and writing from persistent storage. Data gets transferred from a one-time hard storage drive to RAM, and it's used in subsequent accesses, significantly increasing performance. So if you want to view detailed information about system RAM, you can use the /proc/meminfo file with your text editor. If you want to view the shared memory partitions, you can use IPCS-M for your command set. In fact, you can also view memory stats on a system with the command line utilities such as free, SAR, and vmstat. But I'll tell you, though, another source of problems regarding memory issues is memory swap spaces. So when the system needs more memory than, well, what's available, it uses swap spaces defined in a special partition of the hard disk drive called swap space, or swap, or virtual memory. So if you need to view information about available memory and swap spaces, the total size, used, free, shared, buffered, cached, what's available on your system, well, you can just go to the command line and run free-h for a command set. But I'll tell you, another really useful utility is vmstat. And this utility allows you to view the swap-specific disk I/O, as well as the total blocks to and from the device. the swap on-s command set. This is used to determine if the swap is a file or a partition. You can also use the same information from the /proc/swaps file. Now, in Linux systems, swap space is either a partition or a file. So it's recommended not to store your swap partitions and files on SSDs due to their limited lifetime and wear level, as heavy swapping is going to cause premature SSD death. Just don't take that lightly. Okay? Anyway, during the installation of the operating system, a swap partition or swap file is usually created. And the swap volume will be added to the /etc/fs tab configuration file. Now, RAM memory increase in your system may require you to create an additional swap unit. If your swap partition is on a logical volume, you can add additional swap spaces using LVM tools. And that brings us to the second topic that we're going to cover in Analyze and Troubleshoot Network Resource Issues: Recover Root Password. Now, just like in other operating systems, the username and password information of the users are, well, considered the most critical part of the security procedures, right? One of the most common problems is going to be forgetting the root account password. Linux offers, though, several options to solve this problem. First method would be resetting the password using the account's superuser privileges with the passwd command. However, this method will not work if you use the root account to gain superuser privileges in the first place, or if your privileges do not allow you to change the root password. But this is how it's generally used. So our second method would be to start the system in single user mode and allow access to the root account and password change with the passwd command. So if you want to perform that operation, first boot or restart the system. Meanwhile, when the boot process reaches the boot menu, press the E key on the boot menu line that you want to edit. So find the line containing Linux or Linux 16 with your arrow keys. Go to the end of the line, press spacebar once, type 1. Press Ctrl and X to boot the system. That way, when the system boots, press Enter if it indicates you are in emergency or recovery mode. Then change the root account password with the passwd command. Then you got to restart the system with the reboot command.